All right, well, thank you all for coming here despite our beautiful storm yesterday in Minnesota. We wanted to give you guys the authentic experience. I'm actually not the one kicking this off. That would be our office director, Jeff Brunner. He's actually also our research manager. I'm not going to take any of his time. I'll let him kick us off here.
Thanks, Kyle. Welcome, everybody. Very glad that so many showed up with our snowstorm. 6 to 8 inches is kind of normal around here, but we get a lot of crazy idiots. I get that it's winter driving rules, so pleased to have you all here. Pleased to have everybody online. I'm excited about to have everybody back face to face. We haven't had that now for 3 years. And I think the conversation is better. There's a lot more collaboration maybe that happens around the coffee and the bagels back there. But, as Kyle mentioned, I'm currently acting as office director. Glenn Engstrom, who you may have known, retired 2 months ago. They're in the process of filling that in a more permanent position, so I'm just temporary. And I would expect they'll be naming a new office director here in the relatively near future. So in the meantime, I'm doing a little double dipping. But in regards to the DPS, I do want to thank all of you, one, for being here, but especially to my staff, Di, Mercedes, and Kyle, for their efforts over the last 2 years. It's been really fun watching it, having discussions with them about it, how to move this effort along. I'm a big champion of it. I know Glenn was a big champion of it. We think there's great promise in it. And thanks to all of you guys, you're all contributing and doing your efforts back in your states too. Just a few logistics before we get going. There is a sign-up sheet if you can take time today to sign up back on the table there. We do have coffee and rolls. Feel free to get up and do that. Mercedes wanted me to let you know that we are recording this, so everybody be aware you are recording it. If you need bathrooms are out the door just to the right. And if you need to handle a phone call, there's a little lobby out there. If you need a private conference room, maybe touch base with me or Susie up at the front desk if you need to have a private conference room for some kind of any kind of meeting or whatever. But that's about it for me. Is there anything else, Kyle, Di, that I should be sharing? All right. Thank you all.
Maybe just a quick check if the audio is coming.
Question for the people online: are you is the audio coming across well where everybody can hear us?
Yeah.
Great. Thank you. If not, if you're losing audio or whatever, put something in the chat and we'll try and get things improved on this end. Thanks.
Thank you, Jeff. I want to echo what Jeff said. Thank you, everybody, to devoting these 2 days to come to this meeting, and particularly in the winter time in Minnesota. This probably is the biggest snow we got for this year so far. You brought us snow. Well, let's just go around the table first, introduce ourselves, and also to online. My name is Chung Tao Dai. I'm a research operations engineer in the Office of Material Research. I'm responsible for research group in the payment evaluation and the material testing.
I'm Kyle Voigt, a research engineer at Minnesota Department of Transportation and the project manager for this cool fund. And let's see, I'd like to think of one thing I'd like to get out of this 2-day meeting would be to try to hopefully get some active discussion. I hope everyone feels comfortable if they either don't understand something or something doesn't seem right, to just speak up. You know, that's one of the great things about being in person is we can try to clear things up that are a little bit harder to discuss virtually. But then for you, people who are joining remotely, there's a chat there for a reason, and maybe monitoring the chat So I'm just excited mostly to get feedback from all the people who are joining us here today and tomorrow. And if you introduce yourself and your organization, you can also share anything you want, whether it's what you want to get out of the meeting or something that you just want the group to know. So thanks.
Hi, I'm Mercedes Kuznia. I work for MnDOT, the Materials and Research Group.
Roger Roberts, GSSI. I'm deeply involved in the gifting areas. I'm real curious to hear everybody's experiences here today. What works, what doesn't work, what we can do.
Ryan Most, Maine DOT, Destructive Testing Supervisor. I'm just looking forward to getting everyone's feedback today and seeing what's working for everyone else.
I'm Steve Cooper, Federal Highway Resource Center for the pool fund. I'm the Federal Highway liaison. That's there. And for me, I personally would love to hear your thoughts on where we go in the future on this.
I'm Ulrich Amsugenu. This is a video with the session commission of the CPDP. I'm here as a human to learn more about the project, see what we can everyone is.
Tom Barner, Field Materials Engineer for Missouri DOT. Brendan Ryan from New York State DOT Materials Bureau. I had our non-destructive evaluations.
For Duquette, Fire ELD Consulting, curmudgeon in training, probably the first contractor involved with MnDOT and implementing the DPS, and also chairman of a TRB workshop on DPS and effective utilization.
Morning, Rich Hamilton. This is on from Advanced Testing. New York, here to learn about data analysis for DPS.
Well, Andy Baskin from Georgia DOT, Office of Material Testing.
Jacob Walker, Georgia DOT, from the Office of Materials and Testing and our Technical Assistance Engineering Unit. We're evaluating the RDM and NDM for how it can be used in Georgia. Georgia is currently not a member of the pool fund, but we're looking to become a member of the pool fund.
Our DM machine a couple years ago, we're still in the process of getting it up and running and evaluating it, so we're going to learn, basically absorb as much information as we can to help us in the process.
Corey Beckham, UDOT as well. I'm the construction inspection program manager for the department, and as well, we're trying to learn as much as we can.
I'm Brian Nagel with Caterpillar Paving Products. I have global sales support responsibility for compactors and technology. So really looking forward to just hearing everybody's perspective on where the industry is going, where we see value, and figure out how we can help get that in.
Todd Mansell with Caterpillar. I'm looking forward to hearing what's been happening and kind of just getting an update on where we're at and seeing a little bit of data and maybe how that correlates with existing precedent.
I'm Matt Oman with Mandy Construction. I've done a fair bit amount of testing with this device, so it's here to share some of that.
I'm John Stork. I am a research engineer from North Dakota. Looking to see how other states are handling some of the challenges that we've been facing.
I'm Pete Eckman with the Minnesota Division of Federal Highways Pavement Materials Engineer. I'm interested to hear what folks have to say, what their thoughts are on this, and also just to see how we can move this forward. Thank you.
Howdy. Good morning. I'm George Chen with Transit Group. I'm the developer for Beta software. We have implemented features to import and view and analysis for DPS data. I would like to hear more about what's your wish list for the new feature for Beta.
John Siegmeyer, Minnesota DOT. I was trying to learn more.
I'm Katie Johnson. I'm with CTC and Associates, and I'm taking notes today.
I get to him later.
I'm Amanda Gilliland with the Transtech Group, so I work with George. So I do beta support, work for our technical support center. Super passionate about this technology. And I have seen a lot of good data where we have, intelligent compaction and thermal profiling and DPS all in one program, and seen kind of how powerful that is and how much it can tell you about a project and quality. So just excited to help promote that any way I can.
Morning, I'm Matt Pan, University of Nevada, and I'm all ears.
Okay, thank you, everyone. I really appreciate you active participation in this project and also the contribution to this project. I think, in my view, this is a very successful project. And we started with the 10 agencies joined the study at the beginning of the project. Federal Highway Plus and other 9 states. Now, over the 3 years, we gained more membership. Now, have 4 additional states join the study. So that's because you active participation and also engagement and also promotion to this project. Of course, Kyle and Mercedes have done a great job. So we're individuals working on this project. So I just want to take this opportunity to highlight some major results, just refresh somebody's memory, somebody probably still new to the booth. Well, okay, before I do that, let's quickly go over the agenda for this 2 days meeting. So you can see, look at the full agenda for these 2 days. And the first day, which is today, we're going to hear the update from the full fund study. And also, we're going to hear from the contractor's perspective. And that is, yeah, some other contractors coming later online. But to talk about this, their experience and this device, and also the data collection experience. I'm sorry, I forgot to go online for the introduction. Is anybody online? Introduce yourself.
Larry Riggleman, Office of Materials, Maryland State Highway.
Forrest Kierholzer with Granite Construction, quality engineer, and have tested out the DPS a little bit for ourselves.
Good morning. This is Monica Jurado with the FHWA Resource Center.
This is Craig Londefeld with Ohio DOT.
Good morning. This is Foda Azadi with Federal Highway Administration. I'm a DE Program Manager. I'm glad to be here virtually.
Jason Simmons, UDOT State Paving Engineer.
Hi, I'm Julie Miller with the Ohio Department of Transportation. I'm working with Craig Londefeld and Bill Feehan.
Good morning. I'm Lisa McDaniel with the FHWA and the Iowa Division.
Good morning. I'm Dennis DeVork with the Federal Highway Resource Center, and look to hear more about the discussions about how we can use this technology.
Billy Johnson with Missouri.
Good morning. This is Hari Nair with the Virginia Department of Transportation.
Good morning. This is Adam Marlin from the province of Nova Scotia. Looking forward to hearing the experiences you all have. We've just got ourselves a PaveScan 2.0 RDM in very limited use, but looking forward to gaining all the knowledge from everyone that's got a lot more experience than us.
Morning, Luke Seek, New Hampshire Federal Highway Division.
Anybody else online?
Yes, maybe. Oh, with 2.
Sorry, I'll go first if you don't mind. I'm Jacopo Sala, Chief Scientist for Contour, formerly 3D Radar. We are one of the vendors that are going to present the technology tomorrow and provide an update. We have we don't have the same approach. Is more a three-dimensional system. You'll hear more tomorrow, and we are still a little bit more in the prototyping phase. All right.
Good morning. This is Brian Hurt with CTC and Associates. We've been assisting this pooled fund with communication planning, and I'll be helping out Kyle with some facilitation efforts for this meeting.
Morning, Dale Peabody with the Maine DOT. We've been involved with the technology for quite a few years now. Ulrich's on site there for the meeting, so looking forward to the conversation.
This is Jeff Withy with the Federal Highway Administration with the Office of Infrastructure.
Okay. Okay, Mike.
Yeah, oh, can you hear me? Okay, there you go. Good morning, Michael Johnson, MnDOT, Advanced Materials Technology.
Good morning, Bryce Warry with Boring Technology Consulting.
All right, thank you, everyone. Let's just quickly go over the agenda. Next, the contractors are going to talk about their perspective on the DPS system and also the data collection experience using DPS system. The Federal Highway, the Monica, I think she will be online to give us an update on their activities in terms of DPS research. And so for tomorrow is today. Tomorrow we're going to continue to hear the updates from the pool fund study. That will be primarily from our two subcontractors. One is NCAD and one is the University of New Hampshire. And also the states is going to talk about the experience in the DPS system, data collection, and also their planning. Hopefully, it's clear their plan for the implementation of deployment. The vendors and GSSI, the ESS, and the 3D radar is going to give us some update on our equipment development. Then, at the end of the day, what I'd like to hear from you is what are the topics and research that has not been covered in this current work plan, and we can, we would like to pursue as a group, then we can do within this pool farm, or we can have another program to move this forward. Our goal is to want to get implemented, I guess, as early as possible. State the construction quality acceptance too. With that, I just want to take a few minutes to highlight some major results we got so far for this year. For this project. Like I mentioned before, we started with 10 agencies to join the study. Now, over the 3 years, we have Maine, North Dakota, Utah, and Wisconsin also joined the study during the research period. In terms of timeline, originally we have 3 years. This 3 years project was supposed to end by the January of 2023, which is about a month away. But since we got more states during the studies, which means we have more funds available for us to allow us to do some other things. So we added more activities to the current work plan. So we extend this project to the end of next year. The current work plan to the end of next year. So like I said, we're going to do brainstorming tomorrow. If we have further research you want us to do as a group, then we can pursue within this research with this profile, or we can start another profile. In terms of hardware and software, if you use the new software, you probably feel that the user interface has much improved, and also the software has added more functions in the current software. And in the old software, you can only see the dietary constant distribution mapping, but now you can see this on-site density display and mapping, and also to do some data analysis like histogram and some other data analysis. And also the cloud features, this is just examples. And the cloud features has been added in new software. I think Roger probably can talk about later and more details in the software. I just give you some examples of the improvement. And so then they allow users to be able to transfer the data from the on-site to the office, easy for people to analyze or look at the data. And also the hardware has improved. We started with the RDM 1.0. Now we got the 2.0. And my feel is 2.0 is much more solid, and also sensor is much more stable. When you check against this no data constant material, that's the HDVE material. We feel it's much stable sensor now, which gives much quality data on the field measurements. And also we developed the sensor consistency method. And this, I think, is very important because we want to use these three sensors to capture the material variation, the density variation on the field. And so we don't want this measured data contains the system variation. So we need such methods to make sure these three sensors measure consistently. So not to have the measured data does not contain this system variation. So if you do this recommended method, like straight line method or Salubi method, and in that way we can make sure this sensor is consistent. For me, the biggest breakthrough results from this project was that we'll be able to develop the data constant to density conversion method using geometry spacement. At the beginning of this project, as we know, I mean, the DPS only measures data constant, does not give you density per se, right? So we need to convert from data constant to the density. So at the beginning, we tried to use the field course to establish this relationship, and which means we went to the project and we found the high and the low data constant location, and we took the call from those locations and measure the density on the field. In the lab, and try to relate the measure the constant core density, and that worked fine. But it's time consuming, and also the data is scattered. And more important, this we get this after compaction is done, and so that's why we could only see the data constant distribution in the field because that's after compaction is done, and we could not get the relationship during the compaction process. So during this 3 years period, then someone found a great idea can we use a geometry spacement to establish this relationship. And so GSSI quickly come up this device, this test toolkit, and also calculation methods. So that allowed us to be able to establish this relationship in laboratory. That can be done before the paving starts even. So we can do establish relationship in the morning of the paving day. That's allowed us to be able to see this density distribution on site. I think that's a big advancement, and also made this calibration establishment much easier and more accurate. In terms of the data collection equipment, we tried the different ways to try to more efficiently and to collect the data and reduce labor intensity. Because we started with the push cart, and they have talk about 1 or 2 mile project, probably not a big deal. But if you talk about the 2 or 20 miles project, then it's big labor intense job to do that. So then we tried to use the vehicle mounted equipment, and so then that did not work for us well because we could not line up the sensor 6 inches away from joint very well, very precisely. So we quit. That's the idea. Then we tried the gator, and then also we're working with University of Minnesota, tried to give the robot type of the DPS system. I believe GSSI is also working on this type of DPS system as well. Now we are using the Segway, and I think Steve and Jack come up with this idea about using Segway to push the cart for the data collection, and that has been worked well for us, right, in cities. She has seen very well to manage the Segway. Okay, in terms of specification development, actual spec development, we draft up the actual spec and the laboratory testing covered the actual constant to the density of this method. And we sent to Kurt and Powell sent to Kurt. Kurt Tujing, who is our payment engineer and state payment engineer, and he also is the chair of the actual material committee. So, and he provided comments. There's too much details divided by Kyle. So we're going to revise that one and send it again. And also the NCAD also has done fantastic job, great job, and they developed the certification program, and also the draft of the actual spec. We're going to send out for the actual for approval. And this is important in terms of in the future. If other vendors want to develop equipment, and also we can use this certification program to certify this equipment. And I think this is also required by the highway. Use certification program to certify the equipment. Also, the NCAD developed step-by-step methods to check the sensor precisions and in terms of laboratory testing, and also the field testing. Now we're working with the University of New Hampshire to try to draft up the actual spec for the field data collection, and that's going to be very useful for states how to collect the data. And also created the training videos that is in our website. I don't know how many people know we have the website designated for this pool fund study. And what I heard is the training videos are very helpful for the new users. If you're new get into this device, this technology, and I encourage you to look at this training video. It's a YouTube video to walk you through from laboratory testing to field testing. In terms of the training and communication promoting this technology, which is in our work plan, we've been given conference as a group. We've been given conference to the presentations to different conferences, TRBE, and in fact, how he's going to Virginia soon to give a talk on this technology. And also, we so although this is our first face-to-face meeting, but we have been hosting this virtual project meeting on an annual basis. Because we have access the funds available, so then we hired the CTC, which Katie and Brian is in the meeting now to help us to produce the articles and promoting and educating the other states or who is interested in this technology and this DPS system and the data collection. So that's all I have for today now. Any questions for me? If not, Kyle will be the next one to give updates on the floor.
All right, thanks a lot, Dai. So generally speaking, we're doing a lot of kind of housekeeping type stuff here early, but I promise to, if you bear with us here in the morning, we'll get into the more fun data analysis stuff.
Sorry, I just want to mention the lunch will come into the this week. So it's box lunch, right? So
yeah, box lunch.
11:45.
Yes. Yep. Yeah, so we'll have box lunch in here at 11:45. So, well, actually, we'll have it at 12, but they'll show up by 11:45. So, second here. One question for the people online. Are you able to hear still? Are you okay? We had some comments about audio being a little bit choppy. Can somebody speak up and just let us know how the audio is coming through?
I can still hear you.
Thank you. All right. Yeah, please use the chat or even just comment if there's anything that you're missing, because we want to make sure that everybody's able to hear the content. So I'm going to take a little bit of time here just to give an update on our work plan progress. Again, with this, please, for the people here in person or online, this will be less monotonous and more fun if we're asking questions and getting clarifications and trying to use this as a little bit more informal type discussion, because like I said, it's a lot of housekeeping, making sure people are up to speed this morning before we get into the presentations, but what all the data looks like and analysis and all that kind of stuff. So please speak up. Quickly, background for everyone. Di did a good job of giving the big picture information here. I just wanted to mention that, really our goal is to use the DPS method to improve asphalt pavement density. And that can be done a number of ways, even beyond just strictly quality control type. I see something going wrong, let's fix it right away. I think the information that's provided by this technology, you'll see throughout the day, especially as we get into the contractor presentations this late morning, and then our agency presentations, both MnDOT this afternoon and some agencies tomorrow, that we can really use this technology to improve our processes and provide information that that we just don't have available to us until this technology became available. So, so the tasks for our project to be able to try to accomplish this, these things. Shout out to Mercedes. It looks like we got a zoomed in camera view of the, to Jeff. Thanks, Jeff. We're showing off our technology. We have a zoomed in video of me for those joining online. Task one, as I mentioned, was software and hardware improvements. Task two, development of AASHTO data collection and analysis, specifications, precision and bias statements. That's a lot of the work that NCAT and now UNH is doing. Equipment and operator certification. You guys know this type of stuff. It's standard. Important things that need to be developed to be able to implement any sort of new technology. And then the last three are all about communication. So supporting communication through these meetings and training events that gets us into task 6, and then promoting the technology. So we want to be able to share our success stories in addition to getting the word out about what DPS can do for the paving industry. So this kind of half-hour presentation is going to be a little bit more high level, but if you want more details, we have our quarterly reports on the TPF website. So if I just click on one of these, just to give you an idea, you're going to have the overview of some of the activities that went on each quarter. So this activity here, we had our first TWG meeting, so that was reported on and giving anticipated work each quarter. So that's a good way, in addition to these annual meetings that we have, to keep up to date with what's going on. The overall kind of big picture where we're at after adding additional states beyond what we saw throughout the first couple of years. Like I said, we were able to increase our budget, and then also able to add some additional work for University of New Hampshire and additional data collection, training, and meetings for extending us into December. And we're on track for completing all the work of this current work plan by the end of next year. And like I said, that'll include technical work that I'll go through briefly here, as well as trying to figure out using this kind of transition year to figure out, like Steve Cooper said, if there's something that this group wants to pursue that is not going to be available to us after December next year when this current work plan is done. So that's, you know, one reason to do this kind of housekeeping stuff early is we want to be thinking about what activities we need to start planning for so we don't kind of stop the momentum that we're starting to build with this method after December next year. So just a little bit of details here. So that additional funds covers both the data collection from this year that's not currently on our financial report yet, but then also adding some additional calendar year 2023, both Minnesota and then out of state testing, as well as the meeting today, as well as another couple in-person meetings next year. We pursued with Craig Landefeld and Ohio DOT getting an out-of-state data collection using protocols that we're advocating through the pool fund last year. The contractor we were talking to ran into some labor issues, just having enough people to be able to accomplish that. I don't know if, Craig, are you online? If you want to share a little bit about that, not to put you on the spot.
Yeah, can you hear me, Kyle?
Yes.
Computer issues this morning. Yeah, we pursued trying to, work with one of our contractors to accomplish that, and like everyone, they're having trouble just getting enough technicians to support their standard requirements for ODOT, and they couldn't find anybody to do the additional work. I think they are still interested. Actually, with some of the logistics, I think it might just be easier for ODOT just to pay that out of pocket and wouldn't really have a problem doing it. So we'll see where that goes and if there's an opportunity there.
And then there's also been a little bit of discussion with Georgia DOT about possibly doing some work on a project. I don't know if Jacob, do you want to take a little bit of time just to explain a little background on that?
Sure. So I guess a little bit of background on Georgia. We had the RDM, we've got RDM Basecamp 1.0. It was part of our testing bureau, and then we got moved to our payment management bureau. Cyprian actually had it out and taking a lot of readings on projects. And so it was hit by a dump truck. I think that adds to some of the safety conversation, probably.
Yeah.
But GSSI provided us with a Basecamp 2.0, and we bought the MDM lab unit this year. So we've been working with that MDM here. We, like I said before, we're looking to join the pool fund. Hopefully that will come to fruition, but it's just kind of, it's out of the materials off at this point. It's just kind of seeing stuff gets voted on at a higher level. But we're just kind of, it's different in some states in our in how we do acceptance testing. We actually, at the plant, we don't do volumetrics. It's just do a burn gradation, and then also our and the compactions out on the roadway with your pores or the from the nuclear gauge. And so we're not actually getting, we would actually be getting those pills in the lab, you know, to be doing the lab calibration. So that's something that we're kind of a different scenario than some, you know, especially with this technology and everything. Like I said, right now we've been, Cyprian's actually, he and Andy, we all work on the same team. And Cyprian is kind of the new head of our, we've created our own research plan for looking at the RDM and everything. And he's kind of heading that up now. He and Andy have been working with MDM. So anyway, all that being said, Fabricio, we've worked with Fabricio when he was with NCAT. He's now with Clemson, I believe. Is that right, Colin? Yep. And so he's reached out and think about some possible helping us with maybe some implementation type things and things like that. So, you know, hopefully that will be, especially if we can join the full fund, I would think, is something that be great to kind of see if we can get help with maybe how we could implement it possibly in Georgia, or just kind of look at it, especially with our kind of circumstances with not taking pills for every lot. That kind of adds a wrinkle in it for us, you know, and how would that work? Do we need to do test strips? You know, how do we kind of make that happen? So, like I said, Fabricio's, we've had some email conversations. So Fabricio with something now is, you know, kind of presented some things. Hopefully, maybe we'll look into they're doing through the full fund. Does that answer your question?
Perfect. Yeah. Well, your team's ranked #1 in the country in football. Oh, it's not your team? No. Oh, you're Georgia Tech? I'm Georgia Tech. Oh, okay. They're not joining the pool this now. Yeah, Georgia Tech doesn't even, or they used to never throw the ball anyway. They were all run. Option, that's it. So
One more that way.
Well, either way, I don't want you throwing the microphone back. Okay. Yeah. So we also mentioned University of New Hampshire has been outstanding, helping us with this pooled fund, and I wanted to go over some of the additional work that they have planned, thanks to the additional states joining. So they've already given an update to the technical working group on a data processing tool that they've developed. I think Joe is gonna go over that a little bit tomorrow. But I think that's something that we want to keep in mind, that UNH is helping us, especially with statistical type analysis of the equipment. Task report summarizing how we determine the relationship between dielectric values and the density for the mixture. You know, Di mentioned that was a major breakthrough during this pool fund, is having the ability to do that relationship without having to cut cores out in the field. But it also creates another layer of validation, verification, whatever you want to call it, basically ensuring that the relationship we get from the lab or the production mix tested in the lab is actually representing what we're measuring in the field. And that's something we're going to dig into, continue to dig into for the rest of our time on the pool fund on this work plan. So they'll be presenting on that. We also have some changes to the DPS protocols, kind of based on findings that we're getting. So for example, looking into a little bit more outside the box type techniques of doing our conversion from dielectric to air voids, you know, whether that's a statistical percent within limits type curve that we get from cores, and then comparing that to our percent conformance or percent density histogram to do our conversion that way is something UNH will be looking into. There's just advantages and disadvantages to all these different ways of getting from what we're measuring to what we care about. And I think they'll make a lot of headway on that over the next 12 months. And then, of course, being able to package everything in a draft specification that allows states and other agencies who are looking to implement the technology something they can reference that helps them say, okay, I want to take this equipment and put it out on a project. So we're excited about the additional work that they're going to be doing. I just highlighted the differences. So the member states approved the additional work, and this is just kind of highlighting what's changed since their original work plan. So one thing that Di mentioned is making sure our sensors are consistent, and we've always done that by making sure they're consistent versus each other with swerve testing or repeat line testing. But now we're having success with a standardized material, which I think is more in line with engineering testing that is done with other type technologies. So being able to incorporate the use of a standard block that allows us to say, hey, as long as these sensors are measuring to the standard value from our known material, we can force all of our sensors to be consistent with each other. And I think that'll kind of has a ripple effect to some of the other things that or challenges that we're trying to find solutions for, including if there's a bias between our lab created dielectric to density versus our field measured dielectric to density curves. Just making sure the dielectric values are standardized will go a long way, and we'll go into some more detail on that. We're also adding a little bit on the correlation analysis for UNH. Surface reflection of cores that have already been cut hasn't been successful to date. There's been some data that suggests we might be able to extract surface reflection information from cores and potentially pucks. And the reason that's important is the surface reflection method is the way that we're actually measuring dielectric in the field. There's multiple ways you can get a dielectric measurement. One of those is velocity based. If you know the distance that the wave is traveling in the material, you can calculate the velocity, which gives you the dielectric. Or you can do an amplitude of reflection based method, whereas if you compare it to full reflection with a metal plate, you can get a dielectric that way. In theory, those should be the same, but that's just another way to make sure we're consistent versus each other if we can do the same method of extracting the dielectric using both the lab measurements and the field measurements. They're also going to be looking at kind of these various methods that we're trying to validate that our curve is good or not. And one way to do that is to just get a spot check measurement where there's going to be a core, and that's the traditional way we've been doing it. Get a dielectric in the field, cut the core, and see if it matches your prediction. And that's great, but logistically, it's not that easy to do all the time, depending on what project you're on. And then also, it's kind of in opposition to the advantage of the DPS method, which is that it's a continuous measurement. Its value is in that it creates a lot of data. So they're going to be looking into some of the statistics of how we can correlate our dielectrics to voids. And then, of course, coming up with a plan for, guidelines at least for how many cores do you need and what type of criteria do you need to be able to say, yes, this converted from dielectric to density is good or not. So task 4 for the variability analysis and recommendations for our coverage with our measurement. We just added a little bit of information on both differentiating between longitudinal and transverse variation because we know density, it differs in a lot more of a local way in the transverse direction, especially as you get closer to the joint. And then we wanted to have ability for the statistical measures to respond to what the users of the technology are needing. So, so we added some functionality that's not predefined by our work plan, but define that, you know, if people are asking for something that they'd like to see from the tool, UNH wants to accommodate it with their data processing tool. And then, of course, with these specifications and implementation materials, being able to get the end user up to speed is always a challenge. So, so if you need On or somebody from UNH to come out and show the tool, in addition to some of the online tools that are useful, they budgeted for a workshop or two also on how to use the implementation materials. So just going through each individual task, the software and hardware improvements are done, and we've seen improvement in terms of not having the underlying layer effect for typical paving operations anymore. We have tools that allow us to have a percent conforming measurement, and we found that's critical to turn all this data coming in to actual information that can be used by the people trying to build a good pavement in the field. Failure indications and making sure the GPS processing is working properly kind of early on in the project. There were instances where people would go out and collect data for an entire day or worse, and then realize that it's no good. And that's obviously no good for anybody. So this has been successful at helping us make sure that, you know, we're collecting data that can be used at the end of the day. Cloud data transfer, that is something that we tried out this year, and it was extremely useful for us. And this is something that I don't know if we want to talk about it right now, but I know vendors are going to be interested in how states plan on using the cloud and what are the best ways to implement the cloud. So, you know, when they're putting resources towards developing their product, we as end users don't tell them, well, that's not what we want. So I don't know if Roger, if you don't mind taking the mic and maybe asking some of the questions you want of the group. Sure.
So as part of the task, we developed a cloud interface to move data up into the cloud, then have a user with a desktop download it onto the desktop and process it. So there are a number of things that need to be done potentially to make this more useful. And also the amount of data that's uploaded to the cloud is important from a pricing perspective, because we're looking at using a cloud service and they charge based on volume, data volume, bandwidth. So a big question to the users is it really necessary to upload to the cloud all the data that we currently collect and store? Because there's a lot of metadata. We store all sorts of different metrics that allow us currently to go back and pretty much see how well the data is being processed and if there's any trouble with some of the data, and we can pinpoint why the data is corrupt. So I think, first of all, do you need to reprocess all the data on your desktops after it's been collected in the field? Are we to a point now where we can actually upload just critical parameters that then can be downloaded really rapidly and displayed very rapidly without all the extra information? The bandwidth goes down, prices go down. I think everybody might be able to have it. But you won't be able to go back and do any corrections. So, for minimal corrections, maybe you can change the calibration so that if the mix changes, you can adjust that.
Hey, Roger.
Yeah.
I just got a text from Brian with CTC that we should hold the microphone closer to our mouth. Straight. For the people who might be, it's easy.
Okay.
Yeah. Yes.
So my question to the group is, are we to that point? Where we can do it? Can we cut down the data?
Thanks, Roger. And I think we'll have time to, is my voice coming over the microphone right now?
No.
Not very well. Okay. It's the new. Well, we'll just keep going with this one. So, and I think we'll have time to come back to that question because a lot of it depends on how you're doing the analysis, like Roger said. So, for example, if you're using Beta to do your analysis, as long as those .tes files are exported to the cloud, you have the information you need to do your analysis. So, oh yeah. You got Rob here.
Yeah, I can talk on. So Dave, I guess the question is that data still remote people? Remote people. Roger, sorry, Roger. I guess my question is that data, is that data still available by the hard drive within the system to be accessed? It's just not instantly available.
It's available on the hard drive of the unit used.
Remote people cannot hear you. Remote people cannot hear you.
So yes, it would be available on that tough pad that's used to collect the data. So you'll always have it on the tough pad.
So there is redundancy. Yeah.
Yes, there is redundancy.
Great. Thank you, Robert, for being a good example of what we're trying to do here. Speak up if you have questions. So good job. So yeah, anyway, more to come on the cloud data transfer front. Yeah, our standardization block that was tried out. Initially, I think last time we met at the training, we were just starting to get our feet wet with that, and it looked promising. And now we've done a whole season of data collection, standardizing to the fiberglass block, and then another thing we've been able to do is take Grecio's protocols, and you can tell with the data if you're standardizing to the block and then running it through those precision and bias protocols, you have much better results than if you're just taking the device and hoping it performs the way that you want it to. So we're really happy with the direction of the fiberglass block in terms of what it means for consistency with the device. And unlike the swerve or the repeat line, now we can also test consistency day to day too. So, so that's a big step forward. Di mentioned briefly, you know, we have a lot of data with this method of getting dielectric from production mix putts. And I was excited to show all the data to Kurt for the development of this determining dielectric constant of gyratory compacted asphalt specimens spec, but there's a difference between a research paper and a spec. So we're going to repackage this thing with the kind of nuts and bolts of what people need to do to get a reliable dielectric from samples. And then, of course, we can just cite all the statistics behind why we're doing what we're doing. But that's something that that we should have submitted to the committee. I think he'll need it by February next year. So we also have field data collection specifications that we're modifying to accommodate some of the new protocols. And then, of course, we have our training videos and are constantly updating the information here. And when I say we, I mean Mercedes. So like here, for example, we went over the terminology and how you should be inputting your different kind of what Roger would call metadata, I think, for your projects. And so all this type of information we're housing on our website. Get back to presentation. So so that's all on the website there. We also had Fabricio's report that he did when he was with NCAT was published this year. This is results showing lack of influence below 2 inches based on Fabricio's analysis, which was good to see. A draft AASHTO standard practice for certification of in-place asphalt pavements, density profiling systems. This I just wanted to highlight because this is the type of analysis that that I think is critical for the device, which is basically showing that if you go out and do the same profile with a different operator, a different sensor, you're still going to get the same result. Because as Di said in his presentation, we want to make sure we're measuring pavement characteristics, not sensor characteristics, and then thinking that it's pavement characteristics. So this is a way, and we took the method that Fabricio developed here and took it a step further with the fiberglass block and then cores every 10 feet. They also developed a tool for statistical analysis of precision and bias. And this has been critical for our analysis of the pucks. And then, of course, having a testing guide, because there's always going to be changes made and new equipment becoming available, that we want to be able to take these protocols and see if we can recreate the work that Fabricio did with new protocols and new technologies. And this is just a couple pictures of how we built on what Fabricio did, just doing the same protocol that he developed, but then also doing our fiberglass block measurements, and see some data with and without fiberglass block correction, and then also cores taken every 10 feet. So in addition, so with that 200-foot stretch, the baseline profile was created with a nuclear gauge, which many of you know has a higher variability than the DPS itself. So this baseline profile, we're going to be using these cores taken every 10 feet to supplement the data to allow for a better baseline comparison. And then this is just one example where we have cores every 10 feet and spot check measurements there. And then we also have our 4 measurements back and forth. So one thing I didn't mention from before is that these profiles that we're creating, we're doing measurements all the way down, all the way back, all the way down with the segue, and all the way back with the segue, because we want to make sure repeat measurements with the 4 different test techniques with the different sensors all correspond to each other. So this is just a comparison on an example where we have a little bit of bias between the 2 different sensors. And then this is if you don't do the correction to the standard fiberglass block. And then here's that same set of data after correcting to the standardized fiberglass block. And, performance-wise, that small little shift in the data isn't a huge deal, but the more we can minimize all these different potential sources of bias and error in our measurement, the better off we'll be. And I just got past the note that we're going a little bit over in time here, but we'll be able to look at more comparisons like this later. So this is kind of the cliff notes, these orange difference from the mean measurements here, the raw data basically get corrected to a more acceptable level in terms of looking at the differences in dielectric from the mean, which is basically telling us it doesn't matter what sensor or operator you're using, you're going to get very similar results, which is what we want to see. We're still obviously doing the support communication. I just wanted to highlight a couple pictures of Federal Highway came out to visit. So here's Steve Cooper, and, Pete Ekman, and Dennis Dvorak. And I told everybody that they need to look upset in this picture because our cloud storage ran out of space, and I wanted to send a message to Roger that we needed more space in our cloud. But it's obviously, he's probably not going to get the message with all these big smiles. And Matt Ullman was the worst offender there. So, but he's just a happy guy. He can't help it, I guess. So, and then we also took a look at the robot that day. And poor Ted from the University of Minnesota, his battery ran out, I think, or he was having issues with his remote control. So they didn't actually see the robot in action that day, but it was nice to have them out. And then, of course, we're also doing our technical working group meetings, which is the next subject I'll start going through here. The spring training we did this past year, it was nice to have everybody there in person, and we're still doing videos and calls with the various states and members and trying to support the Federal Highway Mobile Asphalt Technology Center and the program they're doing. And then, I don't know, Mercedes maybe wants to go somewhere warm in February or March. We could probably provide some on-site support if you want somebody from MnDOT to come out and help collect some data on a project. Just keep that in mind. Did I miss Mercedes? Okay. And then CTC has been great, specifically Katie, with promoting the technology. In addition to our presentations that we do each year, we're now starting to put out these DPS digest series. So we've put out a couple already, and then we've got one draft that Katie sent to us dealing with some of the work Fabricio's done for us with the certification and precision bias type work. So that's been good for quick hitters to get information, and that's again on the website. So here's an example. we'll talk about, which I just wanted to highlight the title here that our bituminous engineer, John Garrity, came up with, which is contractors ask yourself one question: do you feel lucky? So anybody know that reference? Yeah, yeah. The Dirty Harry? Yeah, Dirty Harry. So anyway, so we're trying to put out these kind of quick hitters, and the kind of big picture here was trying to use this tool as a way of eliminating potential problem spots in the pavement that if you're a contractor, you don't want to see cores show up there. So this is as a means of helping you out with that. So, so our next subject is going to be our TPF, our pooled fund technical working group report outs. So our champions for each of the technical working group umbrella topics, some of them got delayed to show up tomorrow. So you're stuck with me for the rest of this hour to present some of the report out topics here. But then there's a break after this. So. Okay, so as I mentioned, we have kind of 4 umbrella topics that we developed, and we have champions for each of those. George Chang is here. He and Craig, who's with us online, are helping with the data analysis technical working group. Fabricio Leva is leading our efforts with kind of precision bias type activities. We have Rich Giesel, Dennis Dvorak, Robert Hinman with the kind of more spec type activities, and then Harold Von Quintus and Robert Hinman with some of the challenges in what we're doing to help address some of the limitations of the technology. So we've had 3 meetings so far, starting in 2022, and we have agenda and summary reports that Katie's put together for each of these meetings. So that's kind of where you can go for the details. But we decided it's a good idea for those of you who attended the technical working groups to get a reminder, and those of you who weren't there to get up to speed, because a lot of the decisions I think we'll be making these couple of days, it'll be important to get the background of what's been discussed at these meetings. So that's going to be my attempt here for the next 45 minutes, is to get everyone reminded and up to speed, and then we'll get into some of the more fun stuff after that. So as I said, our kickoff meeting in February, we talked about some of the more groundwork things. And what we ended up deciding on was having approximately quarterly 3-hour meetings, and then dedicating 45 minutes for each of the 4 umbrella topics. And that would allow us to set the agenda. And if there's participants who are only interested in certain umbrella topics, they can kind of just join and leave as their specialization for their preferences. So everybody's got to have a mission statement. So our purpose for the technical working group, at least as of now, is to work as a group of density profiling system users and or technical experts to identify barriers and work towards solutions for deployment of DPS, the DPS method as an asphalt pavement compaction process control and or density acceptance tool. And we included pavement compaction process control in here rather than kind of the originally stated acceptance tool only, because there's a whole slew of things that come with using something for acceptance, and we think that there's a lot of usefulness to this technology, even as we're working towards using it as an acceptance tool. So, are there any comments on that purpose? Something that should be there that's not from the group or anybody online? All right, hearing nothing, moving on. So George shared with us at the beginning, I wanted to highlight this because I think this is important, because we want to include vendors and contractors and various entities that at times can be in competition or in conflict with each other if we don't handle everything in a transparent way. So George shared us some terminology that they use for their other intelligent construction technologies that we try to apply for this group, where we're basically just trying to work together as a team to advance the method itself and being as transparent as possible. The most important thing for the kickoff meeting, well, Robert, first of all, put together an outstanding Excel spreadsheet just listing a ton of different topics related to DPS and really organized it in a way where we could understand what were some of the themes that have been coming up, especially at a November 16th peer exchange meeting that we had the year prior. And we took that, and the group decided on 7 possible umbrella topics during the meeting. And then I think it was Brian who made a good suggestion. Let's do a poll here quick with all the people who attended the meeting and see what comes out on top. So what we ended up with and what we've been focusing on this year are these 4 topics. One of them being data analysis and uses, and then specifically, so that's the data analysis and uses is in relation to how we use our DPS data. But then we also wanted to see, to make sure we're using it properly in relation with other intelligent construction technologies. So that's why it's good to have George and his team on board with that one, because beta is certainly one tool that we're looking at and many of us are using as a means to help us accomplish this goal. And you'll hear a little bit from George here later today. And then I know a couple of contractors and states are using beta, and you'll see that for some of the presentations that we have for different analysis. We even have our own MnDOT beta wizard, Mike Johnson, with us here today. So you'll be able to hear from him this afternoon too. And then of course, Craig Landefeld has been a big DPS user, and the way that he's been able to use DPS to turn the data into information that's useful. I remember him presenting initially kind of data lots of cores versus DPS data, all on the same plot that helped people understand what DPS is providing. So it's good to have him helping to champion this topic as well. The other topic, precision, bias, and accuracy of the DPS in measuring the dielectric and assessing asphalt density. Fabricio has been leading that, and this has all been kind of related to the work that he did for us in the pooled fund, and this is continuing to evolve. Agency use, so we said acceptance / certification, federal highway, and then spec development, state DOT, and Rich Giesel, who isn't able to participate today, but will be participating remotely tomorrow, has developed some specifications as part of the pooled fund and as part of his state work. And then Dennis has been very active in this field and helpful and given a couple presentations to the group, as well as Robert Hinman, so Dennis is here remotely and then Robert is here in person. So they'll be able to help us out with this. And then the last topic with limitations, risk, research needs, strengths, weaknesses, opportunities, threats. The group identified this as an important topic because regardless of what method you're using, there's going to be limitations in how you handle those and minimize the weaknesses caused by the limitations. Makes a big difference in how we can get most useful in some of the technology. And Harold Von Quintus, who actually has put together some materials related to some of these topics, but I believe he's still waiting for feedback from NCHRP before he'll be able to share that. He's also a champion on this topic as well as Robert Hinman. The ones that didn't make the cut but were still identified as important included equipment use, data acquisition, which I would contend is one of our biggest challenges, yet most important challenges for this technology, just being able to go out there and get quality data and then doing it safely and with equipment that's not going to break down and leave you hanging on the middle of the project. This is a critical, in my opinion, aspect. But we did decide that that's kind of included in some of the other four topics, so it wasn't selected as one of the four umbrella topics. What vendors are making and can they meet agency needs? I know we have a great group of vendors who are responsive and they want to provide equipment that we can use. And we need to have a means of giving them quality feedback in terms of what the end user, i.e. us, wants when we're out there in the field. So we thought, maybe just through our user vendor working groups, and then also including them in meetings like this 2-day meeting here, that we'll hear from 3 different vendors tomorrow, and hopefully we can use this time to address this type of a topic with the vendors. And then, of course, kind of hand in hand with that is just awareness and promotion to help agencies and vendors with decision making. Just being able to kind of market and present where we're at with DPS and what hopefully eventually more timeline type stuff. So vendors and contractors and everybody involved can start to plan. That's a big topic here that again kind of is enveloped currently in our pool fund, but we need to start thinking moving forward post December next year how we're going to continue to provide this. I wanted to have a break quickly from me just talking to everyone, if just going through those topics, if it sparked any sort of thought with anybody here in the room or anybody online. Are we missing something major, minor? What are some of the things or topics of importance that hasn't been mentioned here? Any ideas? Nothing, Herb?
No.
Okay.
This old guy has to stand up.
Okay, all right. All right. Well, anybody online? I see a red dot down there. That red dot is a sheet. Okay. All right, we'll keep on moving. So, in our last technical working group meeting, we just talked as a group about what are some of the most important things within each umbrella topic that we want to at least touch on. And a lot of them we're going to give more detailed information on just throughout these 2 days. But I wanted to give a quick summary of them. For topic 1, which would be our data analysis and uses, the group decided we need to definitely talk about beta usage and where the different agencies are with how we want to use beta and on-site information and how happy we are with the current tools available and our ability to take the technology and provide information on site. So I did give a talk to the technical working group back in July on the on-site software. And one thing I highlighted beyond the obvious, which is that we have a continuous dielectric or density measurement out in the field, is that some just simple things like training the person who's pushing the cart that if you see a drop in dielectric, that's a drop in density. And simple things like that can be very useful if used properly. And then also taking advantage of some of the improvements in the software. So having that live table that you can create if you set up your project correctly can give you some percent conformance information about your density that can catch things that help improve the process for the project in the long haul. We also had Rebecca Embacher and then Mike Johnson give us a good presentation on beta in general. And basically, just as background for everybody, it's for MnDOT at least, it's our standardized platform for allowing us to integrate our different intelligent construction technologies together and use that data to analyze not just the individual intelligent construction technology that you're looking at, but see it in relation to all the construction information that's going on that day. So that was a nice presentation that I think can at least get the wheels turning for people on how we can allow for better use of all the technologies in the field. Some of the different things that we went through that are a function of using this type of technology is listed here, just to highlight a couple. A lot of this stuff we already know, but it makes a big difference when you see the result of too many paper stops that you'll see as we go into the analysis today. Or, simple things like windrows not overlapping and what happens to our density when that occurs, or segregation towards the middle of the pavement under a gearbox showing up in our full coverage assessments. These sort of things, there's a lot of different ways to get poor density, and having a DPS full coverage map is a great way to say, okay, we have an issue here, or we're seeing a drop in our density or a drop in our dielectric even is enough sometimes, where you can go back to some of these things and say, okay, what's going on with our different intelligent construction technologies that's telling us why we're having issues. We got a question about GPS accuracy and kind of what direction we need to go with that for DPS. I know with GSSI's system, when you buy it off the shelf, it doesn't come with an RTK accuracy or a sub couple inch accuracy GPS, but it does allow you to stream an NMEA string. One thing we got to think about as a group and in communication with the vendors is, one, what is our required accuracy for our GPS to be able to map this data? And then two, what is the least painful way to implement that level of accuracy? And I know John Sickmeyer's here, and I don't know if Mike Johnson stepped out, but if either of you two want to just give a really high level experience at MnDOT, because we've been requiring RTK accuracy on a couple of intelligent construction technologies. Maybe if you can just share a couple of minutes, some of the success stories, some of the challenges with how we're implementing RTK accuracy and how that maybe we can learn from with the implementation of DPS.
Well, you guys will just stay here. It's going to be brief. So, well, I think, it's certainly the vendors, asking for this level of accuracy is a big deal. We understand. So that's, I guess the thing to share just in a few seconds would be is that the group can have whatever desire they want, but of course they'll have to get the capability on the ground. So that's taken years. So it'll take potentially years, maybe, but can we learn from everything, the other technology? Well, of course, but you'll have to get a commitment out of the people spending the money in building the equipment that they're this is on their to-do list very soon.
Yeah, thanks, John. So just to clarify, the current method of getting RTK accuracy for Minnesota for thermal and IC is to just spec it and say, figure it out, right?
Well, I think we have, no, we didn't just spec it and say, figure it out.
Yeah.
We know what basically is possible.
Yeah.
And then we write specs to push us towards what is doable, I guess, not just possible.
Yeah.
So that's where you're at with this. You have to decide how close when do you want to get to implementing, delivering what is doable, not just what's possible.
All right, we got Irv and Robert. Oh, we even have Todd. All right, finally some discussion.
Well, I think the point about accuracy that needs to be made is what are you trying to measure? And I remember in the early days of IC technology, sitting at my office and getting a telephone call from MnDOT saying, what in the hell are your IC rollers doing? They have suddenly shifted over 2 feet and they're no longer compacting the shoulder. I got on my computer and abruptly, so I get on the telephone to the superintendent, like, what in the hell is going on out there? He goes, what do you mean? Well, why did the roller shift over? He takes a picture, sends it to me, and it's a straight line, as far as you can see. He said, the rollers haven't done anything. I said, what's that in the background? He goes, the bridge? I said, did you, by any chance, change counties that you're paving in? Well, yeah, back at the bridge. That's a river, and one county on one side, one county on the other side, and I think I know what happened. Another calls back to the DOT, and who put together the maps for the project? And at that time, it was done by DOT engineers. And what they didn't take into consideration is that the GPS coordinates are not universal across the state. Is that different counties have different GPS coordinates. And on this particular project, I think it was Highway 14 or Highway 16, as you cross the county lines, there was a 1 foot shift in the X coordinate. So the rollers hadn't changed anything, but the coordinate system had changed. So when we talk about accuracy, we have to know what we're measuring. And then we have to know what is being used as the baseline, whether, what's going to be important or what's not going to be important. At that time, for the IC rollers, they had to be calibrated within 6 inches. Boy, what difference showed up as a big red line. So I think in this discussion about accuracies, what are we measuring and how accurate does it need to be? Marshall Thompson gives the example of, measure it with a micrometer, lay it out with a yardstick, and then cut it with an axe. And we don't want to get into that situation with this technology because that'll kill it. Quite frankly, because the contractors and the agencies will never be on the same page. So decide on a method of accuracy and then double check it. The thing saying you get what you expect.
Thanks, Irv. Mercedes is gonna run stuff around. Hey, Mercedes. Yeah.
Todd Mansell here. Yeah, just totally agree with her. Same experiences in the past, and I'll even add to that just for thought as we move forward. What do you want to get out of the data? So again, kind of spinning off of what Irv talked about. What do I want to see? What do I want? I mean, am I just looking for an average number? Do I want to go back? I use the example of IC. If I want to look at drum overlap on roller passes, then I need high accuracy GPS. I just want a rough idea of 3 or 4 passes over this area. I don't need the high accuracy. So I think we have to look at what we want to come out of it. It's the end information that we want, and then determine the accuracy. One thing, and I'll just throw it out there, maybe getting off topic now, but just as an example, on the low accuracy GPS, you come back a week later, and you may be 10 feet off. If I've got high accuracy RTK, I come back a week later, and that spot is still within an inch or 2 where it was a week ago, not 10 feet away. So just things to think about.
Robert, do you have anything? Yeah. You don't sound excited.
I guess it just muddies the water a little bit more. So along the same, what's been said, maybe said a little bit differently. So I guess I think of it in terms of not only how's the data being used, but what is being done? What is it being used for? Is it used for quality control or for acceptance? Certainly the level of accuracy is going to be different. And as a contractor, if you're in a position where you're having to remove and replace something, obviously you want a higher accuracy because you don't want to be removing and replacing more than what you need to. So again, it comes back to how is it being used. And then I've also seen on numerous projects where there are multiple grids, if you will, that don't line up. And multiple owners of roads. Maybe the state owns a road and someone maintains it. So it creates a challenge, and also along with who owns the equipment, the GPS equipment, right? If it's a consultant, contractor, is it the state? Who's running and collecting equipment, right? And there's going to be differences there as well. And so if you're, and then if you're collecting IC data, IR data, and this all in the same, you're doing it all simultaneously. You can't just use the same equipment. So now you have to have multiple receivers, you have to plan for that additional equipment that's needed. But I think a lot of that can be done multiple, at least components, and owners, well, hopefully a lot of that is coordinated before the project is let. And you're having that conversation early on of any of those discrepancies. And so that when you get into the field, you don't have all of a sudden, hey, we're seeing this big shift in results. And because that's frustrating for everyone.
All right. Oh, yeah, Jacob.
Yeah, and I guess, from George's perspective, we're still just evaluating the technology. We don't know if we want to implement it or not, but, maybe if we wanted to, let's say we just wanted to use it as an investigative tool, and we had a project where we had a paper mounted, and then we want to be, I guess, as accurate as we can to compare to what some of the other technologies are showing with their GPS. So when we do, let's say we overlaid it data or whatever, so that at least we have some confidence that what we're showing with the RDM GPS is lining up with the other technology.
Yep.
I think we're trying to all say the same thing, that there has to be communication on what the level is that we're trying to determine. The first level, as Kyle mentioned very early on, if you're rolling down the road, whoever is pushing the DPS, if they see a change in the numbers, that means something. Now, for the manager, for the contractor, or for the inspector, for the agency, where that occurs, they want to be able to go back to that spot. But that's a higher level of scrutiny. And so we have the first level is see it, understand it, fix it. Then we have the second level of where did that happen? Let's go back. Did they get it fixed? And the third level is the Dennis Borak level. Okay, we got federal dollars in this. Did you get what we paid for? Can you prove that you got what we said we wanted? And that's just third level of accuracy. And I think to make this technology implementable is that all three of those levels need to be addressed. Because I think all of us in this room just hearing the stories and knowing most of you in numerous projects is that we don't usually have that top to bottom communication. And the people using the equipment know that they got to get numbers. What the numbers mean, I get paid, whatever they get paid. I got numbers. That's somebody above me to figure out what the numbers are. But we can't do that anymore. They have to understand what's going on. And their bosses have to understand what they're really doing out in the field. And so then they can explain to the next level, the guys that are paying the big bucks, that they're happy.
I think you can. I appreciate that, Herb, with it. And then even within a contractor, right? You might have someone producing versus someone that's laying down, even if it's the same company, right? Oftentimes those are different divisions. They may not communicate always as well as as folks would like. And there might even be finger pointing between them, but trying to understand why do we have all of a sudden the difference? And if you don't have that accuracy, I think that's hard to do, right? Even if from a general standpoint, you can still use relative data. And say, okay, we know we got something changed, but then it's really hard to pinpoint. Hey, okay, now we know we had a difference because our loader went to the wrong wrap stockpile, right? Or we just had a change in, in something in the mix versus something during production, during placement. And so it's just, I think that's having that level of action is very helpful in understanding the other components and then how risk is perceived along each of
owner, different stakeholders within that.
How far do you want to get in the weeds on it?
We're gonna have some, next time I say, are we sure nobody wants to say anything? Let's go to the weeds then. So,
How about Earth?
yeah. But yeah, I mean, it is a critical, it's definitely not there are weeds that we need to go into, I think. But in the interest of making sure we get a break, we have 14 more minutes on the report out, so I think we will keep moving. The only thing I'll add is I think I like the idea of hearing it based on how you're using the data. I think there's going to be some examples that Forrest is going to show and that Mike Johnson is going to show and others will show where you're comparing quite precise comparisons between two different technologies in Veda, where that just doesn't happen without RTK precision. So that's kind of like a clear one. But then even, let's say you're just doing percent conformance where you're averaging out over 200 foot, 500 foot sections, there's an added kind of security blanket when you have RTK precision when you're doing that kind of measurements, I think. But I mean, you probably could, even with sub-meter GPS, say, okay, if somebody mislabeled their DMI and they're not actually at 120 plus 00, they're at 1200 plus 00, that kind of stuff you can correct. But there is kind of an added security blanket of having that RTK precision too, even if you're not directly using that, and knowing when you're at the joint or not at the joint, that kind of thing too. So, but anyway, I said don't go in the weeds, and then I went in the weeds. So, so we also had a good presentation by Mike Johnson showing use of Veda for some of the kind of mapping and percent conformance type stuff from a 2021 project. He'll do that again this afternoon for a 2022 project, TH36 later today. The UNH tools, again, the TWG just wanted to highlight to everybody that there is capability to take this data analysis tool and kind of modify it based on end user needs. So On went over some of the kind of nuts and bolts of how that tool is being used, and I think Professor Sias is going to go over that a little bit again tomorrow too, in addition to the other topics UNH has to discuss. And we already started some of the discussion of what information the group is looking for, so there'll be more discussion on that later. And again, we've kind of already touched on this, where we shouldn't just be looking at DPS as a quality assurance or bust type tool, I don't think. I think using it as a way of saying, hey, this data is valuable, let's start to use it, and it's worth paying for as an agency, even if we're not using it yet, as a quality assurance tool is something we need to do, rather than erring on the side of saying, hey, let's 100% trust this and eliminate cores, is an error, in my opinion. But then it's also an error to say, if it's not ready to do that, well, let's just wait until it is. I think, throwing it out there on projects and seeing what type of usefulness we can get from it is only going to help us move towards ironing out all the necessary steps to use it as a quality assurance tool. Topic 2, we're going to hear from Fabricio tomorrow on this, so we're not going to spend too much time here. I just wanted to highlight some of the discussion that Fabricio brought to the technical working group. Again, whether we're calling it certification or precision bias, there's just been a lot of work by Fabricio just putting the technology through the ringer and giving us good statistical analysis. So one of the things that his statistical analysis showed is compacting 3 gyratory samples at a minimum of 3 different air voids levels is a good way to convert from dielectric to density. And then the good part about that is we can use the existing Astro T 331 and just do basically what we're already doing anyway with the pills or pucks or whatever you call those samples and get our conversion from dielectric to density. And then he also came up with a way of giving us certification scores based on the errors from person to person or sensor to sensor and put it in perspective of ME modeling in terms of what it actually means on our ability to do an assessment of density. And then gave us protocols that all the different states can put their equipment through the ringer if they choose to see how it's performing using its statistical measures. And that's one thing that we've done at MnDOT out on Minroad construction on the shoulder. So again, created some tools, including an Excel app, as well as an online-based tool that we're trying to get that code so it talks well with our website so we can host it there. But all exciting stuff for the ability to allow users to take a look at the precision and bias for their specific equipment. There was some discussion about the nuts and bolts of how the certification and precision bias statements were developed, and I think that's something we can go into more detail later on. And then just for background for everyone, he did end up following the ASTM E691, which does have some differences for use with the profiler than what we're trying to do for our DPS, but it was a good way for us to get some statistical measures of how these sensors are in terms of consistency with different users and sensors. And then also giving us kind of a means to check it ourselves, and that's something that we did at MnDOT, and we'll show our mid-road results, at least initial results for that later. Dennis Dvorak teamed up with Fabricio after that initial one in July, and I think this was really good to put the work in context. So how the work is presented makes a difference, and Dennis was able to provide some FHWA perspective on the usefulness of the results coming out of Fabricio's study, and then help us kind of put it in its appropriate kind of how it should be used. So, for example, there was questions about how frequently should a field certification be completed, and is 10 profiles excessive for that kind of work? And that's where Dennis and then also state pavement engineers, come in handy to make sure that, what we're doing and what we're recommending is something that a program can take on, and we're doing the appropriate activities based on Fabricio's results. And then also just mention that we're doing some follow-on study, but also using our fiberglass standardization, which definitely fits into our umbrella topic too for precision, bias, and accuracy. The agency use acceptance certification and spec development, that actually we had a nice one-off meeting with just that group. We were able to meet at the both online and then also at the Minnesota conference in March. And Rich Giesel, who's got a lot of experience in specs and materials testing, presented his specification, including mat and joint compaction pay factors, which is basically just a linear bonus that's paid for each percent density of the percent conformance results with DPS that he presented to the group. And there's a lot of great discussion there in terms of how we can, what we need to do to be able to get to a point where we can use DPS as an acceptance tool, and maybe looking at things a little bit differently now that we're starting to get more tools that are continuous in nature versus the spot check type measurements that our current specifications are assuming. So that's, something that I think this group needs to be thinking about. And I'll just throw out one example, at Minnesota that we're just kind of brainstorming about is, so what, in terms of risk management, does it mean if you go out there the first day and your DPS is showing consistent good density, your cores are showing consistent good density, your IC is showing consistent roller passes, your thermal is showing consistent thermal information across the map. Do you have to continue to take as many cores as we're taking currently at MnDOT, or can we start to say, okay, if we got 3 different continuous coverage technologies all telling us that it's good, can we start to leverage the large data to help us with our specifications? And that's kind of just throwing it out there for thought for this group. And then again, just a quick mention that using DPS as a source of information for contractors, even prior to using it as an agency for density acceptance, I think we need to be, in order to get the most bang for the buck, we need to get contractors on board on using this technology to help them, as John Garrity said, feel lucky because they know that they've measured their product and it has full coverage, good density. And then Harold's going to have some NCHRP information at some point. They'll be able to share with the group on this topic. Robert, who's joining us today, the group decided that it would be good for him to be able to explain some of his highlights on the common comments and work. And we're down to our last 2 minutes. But Robert, what do you think? Can you just highlight a little bit about some of the stuff from your spreadsheet for this group?
So to quickly I won't go over all the bullets, but certainly there are safety concerns with data collection, right? And with any work out in the road. And a lot of the information in the spreadsheet with help is mentioned was used to help about the framework of where should our focus in the energies be. And a lot of the things within the spreadsheet as well. So some of them related to safety, some related to precision bias, some related to specifications, development, acceptance, right? And a lot of work that has been done within each of those. So I'm hoping to actually revise that spreadsheet so that it's a little bit more current based on the work that's being done. There's always a bit of lag because there's always continuous work being done in each of these arenas to address the challenges, right? One other thing to note too is a lot of the, like say, the specifications will depend on the state DOT's quality assurance program, right? How and the risk associated with that. And so as Kyle said, if there's all these other aspects that are going well that the state can then scale back and because there's low risk in certain areas, we can accept a little bit higher risk moving forward, say with the reduction of taking cores and even as they transition, develop into an arena of going from quality control, process control to acceptance materials, because there are a lot more stringent requirements from the CFR, right? Which federal highways here help ensure that those federal funds are used in accordance with it.
Okay, and all these presentations are going to be posted to our website like we've done in the past. So thanks for kind of giving us the Cliff Notes version. And I think that'll be maybe good for our next February technical working group, Robert, which is an updated spreadsheet with the comments and work being done. So with that, we've made it through the four umbrella topics that we wanted to hit. And I think we can take, what do we have, a 20-minute break here? 15-minute break. And then I think we're going to be blessed with a presentation from George, if I'm not mistaken. Yes. He's not going to throw me as you speak. All right. Well, you're temporarily dismissed. So wherever you want to go, we have some food in the back. We'll walk around, go to the bathroom, whatever. And if you're online, you can just wait for us to start again at 10:15 Central. Thank you. All right, can everyone get back to your seats, please? We got George Chang joining us now.
Oh, okay. Okay. So, yeah, I'll go then.
Oh, you can run over there. So they know this, the speakers, we can get them in there. What's that?
That one. I better stand close to that.
This is good for us.
Oh, I didn't know that. What's the way they online?
Hello?
Yes, that's online, yeah. Get it on your. Yeah, so George, you want to use this?
Okay, you.
Just weird. So hopefully it works not on the cloud, but it should. Yeah, you know what I mean? I'm highlighting the high one.
You might know.
Yes.
I probably need to.
It should really work really well on.
Yeah, it could. The normal project my voice pretty well.
This is. Oh, yeah, oh, this is the top. That's nice and safe.
Technology.
Yeah.
Too much. Thank you.
Down to 5 or 6 inches. Seems a little, it just seems right.
Hello, we're back. Guess you have heard too much from Kyle today. Let's switch gear a little bit.
Not sure whether all the line you are back. We're going to switch gear a little bit to take y'all to the 20,000 feet level to have a little overview what does technology DPS fit into other technologies that we're going to talk about, intelligent construction technology, and all the way to building information modeling, BIM. So I'm going to have a quick overview how we can get there.
You want to maximize it?
Yep.
that's running. So what is intelligent construction technology? So we founded an organization called International Society for Intelligent Construction. That's back in 2016. So the idea is to define this platform for intelligent construction technology that can be used to improve the process on the entire life cycle of infrastructure, from the design, surveying, material production, machine guidance for construction, and quality and monitoring using all the technologies, and pay quantity, and eventually to manage everything through BIM or similar. And we boil down to a fundamental characteristic, what eventually the intelligent construction technology should do. There are four characteristics. Is this technology should have a sensor to perceive the data, to turn the data into information, and also have the capability to perform analysis to turn this information to knowledge, and understand what this knowledge is all about, so it can make decision. And eventually, the technology will execute, and so for the auto feedback control. That's what we call the Padet principle. Recently, we published a book on the intelligent construction technology, just to explain all that. So let's start with the technology you all heard about. Automated machine guidance using 3D for milling process. And we talk a lot about the 2D and 3D milling back in May in the MTC and E conference. So this is one of the technology that we are focusing, I've been using increasingly, and also following the milling. There's also AMG 3D or 2D paving using those technology. You can do a better, more control to pay a high quality payment. So that's kind of our first dot here. We're going to start to connect all the dots together. And next, we now is a very high priority for Federal Highway EDC 6 to push the e-ticketing. And this e-ticketing technology is not just scanning the e-ticket into a PDF, but turning the information to electronic information that you can use in now the AASHTO new standard. It's called Material Delivery Management System that include, that will be published soon, that include 5 bubbles. That include the e-ticketing, loading, delivery event, order information, testing, contract, administration, and field verification, and also digital as bill flow rate. And that will be our next 2 dots. Why does it need 2 dots? Because our current NWRA project will not only manage implement the MDMS AASHTO standard, but also will interface with AASHTOware for pay items. Next, paver mounted thermal profiler. We'll talk about quite a bit in the first section. So this will collect continuously thermal profile behind the screen, and that give you indication whether there's an indication of thermal segregation. So that will be a next dot over there. And IC, we'll talk about IC today, intelligent compaction, that not only used for base, but also asked for compaction. And that will be our next dot. And DPS is this group. It's emerging, and then you're going through similar process that we've been through in the past decade or two for those intelligent construction technologies such as IC and TMTV. So that will be the next dot over there. And one contract that we currently sign up with the NWRA research project is to implement the 2D and 3D high-speed GPR that can be used in a standard platform. So that would be the next dot over there that give you a layer of specific information for contracting purpose or acceptance. High-speed profiler, inertial profiler, rubber, seen this for 20 years. So this technology has been used and proven. And we just mentioned about the NCAT, the DPS certification, pretty much follow the AASHTO R56 that we have been through for the past 20 years for inertial profiling and program. So that will be a next step over there. And you can see from the entire paving train, from the material production, delivery, laydown, compaction, and finally acceptance use or measurement using DPS for continuous dielectric profiling. And there are a lot of other emerging technologies still being developed, and that currently have been proven that we can merge and fuse those data using a standardized platform called Veda. So Veda, it really will connect these two, and finally, in the next 2 years, we'll move Veda from the desktop platform to a web version that can do a much better integration of all the technologies. And Veda has been existing since 2013, firstly funded by Federal Highway, and later on been taken over by the pool fund study. There's several millions of dollars already being invested. The current NRRA phase 2 has invested $1.5 million to further improve Veda in the next 3 years. That currently Veda is to import all possible brands of intelligent compaction data, all paper-mounted thermal profiling data, and DPS data also into the same platform. And you can see from here, this shows an infographic, all the construction, including the material delivery, laydown, milling, paving, compaction, DPS measurement, and this can be using the telematic. We talked about the cloud solution that data can be transmitted into the cloud, so it can merge all the data. So Veda, and with the Veda web solution in 2 years that will be implemented, that will allow any users to use the desktop, tablet, or mobile devices to access the data in real time. And this shows the infographic that Michael Johnson is going to show in more detail is all this stuff we're talking about have been implemented or will be implemented in Veda. And the blue one are the one currently in Veda. The green ones are will be currently in the current contract will be implemented in the next 2 years. And the brown one will be covering the next a modification. And the blue one, light blue one, will be on our wish list. So how can we connect to the BIM? Is to use Veda as the common platform, standardized platform, to provide the digital as built data for all these different intelligent construction technology data we're talking about. So that all the data can be connected through those standardized platform, and that will not happen if we do not use the standardized data. And all the data we're talking about from all the technology have been using MP39. MP39 is a standard data format have been implemented in Veda. And that's something in the future that we can also have a switch to IFC, which is International Industry Foundation class that can be connected to BIM. So the kind of 20,000 feet overview of what all these technology can be all fit together. Questions, comments?
Well,
Actually,
George, do you have a feel for when AWP and other Astro where management software will be able to be into data?
Very good question, Robert. Michael Johnson actually going to show more detail about how all these data marshalling among the different entities, including all the vendors, the system, and also inspector data. One thing important is to interface with Ashtaware. That we already have a protocol that we're working on using the JSON data format that we can transmit the data, can push back and forth.
1 or 2 years, right?
Sorry. We're going to implement, make everything work by December 2023. That's about a year from now. But we'll have the initial beta testing and working with all the vendor, and that by July next year. So is it all coming? And we're also working with DOT that do not use Ashtaware, that we can do other way of transmit data in between. And as I mentioned, the Michael Johnson going to do a much more detailed this presentation on how all this going to work together through what kind of standard and file, and also he's going to illustrate a very complete example how to process the DPS data in Vedos. Advertise the fee.
A lot on your shoulders.
All right, back to Kyle.
Thanks, George. That does a good job of kind of giving us an idea of where we're going as an industry as it relates to all these mostly continuous coverage type technologies. At this point, I think I'd like Forrest to share his screen and he can kick off the contractors. I've had a couple meetings with Forrest and they actually got the technology through the loan program and have been able to there we go, it's still in front of us. Good job, Forrest. So they've been able to collect a lot of good information, in my opinion, in utilizing comparison with IC and PMTP, which I think would be good for the group here. So this will be our first remote presenter. So please speak up, anybody, if there's any issues. Forrest, can you speak to make sure we can hear you?
Yeah, I can hear you. Can you hear me?
Yep, we can hear you. So go ahead and take it away, Forrest.
Also, what screen are you seeing? Are you seeing the large presentation here?
Yes.
Okay. Making sure I'm in presenter mode.
Yep.
Awesome. Well, thanks for having me. Yeah, today I just wanted to share our experience granite construction using the DPS as well as the IC and PMT technologies. So for starters, we actually loan this equipment from the FHWA. So without them, this little investigation for our internal use wouldn't have been possible. So thanks to them for that and all the help kind of getting us trained. As far as our project overview, we took this on 5 projects, a couple of those spanning multiple days throughout California and in Washington.
Hey, Forrest?
Yeah.
Are you advancing slides yet or not?
I am.
Okay, we're not seeing the advanced slides on our end.
Okay. Let me see. Oops. Can you see the advancement now?
Yes. Awesome.
Okay. So kind of just got to this slide. Thanks for stopping me. So all these projects were similar type of construction, kind of mill and fill, 2 to 3 tenths of asphalt. The only difference was the materials that we used. So our first project was more dense graded asphalt, kind of just standard. We then moved up into the Sacramento area, did some gap graded rubber mix, followed by some more dense grade in San Jose with some more mix additives in there. And then we switched over to Washington for some polymer modified asphalts and binders there. So we'll probably focus on the Washington projects because that's where we had all the technologies in one place. I just wanted to share some photos. During our first demonstration, getting together with the city of Bakersfield, Caltrans, and then, you know, we had a consultant come out and kind of train us how to use the equipment. So that trial went pretty smoothly there. We further took it out to the city of San Jose, did a demonstration with that group of individuals. Also had some of our non-nuclear density gauges out there. And then we moved on into the Washington. So this is on, I think, Highway 82. And then further, Highway 17 in Washington with some night paving. So we had a mix of day and night paving. So made it kind of interesting. Didn't initially have a light on the equipment, so that was something we had to kind of MacGyver into place there. Jumping into calibrations. So now we're just looking at our percent density versus our dielectric for the lab or puck kit calibrations. MnDOT let us borrow their equipment so we could do this. We also sent pucks up to the Washington DOT, and they further helped run a couple more calibrations for us. So thanks to everyone there, we were able to kind of get all the data that we wanted to collect. You can see we got pretty good R-squared values on these, and each mix ended up being pretty different from one another. So just really, it's important that we're doing these calibrations for each specific mix because there's not a lot of overlap with the ones that we collected. And then here we're just showing some core calibrations. These weren't as good. Some of the limitations here was that in many cases we weren't able to collect a wide range of cores. So you can see we've got a pretty not a great range there. The one project that I think was a pretty good representation and we got a lot of wide range of core data was on the San Jose project. So we had anywhere from 90% all the way up to 96% there. And that kind of gave us our best relationship. And then now just looking at comparing the two, core calibration versus lab calibration. We did this for that San Jose project and just wanted to highlight that we did see a little bit of a difference here. With the core calibration, when we had a 0.1 increase in our dielectric, we were kind of seeing about a 1% change in density versus with the lab calibration, we were seeing with that same change in dielectric closer to a 2%. So something that we noticed and maybe, you know, sounds like further research is going to get put into something like this and investigating. This kind of moving towards more of the interesting part of the presentation, at least I feel. We did some beta analysis with our data. First, we were going to look at the density and then the pass count with our rollers. So you see density on the left side of the screen, pass count on the right side of the screen. You can, you know, reference the scale here. We've seen density in the range of 89 to 91, and our pass count close to 4 to 12. So for this, we were kind of early on in the project. We realized that we had somewhat of a density issue. It was actually first identified with the nuclear gauge, but then later when collecting the DPS, we could totally see that the entire roadway was struggling. So we needed to make a change, and thankfully we have a good construction technology guy that works out in the field. So this is about a 1/4 mile up the roadway. We actually slowed down the paver, and we were able to, you know, try to get more passes with the rollers. So here you can see we've increased our density from that lower range to, 92 to 94 now. And our total pass count upwards of 20. And you can see where we had higher pass counts, we also had that higher density there. So I think the data here kind of speaks for itself, and I don't think the concept's new, but just being able to visually see it is definitely good. So another thing that the beta allows us to do is filter our data. So we're still looking at the density data on the left and still looking at pass count, but now we're looking at how many passes did we make when our temperature was greater than a specific degree. So in this case, it was 210 degrees. And for that first section, we were only making one pass when it was greater than 210. And then when we move further up the road back to after we made that change, now we're seeing upwards of 4 passes to where that material is hotter than that temperature. So kind of two things going on here. We increase the total passes, and we also increase the amount of passes at a higher temperature. What I'm trying to illustrate here is the difference between day 1 versus day 2 and how the IC kind of helped us out in maintaining our number of roller passes. So you've seen day 1 on the right side, and day 2 when we came back southbound, we were doing a better job at maintaining that higher pass count just because we were able to, continually use that IC. We didn't get the DPS data here, but I would assume that it's probably higher in the 93s and 94s like we saw further up the northbound lane. And the same goes for when we filter the data. We were seeing more passes at that higher temperature. So we'll transition a little bit now looking at the DPS data, and it's, and also side by side with the thermal data. So this is a different project. It was the one project that we had the thermal on as well as the IC. So there were certain situations where we had adequate pass count, but for some reason we were having these low density pockets. And as I advanced the slide, that was kind of explained by, now we're looking at temperature on the right side behind the paver. So we had a 50-minute paver stop here where our temperature went from being close to 280 down to 140, 160 in this this zone right here. So when the paver stopped, there's about, that white area is about 7 feet. So there was about a 7-foot section behind the paver that's exposed to the ambient conditions of the outside air during the nighttime paving. And that area really cooled off. And as we proceeded with the paving, we weren't able to achieve compaction in that area. And even here, you can kind of see that when you're looking at the reference to the DPS and density, it definitely extends a little bit beyond just that paver stop, probably because the rollers their rolling pattern gets messed up and they're not getting as close to the paver when it stopped right there. This is just another example, a couple 100 feet up the road. We had another long stop here. The plant was pretty far away from the project, so we kept having these issues. But same thing, we've got 140 degrees and we were at 260 before we stopped. Just another example, 30-minute stop. We didn't lose as much temperature here. So, you can see the density didn't struggle as much. And then here's a situation where we had a paver stop, we had adequate coverage with the IC and but this paver stop was only 5 minutes and we only lost about 40 degrees temperature here. So we were still able to achieve our compaction. So really the duration of the paver stop and how much that material cools off will influence how much density you're going to be able to get in that location. So the last thing I want to look at in beta was, kind of the density on the edge of the mat versus the center of the mat. So tried to show that here. We made 2 complete passes. So we went up, the inside part of the lane with 3 sensors, and then we turned back around and came about the outside lane with 3 passes. So for this particular section, what I wanted to do was just show that leftmost sensor, and we were on an unconfined edge here. And for this stretch of roadway, our average density was about 90 with a standard deviation of 1.8. So you can kind of see the zoomed in photo here. We're on the very left side, inside part of the edge. When we shifted the sensors, so we're moving a little bit closer to the center of the mat, sensor 2 and 3, you see that we had a pretty large increase in the average density. So now we're closer to 94%, standard deviation of 1.6. When we went onto the confined edge on the very outside part of the lane, similar density there, 94, similar standard deviation. And then again, back to the inside, average density of roughly 95. So there's a big difference here when we had an unconfined versus a confined edge. So, I think there's ways to improve that. I just wanted to share that data and kind of how it affected our overall density on the mat versus kind of edge and join. For this part, I just wanted to make some suggestions and observations, but as far as GPS is concerned, we did have a little bit of struggle figuring out the output configurations for the Trimble and TopCon. It was pretty easy to connect the unit itself to the DPS tablet, but understanding what the configurations were on the Trimble was a little bit more complex. So I think just having that information more readily available would make it just that much easier, because the Garmin connects super easy, and but it was a little bit more troublesome for when we wanted that higher accuracy GPS. Some other observations we made is, again, we have DPS data on the left, and we saw in some situations that the data didn't look right. With all these gaps and kind of glitchiness. And then when we referenced on the right side our collection speed, we saw that whenever we had these weird gaps, we had this inaccurate speed data. So the yellow's showing 2 miles per hour, and the purple here is showing a 500 mile per hour collection speed. So something was clearly off here. I think the reason behind that now, from what talking to a couple of people, was probably the DMI on the equipment. And then further showing that when everything looked good and all the data looked good on the density side, so did our collection speed data. Some other observations here was the dielectric quality. Just another output that you can look at when you're in beta, but on a flat surface, we saw that the dielectric quality was about 90. And when we went to like these super elevations, we saw that quality measurement dropped off anywhere 80 to 85. And we actually had 2 projects with this and kind of showing similar results between the 2. So there was something going on with that elevation, and I don't know how to explain it, but I'm sure someone who knows what the dielectric quality means could further interpret that. Additional comments, as far as the equipment goes, I think we all know it's a little bit larger, so it can be hard to kind of operate alone, and it is definitely time consuming to collect the data. But that being said, it was useful information. And I never actually tried to maneuver the equipment between equipment, just because it seemed like it would be hard to get out of the way if I was between rollers, and so I always just collected data from the behind the finish roller. And then I guess the last point here is having a light on the equipment would be nice. I didn't necessarily I'm fully prepared, so someone helped me out with that one, getting a light out there so I wasn't walking around in the dark. Yeah. On the software side of things, don't want to get too much into the weeds. I guess we could discuss some of these later, or if someone had some questions or wanted my input, but the one I wanted to focus on the most was the 0.4, which is just understanding when you're collecting good or bad data. Maybe this is partially a training thing, but there were a lot of cases where I didn't know if, especially the examples I just showed you, the dielectric quality or the collection speed. I didn't know that was happening real time. And yeah, so it would be good to understand when you're actually collecting data, if you're collecting good data. In many cases, we only have kind of one opportunity. So if you don't get it the first time, then you might not be able to get back out on the road with road closures and all that sort of stuff. And then finally, as far as considerations go, I guess when we're talking about quality acceptance and quality control, I think there's definitely a change in risk here. We're moving from just taking a limited amount of cores or density readings with the nuclear gauge to now looking at the entire mat and kind of taking a step back and reevaluating what our acceptance criteria should be moving forward, and researching that a lot, I think, is definitely important. I also think it's important to and evaluate that lab versus field correlations, and sounds like all this is kind of in the works and underway. So, and on the quality control side, the best benefit I saw was when we had all the technologies together, kind of gave you the entire picture of what was going on, and kind of really helped to understand what your root causes are, especially when it related to those densities. And when you're using all these technologies together, it's easier to make a change to your operation, and then with the displays and everything, kind of sustain whatever gains that you've made in your density, and moving on to multiple days of paving, you're able to continually achieve the same thing that the change that you made on maybe day one of your operation. So that's it for my presentation. Put my contact information here. I don't know if we want to take questions or just kind of roll into the next one and do questions afterwards.
It's a great job, Forrest. Really, really appreciate seeing contractor perspectives on these things. I even said Robert is just chatting away in here, and we will get to those questions. But I echo what Robert said at the end. Excellent presentation at work, because this is exactly the type of thing that needs to happen with contractors for us to get both the good and the bad about where we're at currently. And you had both. You had great examples of the technology being used to actually help with the process control, and then also some suggestions on what'll make it easier, because you're definitely not alone with your the needs that you have at Granite. I'm sure are going to be echoed by some of the other contractors. So great work. And are you able to stick with us for the discussion after the industry perspective? Okay, so then I think we will. Okay, so we'll save those questions for that time for now, just to allow our other two contractors to speak here. So why don't we go with Bryce? Do you want to go next? Sure. All right. All right, you were gonna get a recording from Bryce, but
Yes.
last minute.
I am a little jet lagged. I had a 4 o'clock flight to get here and I was an hour behind, but we'll make it work. So my name is Bryce Worry. I work a lot with contractors implementing technologies, up to 8 contractors currently. We've used the DPS with on projects for either forensic or to help with proactive quality control. So this is kind of what working with these contractors, what they've kind of said about the technology, how they like it, what they dislike, some projects that we have worked on and what we've got from the technology using it, and just kind of last year's projects, and haven't had time to put in some of this year's work. We just finished up our last project here, so starting to crunch data and numbers on that right now. So, we all know this, so I'm going to just skip that. We do use, as a contractor in a lot of the states that I work in, there's a joint density spec. This tool for measuring joint density is phenomenal compared to traditional nuke, non-nuke, where you might not always have a good flat surface to get a good reading, or it's hard to get a reading. So about 50% of what we use this for is just a single sensor shooting joint density. And probably 90% of the contractors that I work with, we use a notch willow joint for the paving and the construction. So just a picture of it running on the joint there. An example of some 2021 projects we got all over the place: Montana, Wyoming, North Dakota. Got over here just to eastern Minnesota, Nebraska, down to Texas with the Stone Matrix and a couple airports. So we've tested all kinds of different mixes. We do have the puck kit and have had great results with that. Absolutely love the puck kit, and our best results have came with more of the dense graded mixes, airport mixes, 4143s, where we get our best correlations. You get into the bigger aggregate sizes, 19.5. We've even been up to down in Utah, I think it was 1.5 inch size aggregate. And it's just the data seems a little more volatile when you get up to a bigger aggregate size. Oils can also do that a little bit, depending on what part of the country you're working in. Obviously, the oils in the northern climates are a little different than down in Texas, where I just came from. So each state kind of has to have their own understanding of what this technology is how it's going to work for them, based off of their aggregate sources, their oils, and just how they construct their roads for those regions. Because you can see huge differences from state to state and how you implement it and understand that is shown with this technology. Some 2022 DPS projects. Wyoming, actually on I-90, these projects were all within 20 miles of each other, with kind of the same similar mixed designs, different oils. One had wrap, but different aggregate sources for each one. One was a dolomite, one was a granite, and you wouldn't believe the differences in the dielectrics when we did our calibration with the puck kit. But the granite's more dense. We had a higher dielectric, some of the highest dielectrics we've ever seen, pushing the limits of 7. Where we get down to some of the softer aggregates, and we're at like 630 dielectric. So just within 50 miles, an aggregate source, you can see that much change in a dielectric. The North Dakota project was very unique. I spent 2.5 months on this project, 186,000 tons of mix. The only quality control tool we used on this project was the DPS. No nuke gauge, no non-nukes, nothing. We did we calibrated our plugs daily. 2 different mix, or 2 pits, 2 different mix designs. One with air separated dust, one with a wash dust. So we got a ton of data from that project, joint density, mat density, tons of data that we're still crunching on. But overall, this was the only tool we used for QC, was the PAVE scan. And we had a prototype there that I'm itching to talk about, but I have to keep my mouth sealed about that. We collected a lot of data with 2 prototypes on this project too that absolutely worked phenomenal, that I'm very excited to talk about when I can. So we also got out to Montana and a couple other airports too. So lots of data, lots of work. Just an example of the amount of data we collect with this, and we use this as a more of a proactive tool. We're using it to set up roller patterns. We're using it kind of like Forest at Granite. We're using it, we cut the mat transversely to look for roller consistency on the joints, pretty much right behind the finish roller or in front of it. We're using this proactively to make changes. And that's what I'm doing, is teaching these technicians how to calibrate. And when they find and understand, even just using dielectric, not doing density, like Toby down here on the right, he can walk and he can see a change. Well, if that change is out of our parameters, what we consider quality, then we can mark it and we can keep going, cut it transversely. Cutting the mat transversely is one of my favorite things to do, because that's, if you're working on a PWL project, you can look for consistency from one edge to the other. If you have good consistency all the way across that mat, it's a quick, easy way for QC just to see, am I lacking density in any of these locations from center line to shoulder? It's one of my favorite things to do for a quick check with QC with this tool. But we did scan a whole bunch of longitudinal and mat joints, a whole bunch of on the Highway 52 with 188,000 tons of mix, over 150 mat joint core locations were collected prior to extraction with both the prototype and the pave scan. And we're crunching that data as we speak. And there was 95 lane miles paved on this project that we used the DPS. We didn't collect data on all 95 miles. We just used it as a QC tool to make sure that we're staying consistent with our mix, with our rolling patterns. And we were using IC on this project as well. No thermal profiling or data or anything, but and one thing that is amazing about this technology is every contractor I've worked with, their first initial thoughts with it are, oh, what's this? This is going to show me all my defects. But really, it opens their eyes to, real-time data that they can see, make changes. It's a proactive tool. Once they get the hang of it and can see what it actually does, it really is a game changer for contractors. Honestly, every contractor I work with, once we start using this, the nuke gauge just goes away. And we're using it every now and again just to check. We find a spot with the DPS, well, we're just confirming it with a nuke gauge or non-nuke to make sure that, yes, this area is low density or we have an issue in this area. So that as a proactive quality control tool for contractors, this technology has a very bright future. And I feel like a majority of contractors in the industry don't even know it exists, really. I mean, the time I bring this out to contractors for the first time, they don't even know something like this exists. They think it's futuristic as this prototype. No, this is real. This is what it does. So the contractor industry is a little bit behind on it, and they always are a little reactive with technologies until they're forced to kind of use them. But I think filling that void and getting a push with these contractors and showing them how they can use it to benefit, to get incentives and build better roads and use it as a QC tool has a huge bright future for this quality, and will help the overall process of getting this technology out there to improve infrastructure in the United States and all over. So that's kind of the big thing. Improve quality control with DPS. Real-time data. You can't collect if you're looking for consistency on a PWL project with a nuclear gauge, and you got the timer set at 30 seconds or 1 minute. It'll take you. If you cut it, it's a 16-foot lane, and you're taking 5-6 shots. Well, that's 5 minutes to just get that one shot. You can take the DPS, cut that transversely in less than 10 seconds and see your consistency. So you collect a lot more data. You're making changes based off of real data that is helping you be proactive in building a better road. And that's what I believe contractors, once they understand that and see that, they already are, the ones I'm working with are using this for that reason. The real-time data just allows for improvements. in a faster manner, more data, you make better choices for what you need to do to improve the quality. Again, we use it as a QC tool for full longitudinal centerline accuracy. We have great luck with that. Core evaluation. Prior to extraction, a lot of times we'll shoot. The logistics are always kind of hard, but we'll shoot a few, as many as we can, just to verify when that core does come back, that we're within a range that we feel is acceptable. And we've had that happen before, where cores come back and we shot it with the DPS and we're like, that the correlation, something isn't right there. So we've asked to recore a location close to it that came back a lot closer. And was it an error in the testing in the lab with the core? We don't know, but we have had those instances before. And if we wouldn't have collected that data with the DPS, we would have never even thought about going and recoring or anything, or checking why did our data with the DPS tell us this was a 94% and it came back at a 92.1. So that's why we do a lot of the core evaluation verification prior to extraction. Obviously, we want to eliminate the number of cores, but right now with what we do and how our specs are, that we're still doing quite a bit of cores. And just in perspective on that 190,000 ton project, we had over 1,100 cores. That's a lot of holes in the road. So if we can eliminate that number with these technologies and use this data to just bring that number down to half the amount and feel comfortable with that, that's even a huge step for the industry and everybody. So those kind of steps towards with this technology, I believe are huge and what we should kind of work for. But using it as a quality control tool, absolutely love it. And this is an example of rolling patterns. How we cut that mat transversely to look for that roller consistency. Obviously, you can't cover the whole mat in one pass with a roller. It'd be awesome if you could, because then you don't have that inconsistency with thermals. And, the time it takes the roller to go up, see a breakdown and do its first pass and comes back, it's got to go over and do the other side and one pass up. Thermally, that mat's cooled. Even if it's only 10, 15, 20 degrees, it's cooled in that time. Especially if you're up in the northern climate, like here, where the wind might be blowing 40 miles per hour and it's 40 degrees. So with this technology, we can cut that mat and see, do we need to put tandem breakdown rollers to get that compaction right up front? Where are we lacking with our density? What's the issues? I've been on projects where the milling caused the problem. The mill came by and it put a quarter crown in the road. We were only putting 1.5 inches down in the middle of the road and 2.25 on the center line and outside. Well, that's going to compact different in the middle where it's only 1.5 inches. We could see that with the DPS, that the density was lower through this 5 miles of this road, just because, and when the course came back, obviously in the middle, we could see that they were lacking in thickness, and the DPS picked that right up. So there's a lot that you can see with this tool. It opens your eyes to things that traditional tools will not give you. There's not enough data with it. And when you integrate this type of thing with other tools like Forrest was talking about with IC and thermal profilers and anything like that, it's just amazing what you can do for quality as a contractor. It's eye-opening. And a lot of the contractors that we work with have went to using full-time IC on projects, even if they're not required, or they run a thermal profiler, just because it shows those operators what they're doing. It's not a guessing game anymore. It eliminates paver stops, it eliminates bumps. Well, all that does is increases the quality, longevity of that road. So in the contractors, the big thing with contractors is you got to dangle a carrot out there. You got to give them some incentive to do this. Contractors are it's a competitive bid industry. You have to kind of, I don't want to say force them, but you have to kind of give them something, a drive to make them want to do these things. Once they figure out how to do it correctly, they can realize they can make a little bit more money on incentives. They can get better ride, then it just kind of takes over and it becomes a norm for them. That 190,000 ton project, the contractor made over $750,000 in density and ride. And a lot of that was just on the way we did the quality control. And if you can, it's kind of a, if you can get good consistent density, the majority of the time the ride will follow along with it. So it's all kind of one, they go hand in hand. Some of the things with DPS accuracy in the field that we've noticed on all these projects where we've been working with different mix designs, fibers, a lot of other different things. The biggest thing that we've noticed is the larger aggregates kind of make a little bit more volatile data. The dense graded mixes we get phenomenal data on. We've had some dolomite, some different aggregates down in Wyoming that have magnetic properties where it was very difficult to get good consistent data. But once we kind of figured out what was causing it, we could combat it a little bit and understand what the data was doing. But we've had lime, evotherm, fibers. None of that seems to affect the data that we've seen. Nothing with oils, polymer versus standards. Doesn't really affect the accuracy that we've seen. The higher the AC content, it seems like the results of the DPS are better in the field, what we feel. And then base lift versus top lift. We get better results on a top lift compared to a base lift that's on concrete, or you have to really understand what's underneath you when you're putting that first lift on, because it can affect your DPS data. And then asphalt plant changes is a big thing. That's why when we do this, we use this as a QC tool. We're checking our daily plug, our lab tech. We take a plug every day and check it, because there's gradation changes. There's mix. We might be adjusting AC to get air where we need it. Moisture from rain, you're getting into a pile. All those things with the plant, even the production of the plant, will change that the dielectric a little bit. You can see it in the field. I've been walking on projects before where we got a dielectric of 650, which equates over to a 94, and we get a huge drop. And the rollers didn't change a thing. You know, we had an issue at the plant. We had a dry batch, or we got bad oil or something, or the burner went out and our temps went down. I mean, so this technology opens the eyes to the user to identify those things in real time as a QC tool. And that's absolutely amazing to be proactive like that as a contractor and do that. Some of the logistics, yeah, it's a lot of walking. You know, a lot of the projects that we work on out in the open, the contractor, one specific project, the contractor would not shut the plant down until he put out 6,500 tons every day. 6,500 tons paving 14 feet wide, you can't keep up. You cannot, no matter how hard you try, you just can't keep up. Especially if you got joint density, mat density, and I mean, it's just logistically, you can't do it. And there's a lot of those projects like that. So obviously there's a lot of exercise, there's a lot of staying in the safe zones, and there's a lot of hills and stuff if you're working out in the mountains, and it's just logistically you gotta be careful. There is some steps that we need to take to figure out logistically what will work best with this technology. That falls along with safety concerns as well. We had night paving on that one specific project, and we had to put lights on as well. We had headlamps, and it is a little harder to to see. Even if you do find an area that produces a lower dielectric, shadows and stuff can play games on your eyes, and when you look at imperfections in the surface and stuff, and it's just a little more difficult to use. And and you have to have a spotter. We always had a, what we call a crash truck behind it. And that's another cost to the contractor to have. It costs quite a bit of money to have a crash truck behind a quality control person pushing this at night. And so those are things that you have to take into perspective. Yeah, safety concerns, night paving, center line. Center line's hard to get sometimes with live traffic. So we have that. And these are just DPS logistic ideas. We have, if you run an ICR, you have RTK. So running DPS from the contractor's perspective, running it on something that's already producing, taking a piece of the puzzle out, we was running RTK, mapping temperature and stuff. This was been thought of before, obviously, and we actually tested this with a prototype. I want to talk so much more about this, but I got to keep it zipped here. And had great luck with it, and it just we're going to keep pushing this, and it just logistically fixes the problem, especially on the finished roller. The big issue before was combating the water from the rollers. Well, that equation has now been eliminated, and we've tested it against running it on the roller and then collecting the same data with just standard DPS after the operation, and the data is correlating right where we want it to be. So we've kind of figured out that piece of the puzzle. We linked it with RTK and did all kind of the same things with dropped a lot of the data on top of each other, found the areas of low density where the roller stops were, the bumps and all that. And it's just a kind of you already have this tool out there, the roller. A lot of the times they're running RTK already. You have that machine running. It's just kind of, if the contractors are going to collect the data, this is the way. The industry is lacking hard on finding good help right now. A lot of times the QC person is the project foreman, or if you're out coring, that QC person is going to go do the cores. Well, then there's no QC person actually doing their QC job behind the rollers. And there's just a huge lack of good personnel in this industry right now. So adding another person to push a cart and do it all day is hard on these contractors when they're already doing 3-4 different jobs. They're running a paver, running the rollers, and I'm doing QC. It's usually one person doing all that on a lot of these projects just because they're spread so thin. So for the future, I think figuring out the logistics part of it is going to be huge for contractors, especially if they're going to be required to collect the data. They're going to find the easiest, cheapest way to collect the data. So some of the pros, the full assessment with continuous coverage, using it as a proactive quality control tool. Contractors love it for that. And a lot of times I'll get a phone call, can you bring that fancy tool out? We got some areas where we failed a lot. Can you come look at it? And they don't even know what it's called. They just call it the fancy tool. You know, so I think enlightening the contractor's perspective on a lot of this and getting them more involved with it and understanding how it can help them is going to help overall the whole process of this tool and the future of it in this industry. So it's non-destructive. Equipment and programs are pretty user-friendly. Generally, within a half a day of training with a technician, they're comfortable with taking it and doing calibrations and understanding the data, not just following, and it depends. A lot of times I just run dielectric for a QC tool. We'll create our own calibrations. We don't have plugs right away when we're doing testing, so we'll create our own calibrations, and I'll give them ranges of stay within this dielectric. If you see a drop here, or if it's a PWL project, we want to stay here within these ranges because we know that's going to equate to this density. you don't have to really get into full detail of how it works with them, but they have to understand what they're seeing to be efficient. And once they understand that, it's pretty simple. So some of the cons, logistics, cost. Cost is going to be one big thing with contractors. They don't have the people maybe to operate them full time, so it isn't the cheapest equipment in the world. It is kind of, you got to dedicate one person to running it, managing it, taking care of it, updates, all that kind of thing that go with technology. Safety, obviously with night paving and trying to keep up and having a crash truck behind it. And then the accuracy and calibrations have gotten a lot better with the introduction or having the MDM. But there's still some variability out there that we've seen a little bit in the field. And the field conditions are the other thing. Paving is done in an environment where the weather controls everything. So you get rain, you get snow, wind, all that. You can't, well, especially you get moisture. You can't run your DPS. So it's pretty much back to the old ways you're doing QC or what you're doing. And that gets tough because especially up in the Midwest and some of the higher elevation areas, there's rain or snow. You go up to Washington with Forest. I mean, there's rain every day, every other day. It's just kind of one of the cons of it. And I've ran into that too, where I've driven 8 hours out to a project and it rains for 2 days. Well, I can't even effectively use this tool with those conditions until it dries. So just some food for thought. I think that's all I have. Yep. So yeah, that's all I have.
Great job, Bryce. We have Matt Ullman coming up here. It's just outstanding to hear about contractor use of DPS. So thanks for sharing that, Bryce. Look forward to what Matt has to say always. And then we'll please save and think of your questions for all three of these guys for the discussion that's going to come in your industry perspective. So.
Well, thanks, Kyle. Again, I'm Matt Ullman with NAPI. Some or most of you probably heard me talk last year, so I tried to come up with new things to talk about. So I just, as I showed up this morning right on time, I finished this morning right on time too. So I'll be going through it for the first time, just with the same time you guys are. So
it'll be fresh. Yeah,
right. So this year we did a couple change order projects through the pool fund. First was on Goodhue Cassat 14 and then Highway 52. They're both part of the design build project. We picked this one just because it was completely closed to traffic, which, like people pointed out, the safety is kind of a big concern. So in this case, we had the sites to ourselves. So that's why we chose these projects. They were placed in 3 lifts. So in this case, we did training on the first day, and that's a big part of it. Between connecting everything, getting all the files named, everything's all part of that training. And then we did collect data on the 26th through August 1st during production. And MnDOT was there doing some side-by-side testing too. And of course, just like last year's pool fund, MnDOT has been doing all the data analysis. So I'm really not going to get into much data in here. And I'm guessing maybe this afternoon, Mike, Kyle will be talking about some of that. So if not, we can do that next time. So training. So the guy on the right was the one that did a lot of the testing last year. Now Kyle calls him
Captain America.
Captain America. Yeah. So you'll see that in a second. But so we're passing on the training. Once you get familiar with it, it is, you're pretty good at it, but it does take a little bit of time. So here's some of the file naming. You can see that it's just like a lot of the data files, but if someone sees this for the first time, that's a lot to take in. So we have these little cheat sheets to help with the namings. And when you do this work, when you call something what, and I think for the most part, it was done fairly well, but that's just part of the practice is that we want Kyle wants this thing not to struggle, but to go through a realistic test, see what sort of mistakes may maybe just be natural. So in this case, we'll call some cross training. You'll see if it works. In the distance is MnDOT on a Segway, and in the foreground is Captain America running. So he's in the National Guard, so he's doing training all the time, and so he's in very good shape. He's young. Me, on the other hand, I'm just too old, too out of shape, and too many bad joints to do that. So that's not the solution to this, but for us, it seems to work on these projects. But then, as we'll see a little bit later, that he wasn't available for the second. So it's setting it up in the lab. We've done this before. It's actually fairly easy if you just set it up in the process, and it really doesn't impact the technicians in the lab much. Everything I try to do, I try to minimize any impact to their routine, because they know what they do and they know how they do it. And so for this, it actually works fairly well. We probably do get some mistakes, but
The same person who's running the pucks anyway, or did you have to add people?
same people. MnDOT has, as Kyle's probably pointed out before, has had success with the core drive. But in our case, especially with some of the aggregates we have, I found that we want to just make it prior to dunking at all. We'll do that. And I'll show a little bit later what more missing a core drive is. So the second job we had was, this was live. This was under traffic with flaggers. And there was a 2-lane portion and a 4-lane portion. So we strategically selected only the 4-lane portion because the 2 lanes are really almost shouldn't be, at least in my mind, shouldn't really be used for this technology. So we did limit it just to the 4 lanes. And this one had some main line with mill and overlay. Some shoulders were part of it too. And because I picked that 4-lane only, it was maybe 2.5 miles long. Because I picked the 4-lane, I was kind of stuck with whatever timing we got, that's what I got. So in this case, the testing was done in October, middle October, so it was cold and rainy, so we had some downtime. And then on the 14th, we did have snow.
Yeah.
So that shut down paving by 10 o'clock. So we'll see some of that. It's in pictures here, but again, MnDOT did the data. But so the GPS, so in this case, because it was October, all the students had gone back to college. So I was the guy. So I was the one collecting this data. And I'm not a GPS person. So you can do a lot of this, but you've got to troubleshoot on the fly. Just setting up all the ports, going through the GGA, setting that up with the NMEA strings, using hyperterminal to check everything. That's the picture at the bottom. And then going through and setting it back up with DPS equipment. So it's not difficult, especially if you know what you're doing. But in this case, I was the DPS guy because I know that, but I don't know GPS. So now maybe I'm the GPS guy. So as it was brought up earlier, I worked with a contractor, but they didn't bid it knowing that I was going to be doing this. They've got their schedule. They go at their own pace, and that's the realistic part of this we're looking for. So I got out there to look at this, and of course I've got about 10 feet of pavement to measure, unless I want to move all those barrels. So this is a new one we learned this year, is that we may not always have full access to what we just paved, because they'd already switched the other side over. We're paving, you can see us paving the other direction on the other side. So in this case, either you just get narrower coverage, unless you want to move all those barrels, but then you're moving into traffic. So just narrower coverage, and then you've only got one joint too. So with this, Kyle said this is all good data because it's new. We're learning. We're just thinking of all these scenarios. But in this case, we didn't get full data. So here's another one. This was after the snow on the 14th. So that time I decided to move the barrels. And then of course I discovered water under the barrels. And you can see on the bottom that caused a lot of spikes in the data, which probably on a very large scale, look at the data, you wouldn't notice. But if you're looking at very specific data, it's of course a lot of garbage in there. So it's just another thing we had to consider, was capturing that water onto the barrels. So now in this case, it was cold, and I'd collected data all week, and I'd collected data all season, and I hadn't had any problems. But in this case, on the 14th, the last day, I was getting a lot of files that were just disconnecting this one specific sensor. So when that happens, the file stops instantly, and you lose the data that you collected. And then when you come back in, you've got to re-enter all the file name, the lot names. You can remember those cards I showed, you've got to retype all of that or copy and paste it from somewhere else. So it gets to be very time consuming. I think on that day, I probably had 25 to 30 disconnects. And as I talked to Roger before, it's temperature related. So in this case, we had great service and they sent a replacement sensor right away. It still impacted the data we collected for that project. But here you can see it works. So you hit the button and it just kills it and comes back out. And you can see it reconnected right away. So it sounds like it's a hardware component that was, and it's temperature related. So like I said, we've got this addressed, and at least for now, we've got two sensors that may have the same thing.
I have to give Matt credit because he called me probably 5 or 6 times that day, and each one was like incrementally a little bit more distressed, but the guy's like cool as a cucumber out there. Unbelievable.
Well, yeah, I was getting a little frustrated, but Kyle said, no, we're good. This is good. This is all we're learning from. Learning, good to learn. So here's just some miscellaneous thoughts. So until this year, I had never really checked the angles. And talking with GSSI, they had sent me the measurement tool that you can see on there. And so on the left picture, that's measuring the cart, which is at 0 degrees. You can see all my sensors are at 3.7, 2.8, 4.3, which is good. I don't know. It doesn't matter. Maybe it does. So then you look through, they've sent the field level calibration procedure. And in that case, on the bottom, you can see it says they all have to be within 0.3. And so for whatever day I had taken those pictures, I hadn't adjusted those angles. And I looked at them later on in the season, and they were all at like 0.3 to 0.8. So they seem to almost change. And so I'm getting some nods that others have experienced that too. So then my questions on here is, this would be technical people, but how important is this angle, and can the data analysis actually just account for it, or is it kind of, if it's not within that 0.3, is the data almost not bogus, but is it too far off? I don't know. That's questions that we can talk about later. So again, like the contractor side of it, we want to make things quick and really minimize impact. So this was one where I had the field or the lab equipment from Kyle, and I want a bridge deck here. And I started had the pucks brought out there, and I did it in the morning, set it up, and took off. And it worked great, except that I learned the next day that there was still some moisture in those pucks. So I had a shift in my data. So everything I said was completely wrong. So the lesson learned, I dealt with that before with moisture, where I kept moisture in pucks 3 or 4 weeks. My weights, yeah, high weights, and I knew the weights hadn't come back down, so it's been 3 or 4 weeks. But others, depending on the aggregate, hadn't seen a problem with it. So in this case, I thought they'd be fine, but they weren't. So the lesson learned is basically just assume there's water or do the core drive.
If you've already done it.
But in that case, I was out there. They came from the lab. I was trying to be as fast as I could and test them on the fly and then go. So if there was an adjustment factor you could do to the data, then it would say you've got 9 grams of water. I don't know. That's not yet. So here's another one. This is probably going to violate a lot of rules, but so in this case, you can see the QC technician up in front, and then I wanted to create as much value from this as I could without adding any more work for that. So he's doing his work. He's doing his normal checks, and I came along behind, and you'll see in the next slide, I took his measurements that he'd written down, and then I took my measurements from the DPS and created curves. So you'll see, of course, you can't see this, but that's a nuke, not a non-nuke. So there's a lot of variability just in the measurement itself. And then you also see that I'm not landing exactly where he is. So sometimes I wouldn't even include it, like the one on the right picture. I didn't, of course, look at that other measurement. It's not even close to his. Yeah. So I picked all these and I came up with 14 points just to test this out. Yeah. And I used 9. So the picture on the left, you can see you can take some of them out. And some of these are clearly either the nuke was way high or way low. So I can see they just didn't follow. So I wouldn't say I fixed the curve, but I basically visually looked through it and found ones that just didn't jive with the rest of them. So in the end, it worked okay, and I gave me numbers. So again, as the contractor, we want quick results. What am I getting? How's it look compared to what we're looking at? If you're doing acceptance, of course, this is not going to work. So just some thoughts on the moving forward part. So take good notes. As I think it was Forrest maybe said you can't take notes during the thing. So I learned this time trying to put this together. I'm like, oh, I got these great scenarios that happened, but I can't remember. I got hundreds of files, but I can't find them. So just take good notes. The Segway works for research and MnDOT, on the projects that they've used it on. But I just personally don't see it being a tool that a contractor will select to be cruising around a live construction site. But that's just me. I mean, I can't speak on behalf of all contractors, but for me, we've got the equipment, but I don't have GPS dedicated to it. So I always rent the GPS. So the pinch point for me is always the availability of that GPS, because they only have one or two of the because there's newer GPS that doesn't work with this. I think it's the R8, I mean, not the R10.
And the moving time window.
And so in this case, yeah, the moving time window, I had to push it a week, push it a week. So it's just a balancing act between that. So on the flip side, if we were to buy one, that's just another cost that goes into this. So it just adds fuel to that cost fire that Bryce mentioned. And then as coincidentally enough, I actually had out there, is there any way that this could be done without high accuracy GPS? So we've got the little Garmin, the one that was on the left of that picture that Forrest showed, and that works perfectly fine for everything I do. So in the case if you don't need GPS, all I really use it for is to make sure it tells me, oh, that's what the job I was doing, part of the job. So it's really just different uses of what you want to do. So as a contractor, I want to maximize the QC data collection efficiency, because they're doing so much already that try to maximize what they're doing efficiency wise, and minimize anything new that they have to do. And then on the other side, minimize the DPS post processing, because there's a lot to it. So everything I do, a lot of times I might not even save the file. I might just be out there looking at the data, find what I'm looking for, find a high spot, low spot, check it with a nuke or non-nuke, and then I'm done. I don't even save anything. So on non-DOT change order jobs, I use this thing completely differently than we've used it in the spec. And that may be the case for other contractors too. Again, I'm just wondering, but we would use this completely differently on our own accord. So then there's just some ideas that, so alternative, maybe if you just randomly sampled 528 foot sections throughout the day, if you paved 2 miles, maybe you sample 400 or 500 foot sections, which you could collect a lot quicker, a lot more efficiently. You're still sampling a lot of data. As long as there were no mix changes, you'd probably be capturing everything you needed to see. And then if you could do some disputes, could be additional sampling of more sections, or you could do coring. There's other things you could do. This is just an idea to get past that, the need of walking 3 times as far as you pave, all that. So again, certainly not on behalf of all contractors, but based on the way it is today, this technology, this to me feels like agency or consultant testing would be the way it would go as the acceptance tool, because contractors have a completely different desire for this equipment. So if they're buying it, they want to do their stuff with it. That's just how I'm seeing it right now. And if this changes, I know Bryce mentioned real time. When I write real time, I mean like behind the screen and doing hot measurements between pass 1 and pass 2. I want to get up there, and that we can't do with this. So just kind of the generic summary of it would be absolute measurements with validated sensors and you name it, high accuracy GPS. That's the QA or the acceptance part of it. The relative, if I just took it out of my trunk and just walked around here, it doesn't really matter what it says. I'm looking at how's it different around here? And then I can check with some other device why that is. So that relative numbers is what I'm looking at. So to walk out the room is like a lot of this technology, the IC or PMTP reticketing, there's a lot of project selection. It says you need certain such and such criteria. And this would be the same kind of thing. I don't think this should be a blanket application to all jobs. But that's just me at this point. Again, if the technology changes or the equipment changes or whatever, if it's mounted on something different that we can't hear about yet, that would that may take care of this anyway. So that's it.
Well, thanks a lot, Matt. I appreciate getting all the feedback about the bumps along the road. No pun intended too, because I think that's critical to hear that stuff before we're saying you must do this, right?
And we can disagree about certain aspects and talk about it and figure it out. So that's part of the reason we have meetings like this. We need to move on to our industry perspective. So I see you feverishly writing notes over there.
I should probably grab them. But
You want me to grab them for you?
no, it's fine. I'll keep this short and sweet. Again, my name is Brian Nagel. I'm with Caterpillar. That sounds weird. We've pretty much covered everything I was going to talk about in here. Maybe I'll kind of recap a couple of things that I tend to see talking with customers, dealers, contractors. I think my perspective is maybe a little bit different than most in here, but obviously Bryce and Matt and some of the other contractors that we've talked to and heard from, I still talk with customers that don't know what IC is. And it amazes me to this day that that's still something that's not as widespread as a lot of people that are close to it think it is. And you take it one step further now, and this is like, it blows people's minds when they think about it, right? They just assume you can't measure density other than with a new gauge or a core. And so when you start to talk about the ability to measure it on the fly, actively, however you want to think about that, it starts to open up a lot of opportunities. I think my perspective on it, I guess from an industry standpoint, is we can use it to try to replace what we're doing today. So you think about going along, taking cores, snoop gauges, taking readings. In its most simplest sense, it could be just another tool just like that. Some people love data, some people don't. It's great you can map out density of the road now, but do you really need to? So it's not that we want to go backwards in technology, but you could just replace what we have today with this tool. You're going to get more data points than you are today. And then it's just a matter of scaling that. How far do you want to take it? Do you want to get this level of reading? Do you want to take 10% reading on the road? Do you want to get 100% coverage? When you start thinking about it at those different levels, that puts it in a better perspective for that contractor, depending on what they're after, what they're looking for. We've got contractors that are just there to paint it black. We've got ones that are really trying to do a great job, right? And so they're going to have a different perspective on how much they want to invest in the technology in terms of what kind of value they think they're going to get out of it. We have a lot of contractors that have, I would say, refined their process enough that they aren't going to want to try to get a full road scan. If they have to, they will, right? But they have dialed in their process and they're consistent enough that they are confident in what they are doing, that they would be fine just taking a couple data points. And even if they couldn't see what the full scan looked like, they could probably tell you pretty close what they thought that would be. On the other hand, we have other contractors that really need a tool to be able to improve their process. So overlaying this data with the rest of the IC data and the IR data is like the most fun part about it, right? To be able to draw correlations that maybe in the past, without the density numbers or the map, we sort of guessed at. We had a pretty good idea, like, hey, you had vibe off here, or here were some low temps or paper stops, and you're probably gonna have some density issues. But it's really challenging to draw the correlations without taking a ton of different core samples or measurements out there. So, you know, you kind of have to approach it from a couple different perspectives. So as we think about rolling it out, obviously there's all of the challenges in terms of the technology itself and its limitations. You think about how rugged it is. There's all the safety concerns along with someone pushing a cart. Do you automate it? How do you address all those different things? It's almost a totally other set of topics, if you will, as we think about what this group is focused on. I think the big portion of it is how do we actually implement it, and do we allow it to be flexible? I think with what we've seen and what we've heard, there has to be some flexibility, right? You have a rain day, you can't just depend on this for your measurement. And so there's going to be all those different situations, and then you factor in what that customer is looking for. In the end, density is what's important, right? And setting what the expectation is. We have today where you're measuring almost none of the road's density. How far do we want to take that in terms of saying this road was done properly? And I think that'll change over time as we implement more technologies, as things get better. But I think we need to step back a little bit and ask ourselves, what are we truly after? And we're after getting a better idea of what the density is, but how much constraint we put on ourselves
is a really important part of that to make sure we're getting the value out of it. I would love to say, hey, every road in Minnesota or in the United States needs to have this on it, and let's make sure it's a really good road. But if you look at where we're at today in terms of how much we're measuring to verify density, it's going to take a few steps to get to, no, we want to be able to map all of it. And I think part of that comes into just the cost and the complexity of being able to do that. The fact that IC hasn't caught on as much as it has already. I mean, it's awesome to see where it's even come in the past couple of years, but we still have a long ways to go just with that. And I think this helps that story. In a lot of cases, I think it eliminates part of that story or the need for some of that if you're measuring actual density. But I think we just have to be cautious of how we implement this, because change management is really hard. And I think it's taken a long time for IC to catch on because it's complex, because our contractors have enough going on, especially if we're putting a separate vehicle or checking device out on the site, whether it's autonomous or if someone's pushing it. It's just one more thing to invest in that's out there that contractor has to think about what kind of values. There was a lot of talking. I think we all share the same perspective on a lot of this. It's just how to wrap our heads around it and implement it effectively. Because it's so exciting, but kind of it in a nutshell. I wish I had something fun and exciting to tell you or show you from Caterpillar, but we're all in the same boat, right? This is kind of evolving and we're all learning, and deciding where it goes, I think, is the important next step. Educating is the most important part. There's so many people who have no idea that this is even out there, let alone how you would think about implementing it, or that people are implementing it is a big part of that story.
Great, thank you very much. So we have 15 minutes here, 14 minutes now to kind of have a little bit of an open discussion with, I listed contractor, consultant, inspector, industry, open discussion. And I think it's a good idea to start with some of the questions that we didn't get to for the contractors. So Robert Hinman asked, this is for you, Forrest, for the DPS PMTP comparison project with the paver stops, did you use WMA or MTD/MTVs? And then, okay, we'll start there and then we'll get to the next one. Robert,
yeah, on that particular project, there wasn't more mix additives. And then as far as the material transfer device, I think we had end dumps into the MTV, which then into the paver. So we did use that on both the Washington projects with the IC and PMTP.
Right. Does that answer your question? All right. And then we also had a follow-up was, do the state DOTs use percent within limits for density acceptance or acceptance based off average density? And actually Dennis chimed in, approximately 32 states currently use PWL for acceptance and payment for density. The rest use a variety of quality measures for density. And I think that was a good topic to bring up, because I think when we're looking at use of new technologies, we need to be able to compare it to what is currently in use. And that makes a big difference, whether a state's using PWL or average densities. Even with Matt, when he chooses to use DPS or not on projects, just how that project is set up, whether there's test strips and all that kind of stuff makes a difference. So anything else, Robert or Dennis online, you guys want to add to that?
I guess one thing I want to add, this is Forrest, with at least our Washington trial, they do a test strip and calibrate their nuclear density gauges to the cores. So I did a calibration, obviously, with the cores, and then, kind of just on the side, I forget who was talking about it earlier, maybe Matt. I also, did like a calibration to the gauge, because that's kind of ultimately I wanted to see where we were in reference to that. So Yeah, they're paid based upon what that nuclear density gauge says.
Great. Anything else to add on that subject? Go ahead,
Well,
Ruth.
just to compliment that, Wisconsin does the same thing, especially on the PWL projects, is that you have to correlate your gauge to the DOT gauge, which has to be correlated to a standard.
Right.
And the key thing I think that we're seeing here is you have to have a universal reference for agency in the contract.
Yeah.
Kyle, you want to repeat that for the people online?
Yeah. Were you guys able to hear that online, Irv's comment? Okay. So for everyone online, well, why would I explain it to them online if they can't hear me either? Can you guys hear me online?
I was able to hear.
Yeah, I could hear Irv just fine. Thank you.
Okay, good. Thanks. I thought maybe there was an early lunch going on there or something. Another question we had come up, Forrest, any thoughts on using PMTP and DPS? This is from Dale Peabody from Maine. PMTP and DPS as quality control tools. I'm assuming these projects were DOT specified. Are they worth contractor investment?
Yeah, I mean, these projects weren't DOT specified. You know, we just had the opportunity through the equipment loan program to use the technology. So we wanted to kind of make the most out of that and bring it to a couple projects. And I think for our own internal purposes, I think we collected a lot of good data that we can share amongst our organization here. So I think it was definitely beneficial, but you know, I guess it depends what you want to use it for and if you find value in it yourself. So
Yeah, really good. Any other questions from the group for the presenters?
Thanks, guys. Excellent presentations from contractor perspectives. I'm one of you, and I can echo a lot of what you were saying related to sensor dropouts.
Can you introduce yourself?
Oh, yeah, Rich Hamilton, Advanced Testing for New York. So we do all the testing, or most of it in New York State currently for the last 3 years under special provisions for New York State DOT. So I can appreciate the frustrations with the sensor dropouts, which is something I believe Matt had mentioned. Another thing Matt was talking about was the angle of the sensor. And that has been a big deal for us. We had some data quality issues, which the operators were unable to identify in the field. In post-processing, we were able to see that separation. So ever since then, we've been bringing levels with us to the field every day. And one of the things we found with the GSSI RDM unit with the articulating arms, those Allen screws, you really got to pay attention to those, because as you walk throughout the day, those wings are flapping, and that flapping motion actually changes the angle after a certain time. So we've seen, like, after lunch, our data quality drop because we've had a whole 4 hours of walking back and forth with this thing. So I think that's something that maybe in the design needs to be addressed. But my question specifically, first for Bruce, you mentioned 1,100 cores on one job, and you're shooting all those with the DPS? Okay, so my question for you and then for the group in general, what is the correct protocol for making a measurement on a core? Do I use time or do I use distance? Or do I use both? Do I use an average of several? We've tried an average, and frankly, I see some quite dramatic differences between static and time or rolling rather. So that's concerning. The other thing I wanted to ask with respect to your daily puck, you've got an NDM at the plant, I'm assuming. My company handles multiple projects throughout the state simultaneously, and I am unable to do hot correlations on a daily basis. I need to do them before the job, and that's a logistical nightmare. I need to get the correlation established, and now I need to be able to tell my client what's the density. If you're doing them every day, I guess my question is how much of a mix change affects that correlation? And I hope this isn't going to be the answer from the group, but do I need to consider doing that on a daily basis? Because that is going to be a nightmare logistically. So I hope that's not the answer. I hope we can get a correlation established and run with it unless something dramatic happens throughout the production. But that right there, if I have to have an MDM in every plant make a mix for every job I'm covering throughout the summer, that's going to be nuts. And then for Matt, you had mentioned the training, and I think that's a very important aspect. We've struggled with that, particularly, and no one has mentioned this, establishing the lateral offset from the reference. That thing is so confusing, and I've developed illustrations to try to guide technicians, but inevitably, someone on a job is going to pick the wrong side of the reference line. And now I have to go back and, in Excel, change all that data, which is very, very difficult. So if they could just somehow make that simpler, in my opinion, would be a huge help. But my main concerns here are, again, how to establish core measurements in the field, whether you use static or rolling, and then this issue with the angle of the sensor affecting data quality.
So a thought on the MDM at every plant. You think about e-ticketing and where that is and where it's going. It might become the norm that every plant has one, right? And it's part of the data that gets transferred with the load of material to wherever it's going. So as some of these technologies become more common in the industry, for a plant to invest in one to say, hey, if you want to sell asphalt to us, this is the number we need. I can see that being kind of where some of the industry starts to change their thought on some of this as data becomes more important. I don't know when paper tickets even started, but I'm sure there was pushback from the plants to say, well, we're giving you asphalt. Why do you need a ticket on what it is? Just trust us. So as we need the information more and more, maybe that's one of the solutions to push that.
Real good question, say Rich. I think from the perspective of core measurements, I'm thinking right now that you need a distance-based measurement across the core. The trouble is you get some variability, and just making a time measurement at one point is potentially fraught with error. Because you can move it an inch and you're going to get a slight change. And when you have larger aggregate, it becomes dramatic. Clearly distance-based.
Yeah. Yeah, I can confirm our experience has been better using the distance-based for that. And I think Craig Landefeld, if he's still online, has had a similar experience with that. Probably due to what Roger said, where especially if you have like an open graded mix or large max aggregate, depending on just where you are, can affect the measurement. And that's kind of comes back to what I kind of started to touch on earlier with using spot checks to evaluate the correlation in general. Dennis mentioned that 32 states are using percent within limits using spot checks with cores, and then extrapolating up, assuming a normal distribution, what percent is within limits. So that's where I'm thinking logistically, Rich, maybe you can comment on how much it would help with your operation if we didn't do those spot checks anymore and took our distribution that's developed by collecting all the data, or basically full coverage measurements with DPS, and then doing our correlation based on the distribution of the dielectrics and then the distribution of density. In this case, the limiting factor is the number of cores that you're using to create that curve, but that's existing, that's what we're using right now already. So that might be one thing we need to kind of look at as a group, how we might attack that challenge. But were there any other questions that we haven't talked about yet, Rich, that you brought up?
The angle and the.
Oh, yeah, the angle, yes. And that's something where whether it's the angle or the height of the sensor, or that, there's a lot of different ways, similar to there's a lot of different ways to build a pavement with pore density. There's a lot of different ways to collect a pore dielectric. And that's why we're hopeful with this standardized material that, if you do that process, hopefully just at the beginning and end of the day has worked for us. Whether it's an angle issue or a height issue or internal temperature of the sensor issue, that's something that you're catching with that standardization process, and that matches what we do in engineering is we take imperfect measurements and then we use them to get a good assessment of the pavement. But really appreciate you giving those comments, because these are the things that we need to start to think about and address as a group. And we can go way into the weeds with use of the technology, how it's different if you're going to do quality control or you're going to do quality assurance. I mean, the only thing I'll say on that is that while there are differences, I do think that the more experience we get with using it as a quality control tool will help answer some of those questions that we need to make it quality assurance. So I don't like thinking about it as one or the other, even though you kind of do to a certain, because I think we need to get it out there to know what we don't know, right? and that's part of it. And you can only get it out there if there's value in getting it out there. And that's why, kind of want to bring in quality control, even if we're testing it out for future quality assurance. So, Di, did you have something?
Yeah, just one question for Bryce. Just one question for Bryce. You mentioned about the DPS has better measurement than the top left and the bottom. Can you think of the reason why is that? It's because thickness.
I guess to be more specific on where we've noticed the most, 1.5 inches less material compacted. 2 inches or more, we don't see it as much, but it's just collecting data. We've noticed going from a base lift on top of concrete or an overlay, even in the same project where there's different sections underneath that first lift, we can see data volatility, especially with a thinner lift. I don't know if it's reflection from the going through with the radar, getting into that next materials or what, but we have seen that, and it's in a thinner lift, 1.5 inches or less. Yeah, we've done less than that too. So, but anything over 2 inches, we really don't see it as much. But anything less, we have.
And that's consistent with the NCAT that they send laboratory testing. 2 inches and minimum thickness.
And where you really see it is if you're doing an overlay on a cracked seat, PCC concrete, or something like that. Then you'll really see it. Not so much on a milled surface or an existing asphalt surface.
Thank you.
Jacob's got something.
So a quick question, I guess, for Matt. I noticed from the pictures that the MDM was on a metal table. Did y'all find that affected the readings at all? Or?
necessarily, but I haven't gone through the data. Yeah. I didn't notice anything looking at the data, just day to day kind of going through it, but I also haven't gone through to compare the final analysis of it all.
Yeah, you're talking about if it's the kit where you have the sensor sitting upside down and there's a metal table below. Yeah, we haven't seen an effect, but maybe Roger should comment on that.
Shouldn't be any effect at all.
Yeah, okay. It has to do with being within the time window of evaluation.
And the way the measurements are made, we do two measurements and subtract one from the other, so anything in the area should be subtracted. It doesn't change.
Bryce, I think it was in your presentation, you mentioned something about some aggregates with magnetic and some changes in the data, and until you realize what it was, you can adjust for it. I just wondered, in northeastern Minnesota with the high iron content and some of the aggregates up there, if we've experienced anything like that or done any testing up there.
GPR doesn't like taconite.
We don't have it.
But John Garrity assured me we're not using all that much taconite.
Like not on the DPS, on the other SVD GPR, on the middle section, it was a taconite paving section. Could not see anything beneath the pavement. Anything reflected.
So this was on a Wyoming project that we ran into this issue, and what was happening, how we noticed it was the settings on it, on the top pad looked only a 7 dielectric, correct? And I think I called you on this, and I was getting readings where I wasn't collecting anything but dielectric, and I'd move an inch or two forward and I'd get a 6.9 dielectric. And it was confusing why was this happening? What we had to do was go in and change the upper limit from 7 to 8. And then I could see we were getting readings of 730 in this one location. You'd move an inch or two away from it and you'd be back below 7. Well, that was a piece of, I think it was dolomite, if I'm not mistaken. It's got magnetic properties, and it wasn't a lot of it. It wasn't, but you knew when you'd hit one because you'd see your dielectric jump up to a super high dielectric compared to everything else you did. But yeah, that was, there's few quarries all over that have aggregates with magnetic properties that are not, there's not a lot of them, and it's not a large portion of the aggregate in the mix, but I found in Montana and Wyoming a couple of different pits that will produce magnetic properties that the dielectric, that the DPS will pick up. You'll see you just spike, and it's just the size of a quarter area. You just know there's a rock there with magnetic properties. So.
Well, save additional questions. We'll have more discussion where I'm going to be begging people to speak. So keep thinking of questions. A lot more fun if we're talking about stuff. So with that being said, we have lunches here, and it's all self-contained in a box for you. There's enough complication trying to figure out how to pay and evaluate the payment. Let's simplify what we can here. One thing, there's 5 that are labeled garden. So if you're vegetarian, you should be able to have those. If you're not vegetarian, maybe wait to see if we got any vegetarians who need that first. But that's basically it. There's drinks in the cooler over sitting on the side too, and we should have plenty for everybody to have one. So, all right. Thanks a lot for great discussion, guys. We'll be back here at 1 p.m. All right. Well, hopefully you guys like that lunch, because I think it's going to be really similar tomorrow. We thought about going fancy with hot lunch maybe next time. Yeah. Oh, it's doing a transcript. I think you should go. Yeah. Okay, so our first presentation is going to be MnDOT data collection and analysis. Then we're gonna get into some more sophisticated stuff after that. We need to bring in Mike Johnson for the more sophisticated stuff. We'll start here with our, and these tools, I guess the main takeaway for this presentation is that basically if you're just using the technology and nothing more than Excel, can we extract useful information from these this piece of technology? And then we'll get into some more stuff after that. So generally speaking, you know, we're still evaluating a full coverage density map, like you'll see later in beta here, except now we're just talking about on-site software. So basically, how do we take this, you know, 2 lanes, in this case, a couple miles worth of data, and make sense of it just using on-site software and some simple Excel tools. So we've talked about use of the dielectric to density conversion check and sensor consistency check at the last meeting. So this one, I just wanted to hit on the one that's third down under summary analysis on our pool fund website for just a % conformance evaluation. So with this one, you do have to set up your project. This information up here on the right is just for tracking purposes. It doesn't affect your calculations. This stuff on the left needs to be input correctly, basically telling it that we're looking at % compaction or % density in this case. So you're basically just telling the software what range of data is acceptable for both the mat and the joint, and then also by putting in the numbers for the closest lane extent for it to be considered joint, and then mat line minimum distance from the closest lane extent tells us basically if it's a foot or further away from the closest lane extent, then it's a mat measurement. So, and then as long as you have your lanes set up, in this case, 2 12-foot lanes, you can do all of these calculations that I'll show. So I just wanted to take a second to do an example here, just so you can actually see it being created. So we have all these different summaries that you have. So we have all these different summaries from all the different days of collection that we did throughout the year. And I just wanted to go into the example folder where I just grabbed one of them for the 36 project that Michael's going to present on in beta, and just look at one, what we get if we just open the template that's on that website to do this analysis. And in this case, you just follow this step-by-step procedure where you take your data that's exported from the software, segment summary statistics. So this is automatically generated when you go out there and you set your parameters and press export. And then you just copy that data from A through L. And then paste it into this template. And in this case, once you drag down your calculations, you have a plot that is basically showing throughout the day, both your average density lot by lot along here for both the mat and the joint, which in this case being a echelon paving, we want our joint and mat to be quite similar. But then we also have our % conforming here, which tells a little bit more. It gives you both magnitude and variability or variation, where it's basically saying for some of these situations, a situation where this data point right here would be associated with 10% conforming, whereas we're up around, for the map, over 95% conforming lot by lot. So the left side is just giving us our scale for our average data that's shown in the lines here. And then the right axis is showing us our percent conforming for both blue being matte and orange being joint. And then also, if you go down here, you can say, okay, it looks like it's getting a little bit lower, up around 259. And just click in here and see what's going on. Just that location. So, so that's basically just a simple tool that's pretty much automatically generated if you paste it into that template, just using the on-site tools. And then the other thing about this is you can look at a table with the software when you're out on the pavement. So, for example, that section, in this case, a project where we're at Station 80, we have joint percent within limits around 24% conforming. So this is an example where we were just training in a contractor at the beginning of the project, and this day they're paving from this "You Are Here" sign up the upper left portion of our map here. And this is the data we were getting initially. Does anything about this plot jump out to anybody based on what we were talking about before? Any guess is acceptable.
Just joint densities.
The joint densities, who said that? An A student. So yeah, so our joint densities, if you look at this plot, we're looking at some really low, like down around 20, 30, even down to 10% conforming, and the joint densities on average around 90% max compaction. So this type of information can be exported using I don't know, is it KML or KMZ file? KML. It's a Google Earth file. So you can basically just, once you collect the data, double click on it. And if you have Google Earth on your technology, you can see the different results. So in this case, left of center line. And again, this alignment Jim Schneider created for us using the alignment file for that project. So we wanted to be able to see it with regard to our actual station here. But it's pretty obvious where that low density is coming from if you look at the color maps here. And again, this is just by double clicking the exported data, you can see that in Google Earth. So coming back to our map, now we're going to jump up to the end of the day of paving here and look at that same, somebody other than Robert, what's different about this chart as compared to the other one?
Looks good to me.
Looks good to you, why? Yeah, the joint and the mat are both the same, and we're even getting a higher percent conformity because we set our limit a little bit more lax at the joint here, where I think we're at 91% being the lower limit. So, and then also looking at the KMZ, KML file, we also don't see that blue low density spot there. So basically, you are here, bad, you are up here, good. So what's the difference? Well, this guy who has nothing, no degree in engineering or experience with DPS until this day, he's our difference. So he was pushing the cart at the beginning of the day and learning what means what. And basically just looking at this squiggly line and seeing that, hey, why is that blue line lower than the other two lines? Well, that blue line is the dielectric measurement, not even density in this case. It's lower than the other two. And that's the sensor that's being measured right along that left side of the center line joint of National Paving. So the foreman comes up and makes fun of us for being on the Segway a little bit. And then we talk about the data and say, yeah, it looks pretty good, but it's a little bit lower on the left side looking up station on this project. And they're like, well, maybe we might have had some bridging at the joint, something like that. I don't even know exactly, but the point is we're telling him information that he can use to build a better pavement, right? So he takes that information and does it with it what he wants, but at the end of the day, we went from miles and miles of pavement potentially being paved like this for the entire project to miles and miles of pavement potentially being paved like this. And that can make a big difference on how long this pavement is going to last. So that's just looking at a squiggly line that's telling us that it's a little bit lower, close to the joint. So that's one thing that Matt talked about that maybe we need to be more cognizant about is we're hyper focused on getting the quality assurance, but there's things about this information, and Forrest touched on it too, and Bryce, that it's providing useful information even before we do a lot of these different fancy things. So, so that's just one example. I think this was our 55 project where you can just look at the live data and see a big impact from using this information. And then, of course, I was happy to see once we let Doug loose, it's a little bit hard to see here because I was just taking a picture of the screen. He's like, well, how come my line's going down lower again here? And of course, this was on the shoulder side, so it's a different sensor. But again, same issue with apparent bridging of the roller or something going on there. So once you show people what to look for, you can really get some good information from this technology even before you do some of the fancy stuff we'll be talking about here in a bit. You'll hear Mike in. And the other nice part, I like to highlight success stories, but we took our data and we sent it to Dave Van Dusen, who's the materials engineer there, and the project engineer, Brian Tomasoni. And I won't go through all of it, but basically nothing too fancy, just core validation showing the curve we developed with the pucks is matching what we're seeing in the field, an overview of the joint and the mat, where we covered with our density, and then showing the percent within limits for the different areas that we tested. And this is, again, those locations where we saw it low at the beginning of the day and then improving as we moved along the project there. And just getting that information to the project engineer and on-site to the contractor, and got a nice note back saying, I look forward to the day when we can use this real time on all projects to improve our contractor operations. So I thought that was kind of nice. So it's not an easy thing to do all the time to get this new technology out there, but I think it does provide some useful information that people appreciate. So that's going to get us to the more complicated stuff here. And I'll just segue into Mike's presentation by showing some example paver stops turning into lower density here on that same project. And then a zoomed in where you see the lower temperature, especially near the joint, also causing a lower density. That's at that same problem spot, just right at the joint looking up station. And then packaging that in a case study that most of you have probably seen on the website, but Mike will go into more detail where we're going to take a look at this TH36 example project, taking a look at the data here. So Mike, why don't you take over and give us a little bit of background on use of Veda in Minnesota and this TH36 project. Yeah.
Okay, hello, can you hear me? Okay, there we go. My name is Michael Johnson, also with MnDOT. Same building as Kyle and Mercedes and Di and Jeff took off, but different unit, same building, so some coordination that happens. I guess my goal today was to talk about ICT uses in Veda. I think a decent amount of my slides has been covered already, for good or bad. So I hope everyone enjoys the joint peer exchange of intelligent compaction and favor mounted thermal profiling DPS, because a lot of good information, which is what I've been focusing on for quite a while. So I guess some of the background, a couple extra details that I'm trying to remember that may not have been covered, but this Veda software, millions of dollars of public money has been put in to create it and develop it. It is a free software. It's on the internet. Just download it, install it. We encourage you to use it. And part of the reason why I'm talking today is the state of Minnesota. We have been at full deployment for intelligent compaction, paper mount thermal profiling for 3 or 4 years already, with another 4 or 5 years of phasing it in. And by full deployment of those technologies, I mean any asphalt job that's more than 2 miles in length is supposed to have these technologies on them. IC and thermal it is, and a contractor's collecting the data. They are putting it into this Veda software and they are submitting it back to us as the agency. So a Veda project is a deliverable that's required for these contractors. So I think some of this got covered, but the whole purpose of Veda was, many vendors, many systems all under one software. I think you also saw some of the features that had, obviously, mapping, filtering. We could break the data into sublots. We could import spot tests and then some analysis. So I'm going to try and show you a couple of the other features that may not have been covered in other presentations. This is pretty similar. I think it just kind of shows, again, George went through it. I guess touching on these systems. So as long as the data is in a format, in AASHTO standard format, it can be imported into Veda. So there's just a list here on the left side of the page of those AASHTO standards. So it's in that format, or if they work with the TransTech group to develop an API, they can get it in there. So, and we also, I think George talked about, this software can make reports, so you could, you could use those reports to do any other analysis reports, anything else you need to do. And eventually we'll work with AASHTO project, and then we'll turn into a web-based platform. So some of those mentioned before, but just as a reminder. Um, So again, this software, I think you've seen some screenshots, but just as a reminder here, we could see multiple screens of different types of data, different systems. Here at the top is paper mount thermal profiling data. Within a year or two, we will have MDMS, which is the expanded form of e-ticketing in the Veda software as well, which would then give us truck ticket information and locations and times and trucking times, which would be related to paper stops, and can be related to cores that we take. So again, we get the spot tests in there. The middle section, the middle part of the screenshot is dielectric profile data with the estimated density. And then at the bottom is intelligent compaction data. So again, just, all of these data points can be overlaid. I guess just to add to that, our full deployment does include RTK accuracy, IC and thermal data. So obviously a preference to get the DPS data and RTK accurate as well. So I'm going to go through some examples fairly quickly because I think you've seen other examples today, but fairly quickly, I mean, issues we've seen in the paper mount thermal profiling data is, we could see the paper stops, we could see the dumps, we could see cooler material, which is shown here at the top and with the time periods of the paper stop on the bottom. So again, since we've been using these technologies for years, we just have a number of examples, which is why we have screenshots of Veda and time periods and things, issues that we've come up with. And hopefully we'll tie this more to the DPS here towards the end. But the whole point is, with other technologies, we're identifying these issues and that information is getting back to the contractor, and then out in the field, they made the change to use a pickup machine, and that issue with the dumps got significantly better. So again, paper stops generally makes it tougher for the contractor to get a more consistent product. Again, here's example of 3 paper stops at the top. We were able to line up with some higher ride values. Other examples that we've seen is, windrows not overlapping and getting a cold stretch of material go through the paper, so this picture on the left is that's a picture of the actual paper mount thermal profiling unit that's on the back of the paper. I'm sure with the DPS system, you're going to see a screen as well and start seeing issues. So it's just something that was reported to us. So this is a real-time thing that can be seen and identified. Another issue that we've seen is high temperatures coming out of the plant. So we were getting readings of 350 degrees, material that's already gone through the paper and was placed. So probably a little bit warmer when it went into that truck. No matter what happens, there's always some late season paving here in Minnesota. And we got some, so the picture at the, top left there, one lane got paved a week or two earlier, and the closer lane was the weather changed and it got a lot worse, and visually you could see the difference. And we were asked to look at the paper mount thermal profiling data, and you got to tell here at the bottom that there is the legend's on there, but those blue colors don't start until 230 degrees or less. So there's a lot of blue, and there's almost 100 feet or more of it. And what's kind of getting cut off a tiny bit at the bottom is we also have temperature readings from the breakdown roller as well. And I don't think we have the legend on there, but you can imagine that that's also cooler than 230 degrees. So Other examples that we've seen, segregation under the gearbox, so you can see that strip of different colored data right in the middle of the lane. So now instead of one strip, now we have two strips. We've been able to relate that to the slack conveyors. So again, just identifying paper mount thermal profiling issues. Windrows getting driven over and cooler data showing up on the system as well. Holding the hopper wings, so cold materials will get, they'll sit in the edges of the hopper, and then once they hold those wings, that cold material will go through the paper and get dumped out onto the mat. On occasion, those can be visually seen on the map. I've seen it a number of times as well, unfortunately, in real life. Sorry, I'm just trying to move my thing so I can actually see my presentation. So other things that have been reported to us, rain events. So saturated aggregate that goes through the plant, never gets to full temperature, gets dumped out onto the mat. Again, less than 200 degrees, big problem. There you go, rain event. Beyond the paper mount thermal profiling data, get into intelligent compaction data, but basically what we have all the rollers instrumented. So the top picture is just the breakdown roller, then intermediate, then finish on the bottom. But you can just see the inconsistency in the rolling pattern. We can also see the mean temperature that the breakdown roller is reading, and you can see how that makes its way. The intermediate roller had a lot better roller pattern, but it's towards the center line, there's less passes. And then the finish roller was already down to 125 degrees. So I know their job is to make it look a little bit smoother, but still it's gonna be tough. Other issues we've seen, the breakdown roller, so we can see here in the top is the pass count. So the roller has been 3 or more times over the entire mat, the entire width of the mat and everything. But once we look at the other data fields, the lower section of the slide is the stiffness values. Where there is no color means that no vibratory compaction occurred in those locations. And once you correlate the two sets of data, you can see that that's where the roller was. They were turning off the vibration and rolling off the mat, and then they'd roll back onto the mat and pick it back up, but they left a gap every single time. Well, at least on those 5 instances. So. Again, inconsistency in roller pattern. This one was from a couple of years ago, but there was paving through a marsh area, and the stiffness values dropped down, and you can see in the pictures the failures in the asphalt. I mean, this was days later, with truck traffic and everything rolling over it, just tore it completely up. So again, vibratory compaction. Top left is the breakdown roller's been everywhere, but when you actually look at the stiffness values, there's areas of no vibratory compaction, which is happen to be where the cores landed. So not a lucky core location for the contractor. Kyle had a slide similar to this, which there's probably a few of these. I think this was in there earlier, but paper stops, lower DPS data. That one pretty similar. So were you gonna talk about the
So I think it's important to just see visually all the different ways that we can have issues with. Well, let's go into. Oh, yeah. I was just gonna. I'll let you introduce it a little bit. Yep, sure. So as you saw from Michael's presentation, there's a lot of different things that can cause low density and here. So, one advantage with the DPS system itself is that, it doesn't necessarily matter what is causing, the low density or your ability to figure out, what's causing the low density by interpreting the map. It's just showing you the density is low or not, right? So, but on the other hand, when you do see, locations where there is low density, having that other information to interpret what's causing the low density comes in really handy. So this is just a picture of the 36 project that I wanted to show you guys, kind of a case study, and this is the one we used for that write-up that we did in the DPS digest, where we basically headed out to an echelon paving project and trained in the contractor here on the lower left on how to collect data with the DPS. John Garrity and Ed from our bituminous, well, Ed from research and John Garrity from the bituminous office were also out there collecting, I think, permeameter data at the echelon joint. And basically what we did is say, you know what, this is good pavement right here when we're training in the contractor. We're at the joint, our left sensor is 6 inches away from the center line joint, but you couldn't tell from the live display of the color map or the live display of our scatter plot where the joint is. And that's a good thing when you're doing any kind of paving, but especially echelon, that's what we hope for. Generally, that's what we saw on the project, but we also saw periodic situations like this where we have 30, 40, 50 foot stretch where we see a significant drop in our density. Shows up in the scatter plot, shows up in our color map, and this is just right on the screen. I just took a picture of it with my phone when we were out there. So, so now I showed this on-site software picture before, and now we're going to show this is actually a different project here, but what we can do when we look into beta too to see what's going on in these projects. So much like the other project, you want to validate that your conversion from dielectric to density is good. In this case, maybe a slight shift when we look at the average densities compared to what we were seeing on the project, but generally in line, we'll be able to do our assessment. Taking a look at our distribution of the mat and joint, you can see what we kind of tend to notice at times with these different projects where you get a little bit more of a tail here on the joint data, and we'll see where that's coming from here later. This is just our average density broken down by where we are on the pavement. And what you see here is a drop. If you're looking up station on the left side of the echelon paved joint. And the question is why? And that's occurring at the side of the pavement where we saw that periodic 30, 40 foot stretch where we're seeing lower density, even though this is averaged out for the entire day. So that's where we bring in the big guns. So we brought in Mike and showed him kind of some of our more significant stretches where we had these lower density locations along what you can see here is our center line joint. And another thing that we'll kind of touch on a little bit more later is you see this happened to be where a core location was just prior, less than 50 feet away from where one of these stretches of pavement was. This is actually the impetus of the Contractors Do You Feel Lucky title that John Garrity came up with. So anyway, we took this density map and we said, okay, we know it's low here, but we just don't know why at this point. So sometimes you just say it's low and the contractor, they're like, okay, yeah, it must be this. And sometimes you don't have that opportunity, and that's where you can go into data. And this, Mike was looking at the IC data and just looking at the pass count when the breakdown roller was in vibratory mode. And the red or the orange is 1 or 2 passes respectively. So this type of stuff close to the joint where it's red is not a good thing. So so we're not hitting it with our vibratory roller next to the center line joint there. And then even in the orange spots, it's not what we're trying to accomplish here. And you can see the end results with the density. So the primary correlation we determined was just the breakdown roller pass count. And just as an example, you take this section up here where you have consistent 5 roller passes with your breakdown roller, see what the result is. It's of course consistently high density. And then you take the same stretch of pavement, but you look at one where you're getting these lower pass counts with your vibratory roller. This is actually next to the shoulder for whatever reason, and you can see the end result with your density. And this is kind of what we were talking about earlier about for these type of situations, having RTK accuracy on everything makes this, it just jumps out at you, the cause of these issues when you can just overlay it on top of each other like that. Another example, just with the lower pass count, you see on the bottom there, the reds and the oranges causing the lower density at the joint. But then also saying, okay, well, wait a second, how come it was okay over here, but then it was bad over here? Well, now let's pull in our thermal data, and you can see even across the lane in certain spots. So, I mean, everything is a combination of factors that cause your density results. So it's not always just, well, we see low density, we know it's this. It's nice having multiple pieces of technology there to compare it to, and being able to really identify what's going on. And then here, just again, kind of a simple, clear bump in whatever reason we lost our breakdown roller. I say whatever reason, we know what reason now, but at this point, it's just whatever reason we didn't get our breakdown roller past there and we lost density. And again, thermal issues at the time of placement as well. So before, let me get rid of this. There's a little video there. Oops. I wanted to get out of here and just show an example of sometimes taking too much information can defeat the purpose. So I talked to John Garrity and we set up a meeting with the contractor because they were going to be doing a similar stretch of pavement on the other side of the on the westbound side, and he gave some good advice on basically just simplifying and getting it down to the message that you're trying to send. So this is kind of how we packaged it when we met with the contractor. We said, you know, basically you're doing a great job. It's just this, at times, this stretch of the pavement is low. And kind of the way that we presented it was that, you know, on this day that we were out there, you had a core that was actually measured okay. It was up around 92, 93% GMM, but had that core been 50 feet further or more up, you'd have had an issue in the pavement. situation on your hands, so, or a deduct. So, so basically just getting to the meat and potatoes of what we were trying to assess helped in this case. And then just give them a couple examples. And right away, as soon as we showed the data, they took the feedback and produced some things that they were going to do to try to improve on that. And I think the main thing they came away with was, you know, for logistical reasons, they were getting up around 250, 300 feet ahead with their breakdown or with their paver in the lane where we were seeing those issues. So, so this is kind of what happens when you get a situation like that. So this is the breakdown roller that's supposed to be impacting the pavement of the lane that's paved, where the paver, you can't see them in the picture here because they're a few hundred feet ahead. And what does this roller do when it runs into the paver on the second side that's paved? It can't run into the paver, right? So it just turns around, goes around the paver. Well, where is that occurring? Right on the side of the centerline joint where we're seeing our lower densities. So we get that information to them. We no longer see that drop in the density along those sections. And kind of what's interesting about that situation is if you look at this stretch of the pavement right here that corresponds to where that breakdown roller had to swerve around the paver, you had all the information you needed to make that assessment on site, because this is exactly the spots where we were seeing that drop in the dielectric on the on-site software. So, so it's just another example of giving feedback to the contractor that saves, you know, on this project, miles of lower density, potentially early failing pavement due to density. So with that, I'll let Michael get into the Beta example.
Yeah, really good example, because I mean, you know, when you're making a contractor echelon pave, you're hoping that centerline joints can be a lot better than the non-echelon paving. So, but yeah, as I said, I support the IC and thermal technology. So I keep getting phone calls in the summertime from Kyle with theories and data, and you know, he's ready to get things figured out. And my first question is, what job are you talking about? What's going on? But you know, he had some hunches, and we got the data together, all in beta here, and we started looking into it. And I think the PowerPoint presentation actually had excellent examples of all these issues. So I'm going to just quickly show you one or two of those spots, and then we'll kind of move on to a few of the other features. But so for lot one, again, this is this upper section here is DPS data, and using the calibration that Kyle had for this data, the legend is set to density, estimated density. So green is good, yellow and orange is better, blue is bad. So I can zoom in here and you can kind of see just the darker colors and the blue colors. And then down in this lower section is intelligent compaction data. And what we did is we filtered only the breakdown roller and only vibratory passes of that breakdown roller. And keep in mind, as what Kyle was describing, is this is the lead paver. So this is the breakdown roller for the lead paver. And as he got an excellent picture of that, on occasion, the breakdown roller for the lead paver would have to avoid the trailing paver in the other lane and could not get compaction along the joint. So anyways, that hunch that Kyle had, it worked out. He's
1 for 100.
Yeah, that instance was good. But here you can see that these, again, the legend here on the right is, red is 1 pass, orange is 2, yellow is 3. But you can kind of see that this breakdown roller had not hit near the center line joint as well, which kind of corresponds to the lower estimated density values up here in the DPS. But, so again, just the value of the software. I mean, it's all the data is in here. I can just pan through. We can go and we can find these areas. We could zoom in and zoom out. So this first lot here is had good IC data. But let me move to the second lot and apply, which has another good example of paper mount thermal profiling data and lower density. And then I have a little note here. Sorry to scroll over to 204. So again, because we can toggle back and forth between the sets of data here, over on the right is the legend for this screen, and I can move from compactor pass count to thermal profiling temperature. So all of these fields are what's collected by these technologies. Let me just scroll up here a little bit more. You can see all the different options of data fields that the dielectric profile system's collecting, and our ability to switch to that and see those values in the screen. So I'm going to put thermal profiling temperature here on this lower viewer. Just takes a second to update. Try and zoom in here a little bit. So as everyone is saying,
Kyle needs a faster.
yeah, Kyle needs a better computer. Not that there's too much data here, it's just Kyle's computer. Whatever he did. Uh-oh. Okay, but anyways, I just had a couple examples here again on the shoulder of this. So again, this is paper mount thermal profiling data on the lower section. There are some strips of blue, which if I move my thing here, I can actually see the legend. So this light blue is 230 degrees, and the darker the blue gets is colder. And then you can see the estimated density from the DPS system up here. I mean, dark blue is 87. It's getting cut off just a little bit, but the blues started at estimated density of 91, so already not great and getting worse. So there's a few more. I can scroll to just a few more of these examples of the thermal profiling data. Kind of 215. So again, in this beta software, we're able to bring in an alignment file. You can see this alignment showing up here, which is nice because it helps us figure out what we're looking at, especially when you have multiple screens. So we have the station in there. So here at 215, again, you can kind of see a cooler strip on the shoulder, which again kind of lines up with lower density data here for the DPS. So I guess again, a whole bunch of great examples in the PowerPoint. So let me try and touch on some of the other things here in the beta software that maybe wasn't covered. But we can bring in all this data. Here on the left is where we do all the filtering. The whole goal is, so there's an AASHTO standard. Matt Oman had a cheat sheet to describe what we define as a lot, or I guess what is in the AASHTO standard is what a lot is. But basically a lot is a lane that was paved in one day, one lift. So, I mean, that's the gist of what it really is. And we try and organize these lots by number here on the left, and then I can expand that out and further isolate that lot with all these different filters here on the left. So ideally that contractor would identify the lane that's being paved while they're collecting the data. It makes a huge difference. We could also filter the data by location. We could time filter it because I can, let me just go ahead and pick a spot here with my cursor and right click search. But this is showing me the raw data within 1 foot of where I clicked. So it gives me the day, the time, the location, what lane it was identified the data was, which sensor for the DPS system, what the offset was that it was set to, the speed of the DPS system at that moment, dielectric, and again, all these other data fields that are collected, estimated dielectric height, I'm sure, dielectric quality, estimated density, and then same thing here, boys. Yeah, 88, so not very good. That dark blue spot is, that's probably not getting the, what we're hoping for as a taxpayer, so I guess I'll go with that. But again, so we have all these different filtering options here on the left. It is grouped by the technology, so all these are for the thermal profiler. This one's for compactor. Everything down here for dielectric profiler. So like I said, I was able to isolate, I was able to identify and isolate the breakdown roller, separate it from all the other rollers. And what was good was in an earlier presentation, I saw other filters that were used. Someone was filtering out data less than a certain temperature, also a feature here in beta, and again, what we've been looking at, which is vibratory passes only. So again, we can create filters to further isolate the data that we care about. So there's a little bit of digging. We only, for this beta project, we tried to narrow it down to just 1 day's data to make it run smoother. And then again, Kyle provided one calibration for this day, but what we would normally have is we would have a number of days of paving in here, a number of different technologies, a number of different calibrations for each day's paving, or however often Kyle decides is necessary. So let me get into one more quick feature here as we get closer to the end here. The analysis wasn't really shown in these PowerPoints here, but one thing that we can do here is it will give us statistics and everything. I added this one additional analysis result, which would be percent. I guess I just threw in an acceptance rate of above 92%, and I put it needs to be 85% or more or higher. So I just added that, so it's kind of a similar to percent within limits.
So that's saying density has to be, so you're saying density has to be 92% or higher to be acceptable, and you want it flagged if less than 85%.
Of the data, okay. Good clarification, yes, correct. And let me kind of go back up here to the top, but so again, I can analyze all the different data fields that they provide. I can add them all in here. We can analyze them by what we call sublots. So again, I was describing a lot was a lane and a day of lift, but we could further break those down into what we call sublots, and I can set a sublot to be created every 150 feet. And then when I run the analysis, we have overall results for the entire lot, and then we have results for all the sublots. And let me just go straight to density here. But here I can show you that this is the 150 foot section. And so each of these rectangles is 150 feet. Turn the alignment back on so you can see where we're at. It's also here in a table format. And again, here's a new column which is passed, which means more than 85% of the data was above the 92% density, I guess is what I put. So I can scroll down, and I set that for a reason, because I did see some failed sections here. So right here, this 150 foot sublot, it failed. The min, mean, max density didn't fall within there, so it had 82% of the data that's less than the 85% of the data which limit. So standard deviation, again, all the different statistics here. All this information could be exported in a report format, PDF, Excel, text. So then we analyze dielectric profile, but so we could take all that data and I could then export the results. I can export the data. So again, just skip to the last couple minutes. I think I'd just wrap it up there, but questions. I mean, I've been using this software for years, again, to support IC and thermal. The money has been spent to get the DPS data in here. More technologies are being added to the software, so just, you know, we want to, this has been shown at, I think, previous meetings, but just wanted to help encourage you to know that this software is out there, it's available, it's free, it can be used. Hopefully will be helpful to you. So, questions? I'll give a rundown.
Mike, quick question. The TDS file is from the DPS exported pave scan. That TDS, is that affected by the range settings in pave scan, or is that non-touched information?
So the percent conformance shown in Veda here is strictly a function of what is set in the Veda software. Now, of course, the exports that I showed before for percent conformance, it's giving results based on what was input in the pave scan software itself. I don't believe, I could be wrong, I don't believe that extents information that was input in pave scan gets pulled into Veda because it's not using that information as part of the analysis in Veda.
So the TDS is, well, let's call it raw.
Yes, but it doesn't include the lane extent and percent conformance information.
But the range settings for dielectric, for density, for air.
Oh, you're talking about different range settings. You're talking, oh, okay. I'll give that one to Roger.
Yeah, referring to the validated range.
Yes.
Those are.
So if I make a mistake with that data range in pave scan, export to TDS, there's no way I can recover that again. I have to go back to pave scan and fix it there.
Yes.
Aside for the filing information, what is required for the DPS to be able to upload the data into Veda?
So for the data to be imported into Veda, two things are critical, I would say. One is there needs to be a valid GPS information with the data. And Mike could probably comment better on what it's like processing data in Veda that's not RTK precision. It can be done. Maybe you want to comment on that.
So the Veda software has, it needs to have results for all the fields to import into the Veda software. As long as there is a location, it doesn't necessarily have to be RTK accurate. As long as there's a location associated to all the rest of the data fields and all that's in there, then it can come into the Veda software. And well, I guess I was on my slide here that, like I said, there's some ASTO provisionals on how that data is laid out in that TDS format and everything else to get it in there. If that was part of the question here.
And then the second part about the naming convention is at MnDOT, there is a Excel spreadsheet that the contractors are required to fill out that contains all the lot information. And just to remind you from our spring training, all that lot information is kind of a predefined name. So it contains all the information, whether it's date of paving, all these different things, that it's going to be the same exact name based on the characteristics of the measurement itself in that lot. So that's kind of a standardized thing that's pre-filled out at MnDOT. And because of that, it helps in many different ways. But on the other hand, if you don't get your file naming convention correct, all of those different filtering things that Mike talked about, they're based on that lot information. So they're based on what date was it paid, what, I don't know, help me out with the different characteristics.
Yeah, here, so on the screen, you can see, as I was mentioning, I have a couple lots here, but this is the format. There's a lot number, then there's day, then there's route, material, lift, and then the lane is identified by the offsets from the alignment. So this lane, yeah, the lane extends. So it's a 12-foot lane and it goes from the center line to 12-foot right. And right is based on if you're looking up station, that's right. And left. So, and as Kyle was saying, so there's, as I was describing our full deployment situation for IC and thermal, there's a form that's filled out, and like Kyle was saying, it's already, all the columns in Excel are in order of this lot designation. And so that's getting filled out every day along with station to station that was paid. So if I don't have, here in Minnesota, if I look at the data and I look at the sheet, it tells me that, I should expect to see data up to station 215. And if that's missing, then that's a problem. So.
So in general, do you feel like contractors are also using this data to better themselves? Some?
Yeah, some contractors are really good about this. We get phone calls, okay, so there's a number of these projects and even the contractors are busy. So not all of these problems could be solved during the construction season. What ends up happening is we get a call from a contractor, and at the end of the season, our core incentive disincentives were not up to their expectations, I suppose. Some phone calls happen, and usually what happens is we do a debrief with a contractor that says, hey, things didn't go well, we're trying to figure it out. Can you guys help us out? My unit would spend some time to look at these beta projects. There's, again, because we've seen it, between this and their form that they submit for incentives and disincentives for IC and thermal, it helps me track down, find the problem areas, and hopefully identify them and try and make screenshots from the data software and throw it into a PowerPoint and get it into a format that is usable for a contractor. But so again, I think it's just like you guys, there's a screen, your whatever technology it is, even your DPS system, there's a screen on there, some lines start going down, you can see that there's a problem. Identifying what's causing that problem is probably the biggest battle. So the same thing is true for IC and thermal for the contractor. They see there's screens on those machines as well. They can see what's going on, and hopefully they're using them. Some are, some are just collecting the data because it's a requirement, and that's unfortunate. And because of our low bid incentives, disincentives, hopefully hopefully more attention will be put to that in the future, but yes and no, I guess, is the answer. Okay.
So maybe this one's for George. I get the same feedback from our customers as we talk about this, and it's all great when you know what you're looking at. And in all honesty, when you add the density numbers to a map, you could draw a lot of conclusions a lot easier than we could before that, right? You had just a couple of core samples. I guess, are there plans for insights in this? So not everybody is Mike, not everybody has a mic, but as we start, a lot of the feedback we get from our customers is, tell me what I should do differently. I don't want to sit there and look at it and try to figure it out for myself. Ping me on my phone and say, hey, your breakdown roller's not running by, or you're low on passes, whatever that may be. And there's some thoughts of building insights into data.
Thank you. That's the wish list. Basically, you would like to have a digital top mensal available to look at the beta data and to show you, hey, this call failed because you have less Pascal, or you're hitting temperature too low. So that definitely can be a diagnostic tool. We have another software called ProVal that Robert have used it for 20 years, maybe. Yeah, not quite. And that one had a lot of tools, just like Veda. It show you this and show you that analysis, but why? How? What are going to do with it? That's what we're doing now for ProVal. It's called Profile Sniffer. Now you have something going wrong. So what causes it? How are you going to do with it? Similar thing can be done to Veda. Definitely, we'll put on the wish list. We'll send it to Rebecca. Hopefully, we will follow up.
I'm making a note right now.
Thank you, John. Yeah, and Veda has so much power that the more you know about it, no more power to you. Why you just might just show you behind the scene, you can extract your data any way you want, based on the data element, based on the location. You can exclude the bridges. You can override it and just extract a certain lift of material compacted by all the different machines. So all these can be done. And for forest example, that you show the super elevation, I have a low density kind of crossed, that can be looked at again by filtering. Just look at the different DPS height, the DPS height. So you can look at that also. So there's so many things you can filter, and it can tell you a lot of story. I think Herb had a lot of comment to share too.
Yeah, and I'm over that 2 decades with ProVal. I'm over the 2 decades with ProVal, but I think an important thing to mention here is that software is incredibly complex and incredibly useful. And instead of going into a long soliloquy about some story about some event, I'm just going to say that one thing you need to keep in mind is you use it or lose it. And I don't know which iteration of beta you're up to now, but last year at the training session, since I've been trained in the first couple versions of beta, I thought I was pretty smart. Now,
Intelligent.
It's one of those things like I discovered in talking with my grandkids over Thanksgiving, is, going from Android to Apple. If you use it all the time, it's pretty easy, and you can make these wonderful maps. If you only look at it when you get a telephone call, or at the end of the year, you go, well, I'm not doing anything. Let's take a look at what our project data looks like. It is the most miserable thing in the world to deal with. So this is a cautionary comment, is that to use it, you must use it daily. You know, it's just like, you know, running for a marathon. You don't go out the day before the marathon and say, well, I'll run 5 miles a day, and yeah, I can do 5, I can do 10 times that. You have to practice. The more you practice, the better you are. And the better you are, the more information you'll get out of it. But I think that's a key element that we have to keep in mind with this. And Mike, you said you've been using it like 2 or 3 years. So, yeah, I know. So, that's something you're going to pick up today and be a master on it tomorrow. It is wonderful software, and if you take the time to understand it, wonderful.
All right, so this question is probably geared towards George, but and several years down the line, but with intelligent compaction, and then with the AstroWare project or the material delivery, e-ticketing, do you know if there's going to be a link or a potential link that you could link it to any of the asphalt plant management software? So you can link that data in with it as well, and then overlay. So then you're overlaying plant data, trucking data, field data, lab data, and being able to then really, I don't know, maybe using some sort of deep learning or some other software to then isolate why we're having the issues that you're having.
The current AASHTO NDNS standard, we do have the one of the field that link to the asphalt plant. And I think we have last panel meeting we discuss about that. And those information would be pushed by the contractor's e-ticketing vendor, whoever, Fleet Watchers or Hub, and they will push that to through the called API call to Veda. So that's what we're currently working on, and that will be completed for contractor to try by July 2023 and fully deploy in end of 2023. And then you can not only overlay all these data together with the truck information, laydown information, hauling information, and those inspector information, and also the flow rate and all that. All these are the information that will be all fused together, and also will interface with AstroWare, like mentioned.
Like Aztec Mines can be able to link to it.
Yep. All these are talking between the server.
Do you think it'd be beneficial or to have scoring system for the contractor for daily with medians or expectations and how they did that day with coverage density that gives them a score, so that if the score's bad, then they look and go back into the data, the scores, so they can kind of get an idea to go look at the data. Well, I got a 9 out of 10 this day. I got a 7 out of 10 this day based off of past coverage. And it gives them an idea of how they did, so that they don't have to go through all that data. They can kind of be like, need to make changes. You can look at past coverage density, thermal segment, and it just kind of, you put averages in there and it just scores based off of those things.
This are our feature for the next. So what Veda currently have analyzed so much report, too much to digest. what I'm talking about is that dashboard, right? Dashboard that contractor can just view daily by daily basis. You pass today, you fail tomorrow, you do okay the next day. Currently, just for current version of Veda, there already a lot by lot quality control indicator. So you can set a range. If you, this lot is all doing okay, but next lot, temperature drop, then you got to see which truck have issues or whether the paver or anything have issues. So there are tools that's available. It just the you have to learn that, like Earth said, you have to learn how to use it. But eventually, the dashboard is the answer to you. War piece. Venom.
I just wanted to make a comment that I think that complexity of the data software and also the instruments, these DPS instruments, is kind of a barrier to acceptance. And so, as a vendor, we can make our instruments easier to use. But the data software on the other side of the coin is also another barrier. I think I heard somebody say earlier that wanting contractors to deliver the results in Beta is so hard to use. So I might humbly suggest that maybe a line item for Beta could be to make it easier to use for not non-sophisticated users. I thought all the new features, but ease of use is something that is really important.
Yeah.
So just to follow up on that too, I mean, in Minnesota here, we are wiring our contractors to create these beta projects and we submit them to us. So, it's our contractors that are actually using the software. Everybody's meeting, submittals and everything to that. So, granted, the software at first glance and first use can be pretty, complex to get used to, but once you kind of get a lot of the workflow down and what needs to be done and why it needs to happen, we actually do have contractors that are building the projects daily and reviewing their data and making adjustments out in the field under their field crews, something or not, ways, we are having contractors that are features, with that with the field gathered. Yes, there is a learning curve. We do have, online virtual training that is out there to take into stuff. So you don't expect it to be shown pilot.
Or did you? I don't think it's been covered. We basically just need a cheat sheet, as I explained earlier. There's 3 levels of understanding of it.
Yeah.
At the basic level, the grunt's doing the work. Their bosses that have to understand what the grunt's doing, and then those guys that are paying the bills have to have that more particular view.
Okay. We're only 20 minutes over that session, so. But it was good discussion. I didn't want to stop it. I sent a chat to Monica to see if she can move her presentation back so we could still take a break, but I'm not sure. Monica, do you want to present now?
That works. We could take a break.
Okay. All right. So let's take a break, and I'm going to say back at 2:30. Okay, well, thank you, Monica, for, I guess, accommodating us going over a little bit here. We really appreciate you joining us, and without further ado, I will let you get into your talk.
Okay, perfect. Thank you. I apologize for not being there with you all, but I didn't want to get you all sick. But today I'm going to give an update of what Federal Highway's been doing in regards to the DPS and how we're a part of this user group. First, I will begin with some information from the Mobile Asphalt Technology Center, or better known as the MATC. like any presentation we give with Federal Highway, I will have to give some of the FHWA disclaimers. Right? All the content of this presentation does not have the force and effect of law or are not meant to bind the public in any way. All the AASHTO and ACM standards mentioned in this workshop content are not governmental voluntary standards and are not required under federal law. All photographs used in this presentation are ownership of FHWA unless noted otherwise. And the US government does not endorse products or manufacturers' trademarks or manufacturers' names as they appear on this presentation. They are only considered essential for the objective of this presentation. I also have a list of some of the acronyms I'll be using today. And then a quick snapshot of what the MATSI's been doing in 2022. So one of the main goals for the site visits is to deploy the performance of engineered pavement initiative and demonstrate balanced mix design and field test. Since its initiation in 1988, there's been 170 on-site projects through the MATSI. In 2022, we did a couple of DPS in Florida, Puerto Rico, and the U.S. Virgin Islands, Arizona, Hawaii, Washington, Mississippi, and as mentioned before by Granite Construction, we did work with California as part of the loan equipment program. For all these states, we've been looking at some of the data collected and working closely with the NDE lab at Turner Fairbank in looking at some of the data, trying to analyze it, and putting some briefing reports together. So in 2023, we're planning a visit to California, Wyoming, and we're looking for 2 other states, one in the Northeast and one in the Southeast. And we do have a 2-day MATSI workshop that focuses on quality and asphalt paving process. And for now, we have the states I previously mentioned that we worked with DPS, and now we're going to kind of incorporate some of that. The MATSI has also participated in a couple of conferences, the National Asphalt of County Engineers in Buffalo, New York, and the North Carolina Region LTAP Local Roads Conference, and of course, looking to be present at TRB. Other things that we're working on. So since 2021, we've had 17 loan equipment of the DPS. Also, we're not only lending it out to state DOTs, now it's open to academia and contractors. So if anybody's interested, we do have some slots available. We've also included some rotational training assignments within, for now, we've had some division offices and federal lands participate in such a these rotationals to try to get some input of what other states and the field staff is doing to incorporate into this program. 11 DOT specifications review and more than 30 resources documents such as tech briefs and reports. Another thing that we've been working with is the info materials section. I don't know how familiar you are with info materials, but we are trying to incorporate some of the data collected by the MATSI. So it's the projects from 2020 to now. And then we're incorporating some of the sustainability tools such as life cycle assessment PAVE tool demonstrations. And those have been provided to some of the states listed on here. So those are some things that we're adding. Focusing just on the DPS equipment loan support program, our main goal is to provide technical assistance, training sessions, and field demonstrations. So we're all working together within Federal Highway where we're not only lending the equipment, but we're also providing training sessions and then some assistance with some of the data review, and that's part of the Turner Fairbank NDE lab. We're working on developing a DPS quick guide to help accompany each equipment loan. And like it was mentioned earlier, we're also very, we've been using some of the videos, the training videos, and the guidance material provided by Minnesota DOT. We are also trying to provide more support and outreach to asphalt pavement stakeholders by putting most of our material available on our website through the MATC website. And these demonstrations within Federal Highway, we have Leslie Myers, who's the MATC program manager, and then Steve Cooper, who's there, and myself. And then we also have a contract team from AP Tech and AET. Some of the vendors we've been working with are 3D Radar, or now known as Contour, Earth Science Systems, and GSSI. Here we have a map of some of the visits we've done, like I mentioned, since 2019, right before the pandemic. We did have a couple of visits and virtual visits, and we're also showing some of our upcoming visits. We are trying to use beta in our analysis with some of this data, and we've had some IT issues within Federal Highway, but we're working on that. But as it was mentioned on some of the talks that I was listening to, GPS has been having a good GPS system has been a great tool in order for us to use beta into our analysis. On the next slides, I'm going to talk about what the NDE lab at Turner Fairbank is doing in regards to the DPS. So one of the biggest projects was we were doing some laboratory assessment, right? Looking at the environmental effects on DPS. And so we did notice there was a slight increase in the dielectric within temperature, but since the increment was less than 0.08, it was still compliant with the AASHTO 98. So we thought we were still within. And then also when added moisture, there was an increment and it was more sensitive, but that was very dependent. There was also an increase of dielectric, but it was more dependent on the amount of water or amount of moisture that was added to that test. When it came to field implementation, work closely with newly paved asphalt. We had some projects with federal lands and other projects working closely with the MATC, and that was mainly to analyze the data to generate contour maps. And this was before we got to work with beta. And then there's been some collaboration and outreach. We did have, as part of our NDE webinar series, one of the monthly webinars was on beta, and also including some information on what we're doing with the MATC. So several webinars in regards to DPS. We're also having monthly meetings, and we were also part of the round robin project that we had with NCAT and MnDOT, where we were looking at the same specimens, puck specimens, to see the consistency and bias within all the sensors that we have. And for future work, we're going to be we're collaborating with some of our FHWA asphalt binder mixture lab, along with the MATC, to create pucks that will show some of the effects of different mix designs, such as gradation. We're going to look at warm or hot mix, and then maybe even look at some recycled materials and how that changes some of the results, or what we can look ahead. We're also trying to take advantage of old core samples that we've been collecting through the MATC and trying to test those and see if we could see a difference of dielectric from those cores. And we're trying to look at more advanced methods to model some of these techniques. So these are some of the things that are being done by the NDE lab at Turner Fairbank. And with that, I'll open it up to questions, and I'll leave my contact. So I have the contact for the MATC would be Leslie Myers, the contact for the Turner Fairbank NDE lab, Dr. Hoda Asadi, and then for the research center, myself. Are there any questions for me on our quick update?
Thank you very much, Monica. Any questions?
And I hope I caught us up on time, so.
You did great. We're not quite caught up yet though, but you started already. If you had ended right away, we would still been behind schedule, so. Well, hearing none, there will be an end of the day discussion coming up after my next presentation here. So if you're able to stay on, there might be some questions for you at the end of the day.
Perfect. I'll be here.
All right. Sorry, just getting to share my screen. Oops. Just going to share my screen here. Last presentation of the day. So we thought it'd be a good idea to kind of discuss, because our current work plan is planned to be done next December, a little bit of what's covered or not covered after the completion of our current work plan. And the goal here is to start thinking about where DPS needs to go moving forward. Whether that means another pool fund or seeing where the chips fall and not doing anything, or somewhere in between. We as a group of people who are vested in the success of DPS to figure out what are the most critical things that need to happen once this work plan is done. So I put it into context of some of the important factors that are necessary. So, you know, you can take the data and the full coverage density maps and do a lot of great stuff with it. But there's certain things that need to happen in order to be able to create those full density maps that you can actually trust. So one is making sure you have the correct equipment being used. You know, for example, GPR technology has been used to correlate dielectric to air voids since the early 1990s or even before. What's different now compared to then is the level of precision that we can achieve with our technology. Ensuring the sensors are consistent, ensuring our conversion to density is accurate. And again, that's something probably more from a quality assurance point of view. You can still get good, useful information for quality control without that, but that's critical that conversion is correct, because it's going to be applied to all your data, which is thousands and thousands of measurements. Ensure our routine collection has the necessary coverage and is collected correctly. And then we've mentioned multiple times, proper training is everything. And then I'm going to end with some specific umbrella topic questions I thought were of interest that need to be kind of discussed as a group. And keeping in mind that, you know, going into some of this more difficult stuff, we got to keep in mind that even though it's hard, it's worth it, because density is such an important factor for getting long-lasting pavements. So first one, we have a specification out there that's been referenced a few times for our surface reflection method. So this is what's used in the field, and just showing kind of the evolution of the technology and how it's improved over the years, and having a spec in place that says as long as you meet this spec, you should be in good shape in terms of what technology you're using to get a field dielectric measurement. We've also have a draft specification for a similar spec. And again, we have supporting data to back up the method itself, showing kind of better single and multi-laboratory variability scores than some existing accepted technologies. So we're definitely there from a repeatability point of view with our dielectric measurement of gyratory compacted specimens. But we still have work to do there, in the sense that moving forward, how are we going to handle either multiple pieces of equipment with different center frequencies, which could be because it's different vendors and allowing or not allowing different vendors on the same projects and all that kind of stuff is something just to keep in mind with regard to making sure the correct equipment is being used. For example, not using the 2 gigahertz antenna for half the project and 1.5 gigahertz antenna for the rest, because you should expect different results that have nothing to do with the pavement itself. Ensuring the sensors are consistent. So we want to be measuring pavement density, not sensor characteristics. And initially we started and had success with repeat line tests and swerve tests. And now we're moving towards what I think is a more powerful way of doing standardization, which is having a known golden material that basically forces all your sensors, whether there's any issues that have been mentioned today, it should show up when we do our measurement of our standardized blocks to make sure from day to day and sensor to sensor you're getting consistent dielectric results. And again, we've been able to test that out with some repeat measurements following the protocols that Fabricio developed. And at this point, I think it's worth showing some results. Here's one of the larger shifts for the 2 different sensors at the core location shown in this black line versus the 4 repeat measurements without standardization. And you can see the huge improvement. And I'm just going to cycle through quickly. You don't necessarily need to see it in minute detail, but big picture, just what happens before and after standardization, right? So it's one thing to show a summary, but showing the actual profiles before and after standardization, before, after, you can see just consistently when we standardize to a known material, we can take these asphalt profiles and just really tighten things up, which is critical for moving towards use as an acceptance tool. And that's just day-to-day variation or within the same day. Okay, just the kind of progression of things that Di mentioned at the beginning of the day with regard to our dielectric to density conversion, going from a more constructive approach of cutting pores to develop our curve. Again, something that's been around since the 1990s to kind of a more controlled method of taking these gyratory samples that we have to compact anyway on our projects and develop these curves day to day. And one thing that I think we need to keep in mind, especially with technology that's not mature yet or fully mature, is that there are certain things that we have to do today that hopefully we don't have to do as the technology matures. So I look at this plot and I think about Rich Hamilton's question before about, do I have to set up all my labs with MDMS equipment? And the answer is maybe. And in order for us to say no, we need to have the data to show why. And so I would look at something like this, which is multiple different days, multiple different mixed proportions that are slightly changing within that mixed design from production day to production day. From a dielectric perspective, it's not changing. So, one way to do this is to just take those pills that you're already making anyway and shoot them for dielectric, 1, to see if there's any change, or 2, as another quality control type measure of your mix, and it's valuable enough for that. And I think Joe Sias will get into that tomorrow, but The other way to attack this would be just to say, I know within certain tolerances of changes in my mix, it's not going to change dielectrically and go that route too. But for now, the way we're doing things in Minnesota is if it's a DPS project and you make a puck, shoot for dielectric before you dump it and get the measurement. And as Matt showed, the same person who's fabricating the puck can fit that into their day. Of course, there's probably busier days than others where it's a pain, but the way it's working right now, it's something that's doable. Validating to cores is, this is kind of the standard, which is also something Rich Hamilton mentioned with his questions is, taking your device, going to a spot where there's going to be a core and do a distance controlled core mode measurement and hope that it fits your line that you created with your dielectric to density curve from the pucks. That's logistically not that easy to do all the time, one. And two, not always completely accurate. There's been observed bias at times between what we see with our pucks generated curves and what we see in the field. And so one thing that I'm looking into and UNH is going to take a look at with us is, we have 32 states doing percent within limits with cores, where you assume a normal distribution based on your measured standard deviation and measured mean density. We're actually measuring the full distribution of dielectrics when we do full coverage DPS testing. In this case, just as kind of a down and dirty method, I just took the density or the dielectric mean and dielectric standard deviation, computed all these statistical measures, and you basically have exactly what we're creating with the pucks, which is a relationship between dielectric and density, except in this case, it's fully a function of field measurements. So this is just field dielectric measurements relating your low percentile and high percentile dielectrics to the equivalent percentile densities and using that to convert to density. And now, in this case, your limiting factor is actually how much you trust your histogram that's created by the cores itself, right? Because we have full coverage dielectric and full confidence in our dielectric distribution, but you got to have enough core samples to trust your histogram generated by your mean and standard deviation from your cores. So that's just another way to potentially look at it that kind of eliminates the need to do those spot checks where you just use purely field information. And again, going back to some of the results where you see a little bit of a bias between our field cores shown in gray there and our laboratory pucks shown in orange there. That's something we need to continue to look into. And, as part of this study, we've tried to look at moisture tests and trying to get an idea of presence of moisture. Well, it turns out dielectric is more sensitive to moisture than any of these moisture meters. Looking at potential cause of bias being caused by an incorrect input of the puck thickness, because it's really sensitive to the height of the puck, and at least for design voids, for sure, the error caused by issues with your thickness measurement don't give a smoking gun, at least reason for some of the bias we're seeing there. Temperature, Monica kind of touched on this, at least with field measurements, about a tenth of a dielectric per 100 degrees, which doesn't explain some of the bias we've seen. And then for the lab measurements,
about 0.08 dielectric per 100 degrees. And we're continuing to look into this. One thing we're doing with the data that we just collected at the end of this construction season at Min Road, where we have cores every 10 feet, and we did the Fabricio prescribed data collection method, is let's just see, one, how our distribution of cores compares to the distribution of dielectrics over those 200-foot sections, but then also look at it on a spot check level for the different thicknesses of the top lift. So see if it's potentially a function of the dielectric being more sensitive to the top of the lift than it is to the bottom of the lift as a potential explanation. So we're still looking into that as part of the current pool fund, and we'll have some findings, but I think that's going to be an ongoing thing that we need to continue to monitor. Routine collection sounds routine and easy, but it's a difficult thing to accomplish. You can talk to Mercedes or Rich or anybody else who's collected a lot of DPS data. It's a critical factor to successful measurements and information in general. And we put out some training videos and tried to get protocols together for that, and done the same for our measurements with the laboratory. You know, like don't forget to put your metal plate on top, simple stuff like that for the measurements of the pucks. And then, of course, training in various contractors and getting together finally in person as a group last spring. We got to think about, okay, how does stuff like this continue to happen? That seems to be pretty critical to the success of this method. Getting people together to share ideas. So that gets us to the last part here, where I just took a couple questions from our umbrella topics section that I thought were interesting that need to be addressed moving forward. Is, you know, we've already had some discussion of, you know, what analysis tools do we need to look at moving forward? Are we ready to take the plunge and train up our personnel and get into Veda exclusively? Do we still need to supplement it with support for more on-site tools? That Veda is not there yet. Apparently, they're going to go to the cloud in the near future, or focus on some more Excel-based tools that the group can use. You know, Brian Diefendorfer was using some nice Excel-based tools with his analysis in Virginia that he shared with us at Technical Work. Something to think about moving forward, how to support data analysis moving forward. Equipment use, data acquisition, safety, equipment ruggedness. That didn't make it on the top 4 for our umbrella topics for the technical working group, but it's a difficult thing to do. And so the question is, how do we continue to give contractor perspective and agency perspective of how implementable current equipment is? And then on top of that, getting personnel trained and able to collect the necessary data for full coverage assessments. So for an agency to say, yeah, we want to invest in collecting this data, you got to know who's collecting the data and how they're going to be able to accomplish it on top of their current workload. And we've already had some of that discussion that needs to continue. Is it a contractor thing? Matt says no for now. Is it an agency thing? Is it consultants who can service agencies or contractors if they're the ones who are supposed to do it? How can we support this once the pool fund is over, if need be? These are questions we need to ask. And again, what are vendors making? Can it meet the agency needs? And this is peer exchange type stuff, and we're going to hear from the vendors tomorrow, but also start to think about how this can continue beyond December next year.
and how, the segue is working for MnDOT when the agency's collecting it, but, probably not a long-term data collection for full deployment tool. GSSI is looking into robot collection. We're dabbling in it with the University of Minnesota. Vehicle mounted, all these different ways to collect data. We got to continue to find something that's implementable. And of course, awareness, promotion, and all that kind of stuff is going to only be more and more important as we get closer to being deployable. And, we're putting together digests, and a flow chart is in the future of the pool fund that will develop. But then past next year, how do we continue to spread the word? Like what was said before is half the contractors or 90% of them don't even know that it exists. So that's something we got to try to address as a group. And that's what we're currently doing with the pool fund, but that's kind of what I had for some of the more major what's covered, what needs to be covered moving forward questions. And then with that, I don't know, Brian Hurt was supposed to be here in person, but he got sick and he saved us all the trouble. I was going to have to sit next to him, so he saved me the trouble of getting sick. Although I got a little bit of a scratch in my throat, I shouldn't say that. So anyway, Brian was going to lead a little bit of a discussion at the end of the day here. Good thing he doesn't have feedback anymore. He had feedback back at the beginning. But anyway, do you feel comfortable leading that remotely, or do you want me to try to use the Google spreadsheet that you have been kind of working on throughout the day for this part?
Sure. Well, thank you very much, Kyle. And it's been really a great combination of presentations and discussions and questions. And I think most likely there's going to be more of this type of planning going on tomorrow than today. I think it's important to not lose track of what's been happening now, with the understanding that really it's sort of the when you set the table at the beginning of this discussion, you and Jeff and Di together talking about what more or different should be done in the final year of this phase of the pool fund, and what other things might need to get done potentially in a follow-up phase. And those are similar but not identical questions of looking at different issues and possibly different time horizons. This is just, sort of scratching notes. My colleague Katie is sort of taking full detailed notes for the purposes of our reporting on what's happening. What I've been trying to capture are, based on what I'm hearing, items that might feed into, again, future research plans, needs for different working groups, or what the working groups should be focusing on next. Are the topics the right ones? And Kyle, I think you already started this with the power. I hadn't seen your final PowerPoint, but I think that was really spot on with that working group that didn't get formed. That was a sort of a top topic that didn't bubble to the very top. I think it's certainly fine to put what you had shared on the screen back up if you'd like.
You want the notes from the day or the end of my last presentation?
This is fine. And again, what you've just shared, thank you very much. And this is not necessarily to litigate now, but to be sure that if there's something that anyone in the room feels like they want to be sure gets discussed under future needs, or needs to be discussed under what do we need to do in 2023, we should try to get it put up on this page more as a, let's not forget we talked about it on Wednesday. Not so much that it needs to be hammered out or voted on. I think that's a tomorrow topic or possibly even a down the road topic. But, you know, you'll come back in the morning refreshed, but with the less clear picture of what we talked about today. So, Kyle, since I'm having a little trouble hearing everybody, it might be easier for you to lead a bit of a brainstorming discussion of, you know, what are topics we want to be sure get included in tomorrow's wrap up.
Yes, great.
Does that sound good?
Yes. So for example, Irv had some more thoughts on the GPS accuracy issue that I see you have jotted down here. Just to use that as an example for what we're trying to accomplish here, do we want to use this opportunity to further discuss some of these issues or make sure that we have a placeholder for them so they do get discussed tomorrow? And the reason being, we're going to hear from the different states. We're going to hear from Fabricio. We're going to hear from Joe Sias from UNH. And there's some additional perspectives that are going to be presented tomorrow that might also feed into some of these questions that we already have here. So I guess my question for you, Brian, is do we just want to do our best job while things are fresh in our head to populate a list and then adjourn, or do we want to also discuss some of these topics now?
I would say, generally speaking, the first of those two things.
Okay.
However, I understand there might be an industry event tomorrow that will preclude some people from participating. And if that's the case, if anyone in the room or online won't be available tomorrow, I think I would invite those people to share the perspectives a little bit more, or how they, you know, might choose to direct things, just because this is our opportunity to hear from them. And others, maybe if you know you're going to be around tomorrow, you know, maybe save your viewpoints on things or your argument for what direction you think this group might take. Again, that is going to be an agenda item towards the end of the day tomorrow.
Yep. No, that makes sense. Okay, so I'll go through here just to, because it's not necessarily easy for people to read, just to show what we've kind of developed throughout the day, where we definitely had some discussion early on about cloud data and use and making sure we have the right type of data. Oh, thanks, Brian. We have the right type of data going to the cloud. So one trade-off that Roger mentioned is if we send all the data and metadata to the cloud, it becomes more expensive and time consuming. So maybe having some time set out tomorrow to talk about best use of cloud for end use needs. GPS accuracy was a big one, and that was a lot of discussion, which I think probably also needs to be put into context for our cloud discussion. I think it was Irv and as well as a number of others said, well, this needs to be tailored to the end use of the data. And the cloud question is probably similar in that way, in that if you're going to invest in bringing all the piano with the exported data, let's make sure we're actually using all that extra data that we're pulling to the cloud. Same thing with GPS. If we're going to go through the headache of getting RTK precision, let's have a business plan that justifies the use of GPS accuracy and extra.
Kyle, as we're going through this, could you double what you have on the screen again? Because we're having difficulty at this end of the room.
Yeah, Brian. Yeah. Is there any way to make that just view to widen the? I'm still a Microsoft person.
That would be just to zoom in on your own browser. In the three dots in the upper right corner, you can increase the percentage of your zoom. So you see 100% towards the top. If you right click, it should zoom you in a little bit further.
Oh,
there you go.
I'm gonna be technology savvy here at some point. All right. Thank you. I can always count on Herb to speak up. Thanks. So I think both of those things are gonna be critical, cloud usage and GPS accuracy, and both have similar kind of framework that we gotta evaluate them from, that were discussed a bit today. Is there anything else related to those two things that I should put on the list to make sure it gets discussed, argued, litigated?
Maybe you're saying it, but just how the data is going to be used, I think is a very important part, right?
Yeah.
And I don't think it's just going to be used for one thing.
Yeah.
So there's going to be sort of some different roadmaps, if you will, of what you need to get to that end result. And
Parallel
for instance, the 3 sensor, think about coverage, right? There might be some jobs where you want to get full coverage. There might be others where you don't care, right? CNV doesn't give you full coverage. So think about it from that scalable perspective where you might want to get density numbers on every state job, but the longer, bigger ones, I want full coverage.
And that's something that Matt Oman kind of talked about in his presentation is, if we weren't forcing him to get full coverage data, he'd never go out there. And
it's not practical.
Yeah.
Or what tool you use to get that, right?
Yeah.
Whether it's a single sensor that you're grabbing data here and there, it's something on a Segway, on a robot, on a machine.
So should I be calling parallel roadmaps or whatever you're talking about where you have different use cases? Should that be its own bullet almost? That
I mean, at the end of the day, that's what you're after with this group, right? Is to nail down how this technology is going to be used.
Yeah.
And I think they're going to have a lot of similarities, but they're going to have a lot of differences.
Yeah, because ideally in my mind, I'm thinking, okay, let's QC until we're ready for QA, but those don't necessarily go in.
Yeah.
No, that makes sense. Brian fixed my stuff there. Thank you.
Even your QC may look different depending on what you're trying to do with it, right?
Yeah, absolutely. Down to, are you correlating, how accurate do you need it to be, right? I mean, if you're gonna run without RTK and without any correction, and you're just gonna go out there and gather some data. Think about that, just cheap, simple solution versus pull it all out. You've got a robot autonomously following the paper or rollers.
Right.
That ties into what Herb said earlier about project selection criteria.
Okay.
Thinking about what the project is, what the needs are for that project.
That's a good one.
It can even be tough mixes and stuff, right? There's a lot of these that follow basic paving practice. You should be getting density out of ambient tough cases, whatever.
Yeah.
And granted, a lot of those are the day of, but it might be certain mix designs that, you want to see full mapping of the density because it's tough to get.
Don't mind me, I'm just gonna type a little bit here. And then also I was looking at it from at first when you said project selection criteria, I was thinking more, what you said is more where are we getting the most bang for our buck for getting that full coverage, but then there's also project selection criteria that Matt was talking about on where can we actually adequately get full coverage data, so whether that's traffic control issues or, for me, more dense graded the mix is, the better results we're getting. So it could be more geared toward what are the projects where we can expect to be successful with our assessments too.
You could also tailor bonuses to the percent of coverage on the job. So the contractor is going to go through the work to give you 100% coverage of what they pave. They have more opportunity to get.
Say that again from the beginning.
So if you were, or you can just type in your.
No, go ahead. I'm done.
If you have a contractor that's fully invested in technology, they're going to go all out and give you 100% density coverage.
Yeah.
Right. Versus one that's going to go after, I'm going to I got a card with one sensor, I'm gonna run it down a little bit if I'm
Yep.
only 10%. Then you only have the opportunity to get 10% of total bonus versus the other one that put in more effort and more.
Coverage-based bonus. Yeah. And we kind of did that or simulated that with Matt on the project where we said, you know, here's what we'll pay per 500-foot section, and now it's up to you how many sections you're gonna give us, right? So,
You could gamble too and put deductions in there.
let's go with incentives first.
So when I was with the Eastern, we developed specs
Okay.
like that, based on coverage.
Okay, so what should I call this?
For QC. Makes sense.
Coverage-based incentives?
Yeah.
Okay.
And maybe that's just how you implement it, right? You're not gonna force anyone to do it, but people who wanna play that game can go after that bonus.
Right. Interesting. Obviously, we're gonna need a good edit here, because I think my last thing was give more data, get more money.
And then Kyle, this is something that you mentioned a couple times about having a calibration standard.
Yeah.
And being allowed to think for a while back here about nothing else.
You're not paying attention to the other stuff, or what?
Well, yeah. Do we need more study on, does the calibration standard need to be calibrated?
Ha! Yes. Where's Chuck Oden? Is he still here? Okay. All right. He was looking at NIST traceable standards for dielectric. And it turns out like a little piece of dielectric material that's NIST traceable is impossible to get your hands on. So, but that is exactly something that is, yeah, that needs to be included moving forward, because, I mean, Roger's shaking his head because, you know, most materials are somewhat frequency dependent. So there's nothing less constant than a dielectric constant. That's what I.
Well, and I was thinking of, you know, you've used it on individual projects where it's very easy to use one piece of fiberglass on contractor unit and the agency unit, but then as dispute resolutions and Beverly will come in, and especially if you start using this for acceptance.
Yeah.
What happens if central lab comes out versus the regional lab or the district lab, and then you have that further complication. It's who's right.
Right. Chuck. Irv brought up calibration standards.
I'm gonna talk about it tomorrow.
He's gonna talk about it tomorrow. All right. So this reminds me, because I want to go in the weeds all the time, and so does Irv. We need to get it on the list and then move on. So if I start talking a lot, tell me we got to move on. So we got to move on. So calibration standard, it's on the list. Chuck's going to talk about it tomorrow, and then we're going to talk more about it at the end of the day tomorrow. But I did want this last bullet. What'd you say? You said what was your last comment? Yes.
Yeah, universal.
Well, in this topic, we're talking about is the came up standard, the DPS equipment. So the certification process can be, the different equipment can be used against the standard equipment, just like the condition profile. Not sure it's possible or not possible.
Okay. Golden, just for now.
Yeah, golden.
Yeah, golden.
Because when we do the certification, we want to use the weapons against the golden equipment. So pass.
Okay, for now, that's a great point, Di. For now, I'm just gonna have a bullet there that says golden profile data, appropriate use of Fabricio's work. Because we've done, you know, work towards that direction, and Dennis has commented on, and this group needs to talk about how do we use that what does it look like in implementation? So. You happy with that, Di?
Yes.
And I got half of a sentence here. This was tailoring what tools are used for.
For what purpose?
That's kind of, yeah. Okay, are the current 4 umbrella topics still the right ones? For example, I had a slide where it looks like equipment ruggedness and use of equipment and getting it to a point where it's implementable almost needs to be, there needs to be people talking about that, I guess, let's just say that for now. Is there anything to add about equipment ruggedness and things of that nature for now? Hearing none. Well, this is one I put on there. Coming the end of the next December, I don't want to see examples like what Forrest gave, where he's comparing DPS with other intelligent construction technologies to all of a sudden go away. Like, to me, the more we can see examples like this, we're going to find different usefulness, different ways DPS can be useful to improve our construction operations. So I just wanted something in there as a placeholder. How do we encourage continued use of DPS to improve our paving operations? And that's kind of generic.
So Kyle, one that's helpful on that is just a simple fact sheet somewhere that shows who's using it, how many jobs or how many lane miles have been used with it. Because as you build that momentum, other contractors start to think about, or they'll look at, all right, somebody in my state's doing it, and they'll go and talk to whoever. I think about like the IC maps that we have. Something similar would be helpful.
Yeah, I was just gonna add to that, somewhere in all this, I think at the end of it, we need basically a 2-pager working point, like, and it's taking all this research, all this data, all this stuff that we know and learned, and literally, in my opinion, putting it in 2 pages. So I'm an agency or somebody I'm looking at wanting to adopt this or implement it. I know nothing about it. I just heard a little buzz about it. Sounds cool. I want to learn more. And literally, like I say, a 2-pager. This is DPS. This is what it can do for you. Risks, benefits, implementation plan. You know,
I love the idea of using other intelligent construction technology as the template, you know, for that. And I almost could see a DPS digest. Todd. And let's put one together. I think that's a great idea. Okay, but I'm going to write that down and then we're going to move on. Okay.
With the fact sheet, can you add a contractor in there too?
Yeah.
That way they can just reach out to the contractor. And it ways messages, marketing is different. I think that much is direct. A lot received a lot differently from a contractor to contractor versus agency or federal highway to contractor, right? So we can say they have the same message and it's going to be received very differently. So it's really great hearing from contractors and consultants. Yeah, for the contractor, this is how you can make money with this tool.
Yeah.
I have an actual draft written up for contractors, how to implement DPS as a QC, using it as a QC tool rather than assessment. Because I've had people ask me how to do it as a QC tool, so I've just actually wrote up a whole article on it, but for procedures and steps and stuff, so I can share that.
Yeah,
for contractors.
Well, we might have a lot of issues at the DPS digest, which is good. Technical / operational issues, sensor dropouts, sensor angle, core measurements in the field. Do you use the time control versus the core density or the core distance mode? Yeah, this is something that I think Rich Hamilton brought up.
So sensor angle, and I just don't know from a technical standpoint, but is that the same issue or thing where like Forrest was talking about going through super elevation?
Probably,
Or
I would
is that
guess.
not the issue?
Yeah, although I guess with the super elevation, if your whole, if it's just a rigid body motion, it shouldn't be any different. Who's talking? George?
Yeah, and you do have the DPS height.
Yes.
Well, the high-speed profile, I mean, there's a similar.
Oh, that's another story.
That's a different one. Okay.
Different one because
Okay,
it's no longer pointing vertical.
Yeah. Your radius is so big, it shouldn't matter, but it probably does.
Yeah.
If it's 0.3 degrees, you're probably seeing that off 4 or 5 foot.
We're going in the weeds, Todd.
Yeah, I know.
Any other comments on that aspect? Make sure we get that discussed tomorrow. Need to do correlations on a daily basis. That's something that I had in my presentation even before Rich brought it up. Is, you know, really tailoring. My instinct as a researcher is to collect everything and analyze everything so we know if we need it or not. But for a deployment point of view, we need to be smarter about if we're requiring something, there better be a good reason, I guess is one way to say it. So,
Yeah, Kyle, I mean, like for state, like we're that doesn't do volume metrics every line. That would be a pretty big.
Yeah.
Pretty big thing.
Yeah, because we're just testing what we're fabricating anyway, but you guys would have to fabricate just for that reason.
A lot of our projects have been love in place on our. We're not the only state like that.
Yeah, right. All right. Is that enough? It's not just you guys. That's enough to get the wheels turning tomorrow there. Training, yes. So I just did a demonstration with Rich Hamilton about establishing lateral offset, and Matt Oman can vouch for me on this. I still, when I go out there, I stand on the center line. I look up station and then I put my hands up. Okay, that's left. That's 6 feet left. Because you're right, that's an easy thing to screw up. And again, you know, we kind of discussed that's another thing where RTK precision makes that something where it's almost unusable data to, it's just a headache to go back and fix it. Because if you have RTK precision, even if your user puts the wrong offset in, it's still mapping to the right spot, right? So just something to keep in mind there. Yeah, basically, in my mind, I look at this and I say, just ways of continuing communication between users and vendors, in the sense that, you know, it's one thing for GSSI or Chuck or Science Systems to get calls from individuals randomly versus having some time to talk with users to see if things are, you know, common issues that are worth investing in correcting. So is there a way in the software to make establishing ladder offset easier? Probably not. Is there a way in the software to make it easier to get stuff fixed in Excel later? Probably. Are you going to do it? it's probably a function of how big of an issue it is for your users or not. So, so maybe just as a note, here, training slash lots of questions about beta. Anything specific we should put under this bullet to make sure it gets discussed tomorrow? Okay. Linking data and intercommunication, e-ticketing, plant, contractor, etc. I think that also has to do with beta. And also, I think some of the standardization that I know Rebecca's group is doing with trying to make sure all of the data meets a certain bot naming convention and all of those sort of things. It's something we need to make sure we discuss, because I think for all these different intelligent construction technologies, there's an overlap that we need to be consistent with our terminology to link the data, I guess. Bryce brought up the scoring system for contractors. Basically, the means getting contractors to use the data. And then Irv had mentioned kind of the need for a tiered beginner, intermediate, advanced training for beta or other DPS analysis tools, and that kind of fits almost a little bit with the parallel tracks that we talked about earlier. You know, a lot of this stuff is a function of I'm not even at the top yet. Parallel roadmap. So how are we going to end up using the data at the end of the day? And there's certain things from an analysis point of view that if you're the guy pushing the cart to collect the data, there's a different training for that person than there is for the engineer who's taking a look at multiple projects in there.
Well, I think too is that what Bryce brought up in this tiered system of training, I think they're tied together, is that you need some way as the data is being collected to indicate to the lower tier that something's happened. And if it's within a certain criteria, then they have to act. And then the second tier training is when they hear the next level up, when they get a report from the field that something's happened, so they know how to react. So they don't have to influence this third tier why the first two steps weren't taken.
Yeah, I think I see what you're saying.
Have no knowledge of anything like that. Never in dispute.
You're referring to data quality?
No, I was referring to things like they were teasing out about earlier. And you look at the data and you go, damn folder didn't roll the map. You know, so when Matt's going down the road and he sees the dielectric drop out, it's like, yep, this wasn't rolled. Or if it goes sky high, whoop, we got water here. Why do we have water here? You know, do we have a roller leak, or is there unknown water underneath the pavement that we need? You know,
honestly, even just moving the drums. I mean, that's
interesting
too, right? That makes sense that there'd be water, moisture there, and
why does the GPS say I'm supposed to be over here and I'm actually over here? You know, that's we're going up in some ways. Move on.
You caught yourself. We are through the list, and we've.
I'd like to point out, Kyle, there were some comments in the meeting chat.
Oh, great.
If you want to
pull those up.
Pull those up.
Okay.
You might scroll up a bit. Dale had a couple, and then one from Hoda.
Okay, great, yeah. So Dale says project selection criteria could include lift thickness, limitations, type of roadway, like interstate versus collector. Yeah, so Dale's thinking on a similar scale to I was, which is basically what makes the project appropriate for DPS use or more likely for success. Maybe we can copy and paste that into that bullet. Does UNH work on using dielectric for specific gravity fit into the discussion? Seems like could be low hanging fruit application. Yes. So UNH is actually going to present on some of that work for using the laboratory dielectric measurements for specific gravity. So Joe will have more to come on that, but I think we'll add that as a bullet, Dale. Thanks for those comments to discuss further tomorrow. Hoda Azari says, how about monthly webinars with DPS focus as a peer exchange for states and contractors? That's aggressive, monthly webinars. I like the idea, so we can put that as a bullet and discuss frequency of how often they're done and who's giving them and stuff. But yeah, that's definitely something that should be added as another bullet. Are you doing that, Brian, or should I?
I went ahead and pasted those in.
Thank you. It's already done. You know, Brian's so detailed, he actually texted me that my laptop's running out of battery in the middle of the day today. So that's just a plug for CTC. They're pretty good at what they do. Great. So we have a lot of great bullets to discuss for tomorrow. And if you don't speak now, you still have a chance to add them tomorrow. We said 3:30 or 4. So you do technically have 22 minutes if you want to add anything else to this list. Or we could end this and then I could give the floor to, oh, yep, here we go, Chuck.
I just have a couple of questions that might be detailed, so shut me off.
All right.
One is, I know this has come up before, just thinking about data and making things. I think there's a reason that the mixed calibrations didn't go in automatically. That was going to be by the user, by the data user, and since we already have that information with the DPS surveyor, maybe that could be an automated step. I think the backer told me there was a reason why that is. It's just something that we could add to the import to make it easier.
Yeah.
And then I wanted to know a little bit more about the cloud and who's going to manage the storage. Data version, which would be a T set to manage their own cloud server, some of the related needs.
Don't have to answer them now, George, but they're on the list, so be prepared. Yes, those are really good.
Forrest had the slides talk about the improvements.
Ah, yes, yeah. So Di has a screenshot of Forrest's. Forrest had some good slides about the software and improvements that way. So let's say we should discuss Forrest comments on software. Oh, that's good. Okay, sure.
This might be off topic, but if we're gonna have contractors collect the data, do we have to put in some kind of parameters for that? Because I rented my pay scan out to a contractor doing density, and they put the back of the pickup, they're dragging it backwards down the center line about 20 miles per hour. Then you know for a fact contractor, you're gonna find a way to like, is that it wasn't even good data. So do we have to put something self-propelled? You know, so that you're getting good data.
Right.
But the truck was driving down the road down the center line. He was pulling it backwards, sitting on the tailgate, trying to keep it on the center line. I I swear.
You take a video?
No, but I wasn't very happy.
So Bryce, along those lines, I think you're better off trying to put a box around what they want from a data standpoint in terms of its quality and how much, and not tell them how to do it, right? They want to do it and they're gonna get garbage. But what I'm thinking about too is the safety side of it. You aren't gonna want to tell them that they need now to have a person that's gonna walk a machine down the highway to get full coverage. Just from like a pure safety standpoint. So the moment you just say, okay, here's the data we need.
Yeah.
Figure out how to collect it, you exclude yourself from that.
Right.
Now, you can make recommendations on it and stuff, but you definitely don't want to say like, hey, you need to have someone walking this machine this speed down.
I thought previous discussions, the various vendors stated maximum collection speeds, right? So.
Well, like specifications like the bowlers have, must be something, that frequency, things like that, you just give it parameters.
Right.
Because it's gonna happen here.
Parameter's not a recipe book.
Yeah.
If they don't collect data in the way that's specified, we're risking getting bad databases. And like you said, we say this is what's required to get good data we want, but
Stay away from like a method spec. And
Yes.
focus on what you do.
fine, I'll use method spec, not recipe.
I do got the thing. Spring flag.
Oh. Okay. Good. Any other
And-
bullets? Go ahead, Brian.
Well, I have something I'd like to say when we're done collecting these bullets, so I'll let you see if there's an answer to your question in the room.
I'm still squeezing juice out of the fruit, Brian.
Okay, that's great.
I don't know if there's any juice left, but I'm squeezing.
Actually, Kyle, it's a sensitive issue to put safety or in any specification. You gotta talk to a lawyer before you do that.
Yeah.
And I've been developing a lot of AASHTO as well as the ASTM standard. The always disclaimer, this standard doesn't specify or address any safety issue. So you have to kind of separate yourself from doing the safety from any of the specifications.
So if they're pulling the DPS behind their truck, swerving in and out of traffic, we have the disclaimer that says.
You get a call from the lawyer.
We did have somewhere already about how to know if we're collecting good data or bad data. Right?
Yeah.
That was already.
Yeah. And that I think probably was also in Forrest's comments, but I'm not sure we specifically said that, so I'm gonna put it as a bullet. Okay. Any other bullets? Brian?
Kyle, is there anything out there on the spacing between measurements, when, the distance, we want data every 6 inches, we want feet, 10 feet.
That's a great
Is that
point.
existing?
So
It's in the standard. It's in the standard.
it is.
It is in the AASHTO standard, PP 98.
It is, but I think that's something that needs to be reassessed in the sense that we're kind of specifying based on what existing technology is, not what we need. So what I'm trying to say is that, based on what Brian said, we want data at least every 1.5 feet in the transverse direction. If it's, throughout the map, we need data exactly 6 inches away from the joint, plus or minus a couple inches if it's a joint. In terms of longitudinal spacing, if it's a legitimate measurement, every 12 feet, might be acceptable. It's just that we specify every 6 inches because we're collecting continuously anyway. But that might come into play if there's robotic, type applications become available, or, some other just transverse measurements every 10 feet or so. So I think as a group, kind of establishing a data density that's going to allow us to do the assessments we want to do.
Right, AASHTO,
Yeah.
AASHTO standard for IC and PMTP all require 1 foot by 1 foot density,
Yeah.
longitudinal or transverse.
Kyle, how'd you come up with that transverse spacing on your multiple sensor systems? What's
Great
your
question.
rationale for that?
Footprint.
Yeah, it's based on the footprint of the sensor itself, but then also achievable, right? So, right now, we know if we have a 3-headed DPS system, we can collect at least every 1.5 feet between center of each sensors to get our full coverage. And we're also reasonably sure that a contractor can look at that and say, okay, I'm going to do really good on those lines where they're evaluating me, but not good at that 1/2 foot in between the footprint of those sensors. Basically trying to minimize the risk that there's an issue that we're not covering. But
you could have argued 2 feet would also.
You could also argue that 2 feet could work, and that's where this kind of comes into play, where we need to have a criteria based on how we're using the data. And in addition to, are we able, we could spec every 3 inches because we want it, but we're not going to get it. So, it needs to be also what's achievable too. So,
Do you think we have to decide that we're comfortable with going from less than 1%, presenting a map of density? 10% is even a big jump, 1%. So what's the minimum to where, because we got to dip the people's feet into this slowly increase. If we go from less than 1% to 100, it's going to happen. I mean, it's going to just get. I personally, I think that's part of what's going to be the state-specific specification. I mean, Minnesota already contractor here is a lot more familiar than other states, and so maybe it makes sense to collect a higher percentage versus just going to be that percentage might be very, and then also the nature of the project.
And I think about it the same way. Maybe it's because I have a different perspective on it, but you really breaking it up between QC and QA makes it drastically different in terms of what you actually need. Thermal is a great example of it. Thermal behind a paver, the resolution that we can provide is so good that it shows you that you have parts that are wearing. But when you load it into Veda, you don't need that level of detail. And it's the same with this. If you're checking, you're lucky if it's 1% nowadays. That's like the bare minimum, right? This is just a new technology looking at that. But if you're comparing it with IC data and looking for other problem areas for, we were paving a couple weeks ago here, right? And it's cold. Okay, so this ambient temperature and on, we want to see this percentage of map versus summertime when you're getting densities a lot easier to jump all the way to it, even though it's easy enough once you have the technology that can do it. Is it really necessary? And I think that was the only other thing I was going to add is, the QC versus QA broadens this scope so much that maybe you do need to focus on one part of it for now, but the value to a contractor is not the processing after the fact and them understanding why they missed the bonus and why they didn't. It's putting the data in the superintendent's hand or whoever's responsible on the job site, maybe the roller operator, to say, look, forgot to turn 5 on back there, or look at your roller pass is bad.
But that could be that feedback could be a function of looking at it after the fact too. So.
It could be, but they know they should have good overlap and that they should turn Vibe on and they know
Yeah,
all the
okay.
fundamentals. It's just, are they applying it that day? If they, even if it's a lunchtime review of something,
Yes, okay.
let's fix
Yeah,
sooner than later kind of thing.
yeah.
And they go hand in hand, but it's really hard to wrap your head around both aspects of it in this environment.
A lot of these tools for developers, you see, they think the QA on that.
Yeah.
But the majority of these were developed for contractors to force it and slowly. Assessment. It's. Consistent moving forward, we changed that previous
My
book
spelling's
to
terrible.
quality management versus acceptance. So we're using the new lexicon that certain people are suggesting that this is the way we should talk about those two items. So instead of QA versus QC, make that quality management versus acceptance.
I'm struggling here. There we go. Thanks. Sorry, Irv, can you summarize for a bullet what you just said?
No.
Oh, come on.
Based on QA versus QC,
Yeah,
change that to quality management versus acceptance,
okay.
or even QC and acceptance to differentiate between the two.
Quality management versus.
Acceptance.
All right.
Capital A.
Oh, come on.
No, you're gonna do it.
Do I gotta capitalize the M too then?
No, because as a contractor,
Okay,
as you said.
okay. Did I see you wanting to speak there, Steve Cooper?
No, I was just trying to help you.
Okay. He's a helps guy. This is typical of this group, you know, we ask for an inch and we get a foot. This is this group for you, Brian. There, I might squeeze a little more juice out before you get to your final talk here. Is there any last bullet? Okay, go ahead, Brian.
Great, thank you. This has been a really great discussion, and you know, it's tricky with brainstorming because you get a lot of stuff thrown on the wall, and it can be a little daunting, and it certainly is scattered. But it's a good thing, and really, I think there's a little bit of homework to give everybody, and it's nothing formal. But I'm just gonna, if you could scroll down, I pasted some questions be a little further. And that's really to just give some thought to each of these topics or topic areas, because the goal tomorrow is to really think about, well, this has all been great discussion, but what do we do with each of these things? And it might be something that is just an agreed upon thing that maybe needs to be communicated, but maybe it's not agreed upon, and that's fine too, but it needs to be discussed or better defined or possibly even debated and hashed out. And that could be done in a TWG that exists or possibly in a new one. And it could also be something that is deep enough that needs to be researched now or possibly in the future, or maybe isn't quite ready to be addressed and just gets parked to be addressed down the road. And it's really important for this group to continue to think about whether these things are within its scope. And it's, you know, scope creep is fine as long as it's intentional. And if this group decides something should be within its purview, then it should do it as long as it knows that it's taking that step intentionally. Again, it's too late in the day to start doing this, but I think it isn't too early to start maybe even kind of noodling these thoughts around for when we come back to this tomorrow. So I just wanted to throw that out there as a way to cap the brainstorming and think about what to do with all this tomorrow.
Great stuff, Brian. I am going to hand it over to Dr. Shantao Dai, and he's going to adjourn us.
Yeah, I don't have much to say. Looks like Brian gave us homework tonight to think about.
Hey, Brian, is that list of questions in the chat, or how can people access that?
I am going to drop it in the chat.
So now they can't say the dog ate their homework.
No.
I will drop it in the chat in a second here. Yeah.
I think we got a whole day today, and every people
tired, and tomorrow looks like we have full agenda, but we have more work to do for tomorrow. It's like for these topics and the future research. That's all I have to say, and then wish everybody a good night. See you tomorrow. That's all I have.
If you didn't sign this list, it would be great if you could put your name and organization on here.